Hello, and welcome to the world's best iOS development course. My name is Angela, and I've been working as an iOS developer for over 6 years now. And as a part of my job, I work as the iOS lead at the App Brewery. I also teach on our in-person programming bootcamp. Now, I will be your instructor on your app development journey. As a student on this course, you're going to get access to over 50 hours of HD video content, which contains step-by-step instructions on how to build over 25 fully fledged iOS apps. So if you're somebody who wants to get a job as an iOS developer, then this is perfect for building up your portfolio to show off at your next interview. On the other hand, if you're somebody who wants to create your own apps for an app business, then in addition to all of the programming lessons, I've also included full modules on app design and app marketing, so that by the end of the course, you'll know how to design, build, and publish your app onto the App Store. Now, this course assumes absolutely no prior programming experience. So if you're somebody who's never coded before, I'll be with you every step of the way as I take you from programming fundamentals through to more intermediate and advanced programming concepts. Now, if you're an advanced developer, on the other hand, then I've included tips and tricks for iOS development and also ways in which you can speed up your learning process. At the App Brewery, we have over 100,000 students worldwide. So that means you're never going to be alone in your learning journey. You'll get access to our private student community where you'll get to ask questions, get advice, find co-founders, and work together through the course. Now, as if all of that wasn't enough, you're also going to be able to download my 12 Rules to Learn to Code ebook, and you'll also get access to over $5,000 worth of design assets that'll help you when you start creating your very own apps. With over 17,000 5-star ratings, my iOS 11 course is the highest rated iOS course in Udemy history. And this iOS 12 course is going to be even better. At 50 plus hours, it's my longest course yet, and I've included brand new tutorials that cover the latest APIs that Apple has released, including ARKit 2. So we'll be using image recognition and image tracking to build our very own Pokemon app, as well as a magical newspaper app, just like the ones that you see in Harry Potter. We're also going to be learning about Create ML and Core ML 2, which allow you to use your own data to build intelligent machine learning models. And we'll be using that to build image recognition apps and sentiment analysis apps. Now, as a student on this course, you're going to be saving yourself a lot of time because all of the lessons are fully up to date with the latest version of Swift and Xcode. And all the videos are sound tested for HD playback. You're also going to be saving yourself a lot of money. This course has exactly the same curriculum as our in-person programming bootcamp. So instead of spending thousands of dollars and taking time off work, you'll get access to exactly the same curriculum with years of design and testing behind it to ensure that you don't just know what to do, but you also know exactly why you're doing it. Now, don't just take my word for it. Check out what my past students had to say about the course. So what are you still waiting for? Find out why over 17,000 students have rated this course 5 stars and what they've been able to build after completing this course. I look forward to having you on the course. As an enrolled student on the full course, you're going to get access to a huge bundle that we've compiled just for you. Now, let me show you what this bundle includes. You're going to get access to a whole bunch of icons, which you'll be able to use within your app. You're also getting a load of gradients, which can be used as app backgrounds, as well as HD photos and faces for avatars. There's also a load of Photoshop files for buttons and controls, as well as a whole bunch of app mockups in Sketch and in Photoshop. And finally, we've included app icon builders for iOS and Android, so you'll be able to easily create your app icons and export them in all the right sizes. Now, collectively, this huge bundle of image assets is worth over $5,000, but we're going to give it to you for free as a part of this course to make life easy for you when you're creating your own apps. Now, on top of this massive bundle of image assets, we're also giving you access to our highly rated 12 Rules to Learn to Code book that consolidates some of our best tips for how you should go about approaching learning to code. So once you're ready, if you head over to your course contents, you'll be able to download all of these files. All right, guys, so you've signed up to the best iOS development course in the world. And you're going to find out very shortly why over 17,000 people have rated this course 5 stars. But in order to get the most out of the course, there's a couple of things I want to draw your attention to. Firstly, the majority of the course is going to be dedicated to programming and learning iOS development. But there are also full modules on app design and app marketing, which will supplement your knowledge on the entire process of app development. So be sure to look through the curriculum to find these extra modules, and you can work through it alongside the coding tutorials. So very often, I find that students do best when they do a little bit of programming and then switch their mind to a different problem, such as learning some design skills or learning some marketing skills. So feel free to dip between the design, marketing, and coding parts of the course. Now, while you're learning iOS development, I tend to recommend that students code on your main computer. Now, this is just my recommendation, but I find that students benefit a huge deal if you can watch these lectures on a separate device. So that can be an iPad, or that could be another laptop, or it could be even a Windows computer. It doesn't really matter. But having the tutorial videos side by side with the code allows you to more easily compare the code and also code along and complete the challenges in the tutorials. Now, while you're watching the tutorials, I find that it's helpful to have a small notebook to note down some of the things that you might want to do a bit of background research on, or you might want to read up more on, something that's mentioned in the tutorials that you find fascinating, or something that you just want to understand more deeply. So having that there is also really useful. Now, at the beginning of the course, you should have already downloaded the entire syllabus. If you haven't, you can head over to the giant course resources list, and right at the top, the first link will be pointed towards this PDF. And in this syllabus, I've documented all of the skills that we're going to be acquiring as we're building apps and as we're progressing through the course. Now, I find that it's really helpful when students refer to this syllabus and just check off as they go along the things that they are comfortable with. So for example, in the second module, when we learn about the Xcode interface builder, you can see that some of the learning points include things such as how to size UI elements or how to arrange UI elements by setting coordinates. So I'm going to be showing you how to do this in the tutorials. And once you're certain that you've acquired these skills and understand each of the syllabus points, then you can go ahead and just check it off. Now, some of these things might require a couple of reviews. So you could mark it for a review at a later date, or you could come back to it. And that way you'll be able to keep track of the skills that you're acquiring, but also which parts need further review. Now, the coding tutorials were built so that it's a little bit like taking a hike up a mountain. And the slope is carefully designed so that each new tutorial builds on the previous one. So it's really essential that you don't skip coding tutorials, and instead you complete the curriculum in the order that it was designed. And this is really important because I know that when I look at a new course and I see something really exciting like learning machine learning, then I'm really tempted to just head straight there. But it's really, really important that you resist this temptation. Do each of the tutorials in sequence. Because of the fact that everything builds on top of the previous tutorial, then it's very easy to get stuck and get frustrated when you jump around in the curriculum. Now, in the course, there's also a whole bunch of coding challenges, and the challenges are there to make the process of learning iOS development feel a little bit less like school learning and feel a little bit more like a video game. So that means that there's plenty of small coding challenges dotted all over the course that are kind of like, the skeletons in your video games. You're pretty confident that you can slash them down. it doesn't take too many hits before you can beat them. But then there's also end level boss fights, and these are kind of meant to be a little bit larger of a challenge. So you'll be building an app by yourself, or you'll be completing a longer coding challenge. And this is so that not only can you prove to yourself that you've understood the concepts in the tutorials, but also just providing that little bit of extra challenge that makes everything a lot more fun and really tests your skills and pushes you to level up as a programmer. Now, for those of you guys who are learning programming for the very first time, then I tend to liken the process of learning programming to a bit like putting a puzzle together. Because in the very beginning, I'm going to be presenting you with the corner pieces, and then I'm going to give you the side pieces, and then finally I'm going to give you more of the center pieces. And at the beginning, it's very difficult to see the bigger picture, right? You're only seeing the outer edge. But as you add more pieces, as you increase your knowledge and your understanding of different concepts in programming, at some point during the course, you're going to have an aha moment where the picture suddenly becomes more and more clear, and you realize the relationship between all of these different programming concepts and how they fit together. So the important thing is to be patient, and if a concept is particularly challenging, then continue for a few more modules and then coming back and reviewing that same concept a little bit later on, so that by the end you'll gain a complete picture of iOS development and Swift programming. Oh, and one last thing. If you find that I talk too fast or too slow, then if you look at the bottom of the video player, there are settings where you can speed me up so that I talk really fast like this, or you can slow the video down so that I talk a little bit slower like this. So depending on which way you learn best, feel free to change the speed of the videos so that it suits you. So I hope that's helpful in guiding you through the course and a little bit of a sneak peek of what's to come. But the thing I want to emphasize is that you're not doing this alone. There's loads of other students on the student communities who you can chat with and share your experience, help each other. And also, I'm going to be here for you every step of the way. So in the next lesson, I want to talk about how you can get help at any point through the course. So see you over there. Hi guys, this is Angela from the App Brewery, and before we get started digging in and building apps, the first thing I want to talk about is how exactly does an app work? Because we all have it in our phones, we use it to do really important things like banking and contacting friends, but there's actually very few people who knows just exactly how an app actually works. So let's start off by getting an overview of that. Now, the first thing we have to realize is that smartphones are actually no different from just any other computer. And an app is just code that we write to tell that mini computer what it should do. So let's say we have an app that just has a single button on it that says click me. When the user taps on the screen of that phone, then the sensors in the phone register that tap and sends a message to the operating system, which in the case of an iPhone would be iOS. Now the operating system then looks at the data that it gets from the sensor, including things such as how much pressure was applied onto the phone, at which location on the phone screen did it register that pressure, and a whole bunch of different things and a whole lot of numbers. But the operating system takes all of those numbers and makes sense of it. And once it does, then it'll know that this particular button on the screen of this particular app was tapped at this time point. And then it'll send a message to the app in question telling it that, hey, this button of yours got tapped. What should it do? And so the code that you write for your app should specify, in this situation, when the button called click me gets tapped, this is what it should do. It should change what's shown on screen, and it should do this and that and that. So essentially, as an app developer, you're planning out all of the scenarios and what should happen in each case. So it's almost a bit like emergency planning. If the building is on fire, what should happen? Well, we should probably evacuate the staff, and we should probably shut all the doors to prevent the fire from spreading. Well, it's exactly the same for apps. What should happen when a user taps on this particular button, well, we should change the screen background to red, we should show them some other pieces of information, and then we'll wait to see what the user does next. And then there's a plan for how to respond to the next event. So there's essentially only 3 components to every single mobile app. There are the user interface elements that you see on screen. So that can be things such as buttons or images or toggles and sliders. And when we first build our app, we're going to set up the screen. So we're going to drag on some buttons, place it in a location that we think makes sense, and then add images or add other interface elements to the screen. Now, when those elements get interacted with by the user, say somebody taps on the button, then we've got the second component of the app that comes into play, which is the code. And this code is the plan. If this button called Click Me gets tapped on, then what's the next thing that should happen? Well, it's step 1, do this, step 2, do that, step 3, do that. But if the user, say, used the slider, then in our code, there'll be a section that plans for what should happen when the user uses the slider. And finally, most of the apps, especially if it gets more complex, will have data that's stored in the app. So for example, let's say we have a contact management app, right, where we have all the phone numbers of all of your friends and colleagues. Well, on the screen, when the user taps on a button that says, show me Bob's phone number, then that will send a message to our code, and we check through all of those lines of code to see how we should respond when the user taps on that button. And then the code will go into the data and fetch the relevant piece of data. So in this case, that's of course Bob's phone number. And then it's going to send it back onto the screen and display it on the screen so that the user now sees the telephone number of Bob. Now, previously I mentioned that a smartphone is just like a smaller computer, but there's still a few crucial differences. The first difference is that a laptop or a desktop computer is usually plugged into the wall, but a phone, on the other hand, is usually wireless. We usually keep it in our pocket and it's not always charging. It's also a lot smaller, so the battery gets depleted much faster compared to a laptop. Now, a phone also has less processing power. So if you try to play something that's really intensive on your phone, say the latest Far Cry, or if you try to run Photoshop on your phone, then it's not going to be able to do it because it has less memory and less processing power than your computer. So because the phone has limited resources on all of these fronts, then in order for a user to actually have a good time using their iPhone, then we have to manage those resources very frugally. So for example, you can't just make an app that drains the user's power in 5 minutes, or make an app that's so demanding on processing power that it's so slow and barely chugs along on the phone. So in all smartphones, there's always a manager, somebody to manage all of those resources. And that is, of course, the operating system. So it's iOS in our case that we need to worry about. And this manager is a little bit like the factory boss. It tells our app, hey, you're about to come on screen now, get ready. The user wants to see something from you, don't let me down. Or it might say, hey, you're draining the battery way too much, I'm gonna have to shut you down. Or hey, you little app, the user's getting a phone call right now. I'm going to have to switch you off. Make sure you save their data before you go home. And this is what I think about every time I see my apps shuddering and shaking in fear. So previously, we looked at the 3 components that make up any app, namely the screen, the code, and the data. Well, we actually have to zoom out a little bit and see the bigger picture, which includes the role of the operating system. So when we think back to that plan that we're writing when we're coding up the apps, then that plan has to take into account all of the events that happen, not just when a button inside the app is tapped or when the user shakes the phone when our app is open, but also things such as when the operating system tells us that the user is getting a phone call. So our app is going to be switched into the background. So we have to also plan ahead for those situations. Well, if the user is getting a phone call, but they were midway through filling out a long form inside our app, we don't want them to come back after the call and realize all of that data has been lost. So we have to plan on how we save that data when a user gets a call, for example. So all in all, when we build an app, we're essentially writing a very long and very extensive plan to plan for what should happen under lots of possible scenarios. And when the app is launched on the phone, it looks to this plan to see what it should do. So in the course, we're going to be digging into every single aspect that we spoke about in this lesson. And this is a little bit of a teaser of what's yet to come and what you're going to be learning about, so that by the end of the course, you'll understand exactly how the app works and build any app that you dream of. Now, in the last lesson, we got an overview of how apps work on the phone. So in this lesson, I want to take you one step further and look at how apps are made from beginning to end. Now, one of my favorite shows of all time that you get on Discovery is a show called How It's Made. And it basically takes you into the factory and shows you how a bunch of random things get built on the factory floor. Things such as street bicycles, or floors, or drum crushers, or skateboard wheels. And I just find it so fascinating seeing how all of these everyday objects gets made and built. So if you're curious, have a look at some of the episodes, and there's some real gems in there, like how rubber gloves are made. And it shows you every step of the factory process, from dipping it in latex to drying it and rolling it. And I don't know why, but I find it so interesting, the process that's involved in creating all of these everyday objects. So that's what I want to do here. I want to do a special episode inspired by the show on How It's Made, the app episode. So the app industry is absolutely massive. Last year, Apple reported it paid app developers $26.5 billion US, and that number grew by 30% year on year. So it's a massive industry, and it keeps on getting bigger. Now, of course, some of that money goes to big companies such as Clash of Clans or Clash Royale or some other form of clashing. But there are also a lot of stories of independent one-man developers who have made it big on the App Store. And one of the best examples is the 7-minute workout app. Now, in the course resource list, I linked to the article that's written by the maker of the 7-minute workout app, a guy called Stuart Hall. And by himself, he built an app that got 2.3 million downloads without spending a cent on marketing, which generated him over $70,000 US in profits, and was acquired and sold to a company just after 18 months. It's a really fascinating read, but he goes through the entire process of how he built this app from idea to App Store, all by himself with no budget. Just the skills and know-how of how to build an app and the grit and perseverance of an entrepreneur. So I know that you're taking this course for various reasons. Some people want to get a job as a developer. Others just want to gain a new skill and make apps for fun. And other people want to build a business based on an app. But before we get started and really dig into learning and building our apps, I think it's really important to first have an overview of the entire process from beginning to end of how an app is built. So step 0 before you do anything else is why. Ask yourself, why do I need an app? And in many cases, you actually don't. If you just want to build an app that simply displays data or information, say the opening hours of your shop or the services that your business offers, then you don't actually need an app. You can simply build a website that looks good on mobile, and that will take far less time to build, and it's much easier to do. But however, if you need to tap into the sensors of the phone, or if you want to be able to push notifications to the user, then you probably do need an app. But just make sure that you're on the right path before you even begin. Now, once you're sure that you want to build an app, then the next step is the idea stage. Not just coming up with an idea, which is the easy part, but validating whether if the idea is actually a good one. So let's say that I'm bored of swiping on Tinder for my next match, and instead I want to find my perfect match in the form of a Sunday roast. So what if I have an idea for an app that's called Tender? and it's going to match me with the dish that I fancy the most right now. And it could be a delivery app such as Uber Eats or Deliveroo, where I get that meal made and sent to me, or it could be just a recipe app where I try to find the thing I want to make today. So here's an app idea, but how do I know if it's actually a good one? Well, that's when you would need to validate the idea. Talk to lots of people and get a diverse range of opinions. Make a minimum viable product that doesn't require any technology at all to test and see if people are actually interested. Or put up a landing page describing your idea and promote it on social media and see if people actually want it. And essentially what you're trying to establish is, once this app gets made, will people actually want to download it and use it? Now, once you figure that out, then you're ready to move on to step 2, which is designing the app. And in this app development bootcamp course that you're enrolled on, I've included full modules on app design. So you'll learn how to build wireframes, how to build prototypes for your app, and learn how to use all the tools and the design principles to make not just a functional app, but a beautiful app that people will love. And then you can move on to step 3, which is the actual development, the programming of the app. And that is going to take up most of our time in this bootcamp. We're going to be building over 25 apps. And through the process of building these apps, we're going to be learning all of the fundamentals of iOS development and the Swift programming language, so that you become a well-rounded developer and you'll be able to tackle new problems that you haven't seen before or build custom features once you've completed the course. So let's take our Tender app, and let's say we've written all the code for all the functionality of the app and we've developed and built it. Then the next step is to test the app. And I'm going to tell you about automated as well as manual ways of testing your app so that it looks and works well on all devices, so that people all around the world, no matter which phone device they have, will be able to enjoy using your app, so that you can get those 5-star reviews that are crucial for your app to get more downloads. Now, step 5, we're ready to publish it onto the App Store. And I'll tell you all of the ways that you can get press for your app launch, and also what are the rules behind getting your app featured on the App Store. Now that you've made and published your app, the next step is to tell people about it. So in this bootcamp, there's a full course on app marketing as well, where I show you all of the ways that you can get your first customers, get your loyal fans, and start getting those downloads and making revenue off the App Store. Now, finally, step 7. As with all great things, you need continuous feedback and continuous improvement. So when your app is live on the App Store, you'll start getting reviews of people who want to request other features, or they have suggestions, and you can take some of those on board and update and refresh your app and continuously improve your user's experience. So that's a very quick and broad overview of how apps are made from beginning to end. Now, if you scroll to the very bottom of the curriculum, you'll find that I've included a full-length version of this lesson, and it's a talk that I give often at conferences, hackathons, and various events, and it goes into far more detail on every one of those steps that I've talked about in this lesson. So if you're interested in getting more details on each of the steps and seeing each of the steps fleshed out, then head over there and take a look at that talk. And then once you're done, continue back where you left off in the curriculum track, and we're going to get started building our very first app. All right, so in this lecture, we're going to be covering some of the tools that you'll need in terms of software and hardware to start developing for iOS. First and foremost, you will need a Mac of some sort. Now, it doesn't have to be the latest or the greatest, but it just has to be able to run OS X. So it's now called Mac OS. And the reason why we need Mac OS is because we need to install a piece of software called Xcode that will allow us to develop our iOS app. So this means that iPads, even iPad Pros, are out of the question. But if you had a iMac, or if you have a MacBook, or even a Mac Mini, it will work just fine. So if you don't already have a Mac and you don't want to invest a lot in, a brand spanking new top of the range MacBook, then one of the cheapest ways is probably just going onto eBay and getting a secondhand Mac Mini for around $500, and it's a pretty great deal and it'll do just fine. But what do you do if you only have a PC? Well, the other option is that you can go for something called Mac in Cloud. So if you head over to macincloud.com, they have a service where essentially they offer you a Mac in the cloud. So you can be using your PC and you have a remote connection to a Mac that is just for you, and it's already got Xcode pre-downloaded, so you can just get up and go. Now, there's a lot of people who ask about Hackintosh, or how can you run a Mac, sort of dual boot a Mac on your PC without having to pay for a service like Mac in Cloud. Well, there's a number of ways that you can do this, but one of the major downsides is that Apple is very strict about controlling their software and the environment in which their software runs. So even if you're using Mac in Cloud, or even if you're using a Hackintosh solution, you won't be able to run your app on a physical iPhone device that you own. The only way that you can do that is by having an actual Mac. But you will be able to run it on a simulator inside Xcode. So this is a simulated version of an iPhone, and for all intents and purposes, it will work just as well. It's just, say, if you're really excited about having your app on your iPhone, then you really need to find a way of either borrowing somebody's Mac or, getting one cheaply. I've detailed some resources in the text file of this lecture that talks about how you can go about exploring some of these ways of turning a PC into a Hackintosh. But I would still recommend try out some of the earlier solutions rather than going towards building a Hackintosh. It's just that we've had a lot of students on the in-person programming bootcamp who've tried to do this, and it's always given them a lot of headaches. So if you can really try and avoid this, this is almost the last-ditch solution. Now, the software that you'll be using is Xcode, and this is a piece of software that's written by Apple and allows you to write code, allows you to design your app, as well as run your app within the simulator that it comes with. And this is completely free, and in the next lecture, we'll be showing you how to download it and how to get it set up. Now, in order to be able to download Xcode 10, which is the version of Xcode that we'll be working with during the course, you'll need to update your Mac to a minimum of High Sierra, which is macOS 10.13, or even better, update to the latest version, which is macOS 10.14, also known as the Mojave. So it's quite easy to check the version of macOS that you've got. So if you just head over to the Apple symbol here and you go to About This Mac, then you can see what is the version of macOS that you're running. And you can click Software Update in order to take you to the App Store where you can update your software. Alternatively, you can just head into the Mac App Store and it'll take you to the download page where you'll be able to download it for free. So usually what happens with Xcode is that they'll support the last version of macOS for a while, so maybe usually 4 to 6 months, and then the later versions will no longer support it and it'll require you to update. Now, macOS Mojave is the latest version of macOS to be released in 2018. And it's got a number of features where a lot of it is about improving the operating system, but there are some neat things about it that might make you want to update. For example, the long-awaited dark mode comes to macOS, which allows you to change all of your windows and applications into the new darker mode, which is friendlier for nighttime users and programmers alike. In addition, there's the dynamic desktop where the desktop image can vary depending on the time of day. For example, they've got this default one, which is a picture of the Mojave Desert, which will change depending on the time of day in your local area. So there's some pretty neat things, and I recommend you checking out their page and deciding whether if you want to update. But it's important to remember that if you want to use Xcode 10 and all of the goodies that come with it, then you'll need to update to macOS Mojave, or at least update to the latest version of High Sierra, which is currently 10.13.4.
Now, another thing to note when you're updating your Mac OS is to check the age of your laptop or your desktop. So, for example, for Mac OS Mojave, you will need a laptop that is newer than the 2012 model. So, here's a full list of all the compatible Macs that you can install Mojave on. But if you do have any difficulties updating your Mac OS, then this might be one of the reasons. And if this happens to you, it might be that you have to go down the Mac in Cloud route, or you might just have to pick up a cheap version of a Mac Mini off eBay. But that's a tip that trips up some people when they're updating their OS. So when you're testing your app, you've got the choice of either testing it on a physical device if you own an iPhone or an iPad. So because the course is aimed at teaching you how to make apps for iPhone, a lot of the designs that you'll be making and a lot of the project stubs will have the design and layouts optimized for iPhones. So you can still follow along with everything we do in the course with an iPad, but just be aware that some of the designs might look a little bit stretched and they might not look exactly the same as you see on the iPhone, but it will work just fine. If you don't have an iPhone, you don't have to run out right away and get one. This is something that I would recommend, once you realize that you're really into this, or if you're at the point where you're about to release it on the App Store, then you have to test your app on a physical device. It's at this point when you would actually get an iPhone, so not straight away. So as I mentioned, Xcode comes bundled with a iOS simulator, and it's sort of like a virtual phone that runs on your computer, and you can essentially, use the rotate gestures, the shake gestures, you can zoom in and out, you can tap, etc. So it's just a simulated iPhone, and that works just as well. The only times when it doesn't really work so well is when you are using notifications, or if you're using Apple Health or Apple Home or some of those things, it can get a little bit tricky. All right, so another question that we get asked a lot is about universal development. So this is your cross-platform ways of developing apps for iPhone. The three that just came off the top of my head is PhoneGap, which uses HTML, CSS, and JS. Xamarin, which uses C#, and Appcelerator, which uses, again, JavaScript. So the advice that we tend to give students is that while this seems really appealing because you're essentially developing once and deploying it both on iOS and Android, you can do that simultaneously. The problem is that your user experience won't be as nice. You won't be able to tap into some of the native functionality of the phones. And in terms of design wise, it's just not as pretty. And it's very obvious to a seasoned developer looking at something that's been done on cross-platform. So I would strongly recommend you actually learn to use the native tools because it is the most powerful and allow you to build more complex apps in the future. And that's exactly what we'll be doing in this course. We're going to be using the professional tools, so Xcode, in order to make iOS apps. Another thing that you should always ask yourself before you make any app is, do you actually need an app, or can you actually make do with a mobile responsive website? Now, because we have a mobile app development agency as well at the London App Brewery, one of the things that we tend to recommend, we have a lot of clients who come to us and say, I want you to make this app. And we actually spend a lot of time turning people away and telling them, look, you can get this made much quicker and much cheaper by just getting a web designer to make a website for you that's mobile responsive, that scales nicely on the phone. Because unless you're tapping into some of the sensors within the phone, say if you need the location or if you need to be able to send people notifications, something that is inherent about the phone that you need. Otherwise, if you just need to display information, then making an app is a very time and money costly way of going about that. So always think about whether if you actually need to make an app before you make any app. And finally, we're just going to mention that prior to Xcode 7, so Xcode 6, in order to actually download the app that you coded up, that you developed within Xcode, onto your physical iPhone device that you own, you actually had to pay Apple $99 a year in order to be on the Apple Developer Program. So as of Xcode 7, so I think that was September 2015, when it launched, you are now able to do this on any free Apple account. So all you need is just your normal iTunes account, which you use to download apps. We'll be able to get your code and your app onto your physical iPhone device. Now, when would you consider signing up for Apple Developer Program? This is when you're ready to launch your app onto the App Store and start generating revenue. So I would recommend that try to delay signing up for the Apple Developer Program as long as you can, because you're charged on a yearly basis, rolling essentially. So if you're not yet ready to take advantage of the Apple Developer Program, if you haven't got your app together yet, if you're not ready to upload to the App Store, then there's actually no point paying Apple for that privilege. So build your app, test it thoroughly. Once you're ready and about to launch it to the App Store, then start paying for your Apple Developer Program license. And this gets you access to something called iTunes Connect. This is a portal where you can upload your apps, you can check your app analytics, how many times it's been downloaded, how many people are using it, you can check your sales, you can see how much money you're making every day, etc., etc. So this is something that we're going to cover in one of the last sections when we guide you through how to actually upload an app to the App Store. So all of that is coming up. All right, so those were all the tools that you'll need in order to get started. And in the next lesson, I'm going to show you how to install and set up Xcode so that you'll be able to get up and running very quickly and we can get started making our first app. Right, so we're now ready to download and install Xcode 9. So this is the application that we'll be using to write our code and build our iOS apps. It's developed by Apple and it's free to download, so you don't have to worry about paying for it or paying for upgrades or any of that. But before we start, there's a couple of things that you need to check to ensure that your download and installation goes smoothly. First thing is to make sure that you have enough space on your hard drive. So even though Xcode is only about 4.5 gigabytes, you need about 10 gigabytes for the download and installation. So first check to make sure that you have enough space. And to do that, it's pretty simple. Just head over to the Apple icon at the top of your menu bar and go to About This Mac. And when you're here, you can click on the Storage tab to see how much free space you have to play with. And just make sure that it's over 10 gigabytes. So the next thing that you need to check is to make sure that your Mac OS, your operating system, is updated to the latest version. So to make sure that you've got the right operating system, it's as simple as going to the Apple icon and going to, again, About This Mac, and you can see here which version you've got. And ideally, you should be on macOS Mojave, and your version should be 10.14 or above. So 10.14.1, 0.2, etc. As long as it's above 10.14, then you're good to go. Now, if you want to stick to macOS High Sierra, then you'll need to make sure that you have the latest version of macOS High Sierra installed. And at the time of recording, that is version 10.13.4. But in the future, that version might go up. So just check in the App Store and make sure that you update High Sierra to the very latest version. And depending on the age of your laptop, you might be limited to a previous version of macOS, say something like Sierra or even El Capitan. In those cases, then you will not be able to install the latest version of Xcode, which is Xcode 10, and I recommend that you follow one of my previous courses, for example, the iOS 11 course or the iOS 10 course that uses Xcode 8 and 9, which will be compatible with your version of macOS. So once you've done those two things, the last thing that you need to make sure is that don't download a beta version of Xcode. It's actually not that easy to download it by accident, because as long as you're going through this video and following along with what we're doing, then you can be downloading the official release version of Xcode and you won't have any problems. The reason why we don't like our students to be working with betas, because beta software is meant for testing. So it can contain bugs and it might end up giving you more headaches than it's worth. So no betas. Stick with what we're going to do, and you'll have a much better experience developing for iOS. All right, so let's go ahead and do it together. So head over to the App Store. You can either use Spotlight by holding down Command and Spacebar to bring it up using the shortcut, or you can head over to the Spotlight icon over here, or if you want to be really fancy, you can even get Siri to do it for you. Siri, open the App Store. There we go. So head over to the search bar here and just type in Xcode and then hit enter. And you can see it come up over here. And if you just click on this button here, you'll be able to install it onto your system. Now, this can take a little while, and sometimes you'll see it just hanging and it refuses to do anything. So have a look and see if some of those things I mentioned earlier might be the problem. So if I'm talking too quickly, or if you want to see a written version of all of those steps, then I've included a link in this lesson to a written version of everything that I've gone through in this video that you can check out, and you can follow step by step and do the installation according to the written steps. But it doesn't matter which way you choose. As long as you've got Xcode 10 installed on your system, then you're ready to go to the next lesson, where we'll be walking you through the Xcode software and showing you all the bits and pieces that we'll be using later on. So I'll see you there. All right, so now that you've successfully downloaded and installed Xcode, we're now ready to go on a guided walkthrough of the Xcode software. So in this lesson, I'm going to be showing you some of the most common panes and sections of Xcode that we'll be using, as well as talk you through some of the hints and tips that will be really helpful for development later on. So once you're ready, let's show you the ground world of Xcode. So the first thing that you'll see when you open up Xcode is this welcome screen. And here you can choose to start a new playground or create a new Xcode project. So that's exactly what we're going to be doing. So go ahead and click on create a new Xcode project, and then it takes you to the project creation wizard and allows you to choose a template for your project. So we're looking at the iOS templates at the moment, and you've got single view application, or create a game template, or an AR app template, as well as things like master detail, page-based, or tab-based app. So unless you're creating a game or ARKit app, then most professional developers will choose to use a single view application as the template. And the reason for that is because with things like master detail, page-based, or tab-based app, you get a lot of extra things added in that may or may not be useful. So we tend to choose single view application because it's the most customizable, it's the most flexible, and it will allow you to add all of these things later on if you need them anyways. Now you can see that there's also other tabs, such as creating a watchOS app or a tvOS or macOS app. But since this course is all about iOS, then we're going to stick to that and make sure that the single view app is selected, and go ahead and click next. So this is the screen where you're going to input some details for your app, including the product name. So this is the name for your app. And in our case, we're simply going to call our first app Hello World, in accordance with traditional programming tutorials. We're going to create our first Hello World app. Now the team section, we're going to leave blank, so leave it as none. Later on, when I show you how to download your app onto your physical device, we're going to be digging into this and we're going to be setting it up. But for now, we're just going to leave it as none. So the next thing you have to fill in is your organization name. So if you have a company, then this is where your company name goes. If you don't have a company, then simply put down your own full name. Then the next field is the organization identifier. So this is where they expect a reverse domain name structure. So what is that? So for example, our website is londonappbury.com. So the reverse domain name structure of that is com.londonappbury. So the next thing that we see is the language. We're going to keep that selected as Swift, and the final 3 checkboxes we're going to leave unchecked. So in later, more advanced modules where we teach you how to save user data locally, then we're going to be checking this box to use core data. And when we teach you how to test your app using unit and UI tests, then we'll be using these 2 boxes. But for now, we're going to leave all of them blank, and we're going to go ahead and click next. So now you're asked to save your project somewhere, and if you want, you can set up a folder to hold all of your app development projects, and you can save everything in there so that you'll be able to find it later on. Alternatively, and what I'm going to do for now, is I'm simply going to save this app onto my desktop. So I'm just going to go ahead and click Create. So this is the screen that you'll see whenever you created a brand new app. So I'm going to take you on a tour of Xcode to show you where all the different components are and some of the most commonly used buttons. Now let's start from the top and work our way down. So right at the top of Xcode, you can see this here, which is the status bar. And the first thing that you might notice is that it looks incredibly similar to the other Mac apps that you have. For example, iTunes. So right at the top here, you've got a play and pause button, and you've also got the part that shows you what is being played and some more information about your song. And similarly with Xcode, up here we've got a play button and a stop button. So this builds and runs our code project onto the simulator or onto a physical iPhone device. And you can also stop the running by using the stop button. So you can determine where you want your app to run by clicking on this button here. And that allows you to choose either a device, so a physical iPhone, if you have it connected to your Mac, or you can choose one of the many iOS simulators that comes with Xcode. So when you choose any of these simulators and you hit run, you'll see that you get a simulated iPhone device running inside your Mac. So you can resize this if it's too big for your screen, and it's got this bezel around it. And that allows you to click on various buttons like the home screen button or the volume controls, etc. But I personally prefer it without the bezel. So I tend to go into Window and Show Device Bezel. I uncheck that to just simply get my full-size iPhone screen, which you can fill your desktop with to make it a lot bigger. So that's launching your simulator, and we can go ahead and click stop to stop the running of our app. The next part you see is the app status. So here it'll tell you, for example, right now it's finished running, or before when it was building, then you get a progress bar. You'll also get your errors and warnings show up over here as well. So that's just a general status of what's happening inside Xcode and to your projects. Now, moving further along, we've got these three buttons, and we're going to be using these two quite a lot, and the third one less so. So the left one is normally selected by default because it shows the standard editor. So that means that the middle part of your Xcode is just a single screen, and that's what the standard editor means. Now, if you click on the two circle icon, this brings up the assistant editor, and this allows you to split the middle section into two screens. And sometimes this is really, really useful. For example, when you're designing your app, and you've got your canvas on the left-hand side, you can have your code file showing up simultaneously on the right-hand side, so you can flip back and forth quite easily. And we're going to be using this quite a lot when we're designing our apps. Now, the third button is for the version editor, and this allows you to see previous versions of your code. So, for example, if you made some big changes, but then everything broke, then you can revert back to your previous versions and you can inspect them here and compare and contrast, and you can either copy things over or simply roll back to a previous version. We're not going to be using that one too much, so let's go back to the standard editor that we're going to be really familiar with. Now, on the right-hand side, there's three more buttons, and they are for popping out your three main panes. So the pane on the left is called the Navigator pane, and it's composed of a number of tabs. For the majority of the time, you will be working within this Project Navigator tab here, and this shows you all of the files that together make up your app. So that's the Project Navigator. Now, we're not going to be using all of these tabs, so I'm just going to draw your attention to some of the more important ones. For example, this Find Navigator, which is basically like a search bar, and allows you to search within your entire project, or you can narrow down to folders or specific files. And so that means you can find things really easily using this pane. The next one I'll show you is this error pane, and this is the place where your errors will show up if you make them, and it helps you to debug and figure out what's wrong with your code. So let's say, for example, I just write some gobbledygook somewhere. You'll notice that very quickly Xcode will pick up on the fact that this is not real code, and it will highlight the fact that I've made a mistake. And if you have a look, you can see that the error shows up in a number of places, here, here, and here. So pretty much all over the place to try and draw your attention to the fact that there's a problem here. Now, if you click on this icon, this error icon in the status bar here, it'll take you automatically to the error pane, and it'll show you what the error is and which file it spotted it in. So let's go ahead and delete that. Now, the other thing that you might see in here that are not errors are warnings. So when you get warnings in Xcode, they show up in yellow, and they have this little yellow triangle here. And the yellow warnings are basically things that Xcode thinks that you might have gotten wrong. Now, it doesn't prevent you from running your app. So whereas if you have an error, it won't let you run your app at all. It will actually just prevent you from trying to make a blunder, and it'll tell you build failed because of this error. But with warnings, you will be able to run your app, and it's more like, Xcode trying to be helpful, trying to tell you, hey, I think there's something funny going on here. You might want to have a look into it. And of course, you being, the more intelligent human, well, at least until the rise of the machines and they annihilate all of us humans, for now, we're still the more intelligent beings. So there are times where I'll tell you to ignore a warning. So for example, right now, the warning is telling me that I've never used this bit of code inside my file. So that's obviously because I haven't finished typing, and this is one of the cases when you can safely ignore a warning. Now, the rule of thumb is that when you're uploading your app to the App Store, to clear your errors and your warnings before you upload it to the store. But before then, when you're testing, when you're debugging, when you're writing your code, then just use it as helpful advice. Okay, so the last one that I want to show you in the navigator pane is this one, which is the breakpoint inspector. And breakpoints are incredibly easy to create accidentally, especially when you're new to Xcode. So anywhere between this left margin and these numbers here, if you click in that margin, you will create a breakpoint. So this is one of these blue arrow-like structures. And what it does is that when your app runs, the code runs from top to bottom. And when it hits this breakpoint, it stops. It applies the brakes and it stops any of the code that are below it from being executed. Now, breakpoints are useful when we want to stop our app at a particular moment in time or in code, and to inspect what might be going wrong, or to debug, or try to figure out something that's going on underneath the hood. I'll be showing you exactly how to do that later on as well. But if you've created a breakpoint by accident, you can get rid of it by either clicking on it to disable it, so it becomes this light blue color. Alternatively, you can simply click and drag it away, and it gets rid of that breakpoint completely. So that's just something to note. And have a look inside your code when you have any bugs or crashes to make sure that you haven't accidentally just simply put in a breakpoint. All right, so that's the left pane. The next button controls the bottom pane, which is also called the debug area. And this is the part where you're going to get error messages when your app crashes. And when your app does crash and you can't figure out after trying for a while why on earth it happened, then it makes sense to copy what it says in here and post it into the question answers forum so that myself or other students will be able to help you. And other times we'll be printing things into here to figure out what's going on in our app. So it's mostly used for debugging, so figuring out what's going on in our app. So let's move that away. Very often when you're coding, and especially if you're working on a 13-inch laptop, there's not a whole lot of space. So you might want to get rid of some of these panes if you're just going to be coding for a while. And it's always good practice to try and maximize your code file so that your code doesn't wrap. Then what happens is that your code is displayed on two lines because of the space constraint, but actually they belong on the same line. So it's a good idea to try and give yourself as much space as you can when you're coding, and that makes everything so much easier when you can see exactly what's going on. Now, the last pane that I'm going to show you is this one on the right. And when you're working inside the code file, you won't find yourself using this right pane very much. So it makes sense to pop it out. But when you're designing your app, you're going to find this right-sided pane, or what's known as the utilities pane. It's going to be really, really useful. So let's go ahead and create our Hello World app. Now the first thing I'm going to do is I'm going to go inside the main.storyboard. So this is the place where it holds our canvas. And this is where we can design our app to make it look nice. So we can go into what's called the object library. Now I'm going to go and search for a label to put into my app. Now labels are used for displaying various bits of text. And in this case, I'm just going to display the words Hello World. So in order to change the text in that label, I can either double click on it to retype it. Alternatively, I can use the utilities pane. So if you select the label and then go into the attributes inspector, which is this little shield symbol here, then you can see that you can also change the text here. Now let's go ahead and center our Hello World. So let's go ahead and change the background. So in order to do that, I'm going to select the view, and in the attributes inspector again, I can change any of its properties, including things like how see-through this background view is, or what is the color I want for the background. So in this case, I'm going to click on the color and I'm going to select one of these colored crayons to give my view a background color. Now, wouldn't it be nice if our label was a little bit bigger? Well, let's go ahead and change the font here. We can make it maybe a 50-point font. So you can see again, my text has gone over the limit. So I want to resize this label. Now I showed you earlier on how you can do it by eye by simply toggling these edges, but you can also go into the size inspector here, which has the little ruler symbol. And here you can enter a very precise position and width and height for your object. So in this case, it's the label that's selected. So if I change that width to maybe 300, then you can see that it fits my label perfectly. So if you have a designer on board and they can specify the positions and sizes of their design, then you can enter them in here and you'll get a very precise location and size. So this brings us on to another good point, which is the fact that this canvas, its dimensions are actually, it's a 4.7-inch screen. And if you have a look down here, you have a way of changing the canvas size to maybe say an iPhone SE, which is the same as an iPhone 5 screen size. Then you can do that down here. And you can also change the orientation of your canvas. Now remember, this is about the canvas, whereas up here it's about your simulator. So that's your device and that's your canvas for your design. So now the last pane that we've got is this one here. And some of you may or may not see it. The toggle for it is a little bit hidden because it's this tiny, tiny little button down here. But if you press it, then you can toggle this pane here, which is called the document outline. And the reason why it's really useful is because, say if I have two of these labels which are really close to each other and I want to select one of them, then I can actually see both of these labels inside the document outline, and I can also click on it to rename it. So let's call this label 1 and let's call this one label 2. Now I can double click to select label 1 and move it up, or double click label 2 to move it down, or I can select label 1 and only change its color to white. So that's basically an easier way of selecting what's on screen when they are geometrically overlapping. So one last trick to show you before we wrap up is that you can increase and decrease the size of the canvas by using this toggle here, plus and minus. Alternatively, and what I find to be a lot easier, is to use the trackpad. So if you pinch in, then it zooms out. If you pinch out, then it zooms in. And if you use 2 fingers on your trackpad, then you can pan and move your canvas around where you want it to be. All right, so just one last thing to check before we go ahead and run our app, and that is to make sure that our canvas over here matches with our simulator or our device. So over here we've got an iPhone 8 Plus selected, and over here we've only got an iPhone 8. So they have different dimensions. And in order to make our app look good on the simulator, we have to keep it the same. So let's change this to an iPhone 8, and you can see that our text is now a little bit off center. So let's go ahead and put it back onto the center, and we can go ahead and click play. Now, don't worry too much about having your app look good on all of the devices, because we're going to tackle that a little bit later on when we talk about auto layout and how we can set rules and constraints for making the app look good. So that was our first Hello World app completed. If you followed along, then perfect. If you haven't, then don't worry. It's mostly just to show you what the Xcode interface looks like. In the next module, we're going to be creating our very first tutorial app, and you'll want to follow along with me because we're going to show you how to make a really awesome I Am Rich app that sold for $999 on the App Store. And I'm also going to show you how to sideload, or rather download, your app onto your physical iPhone. So all of that is yet to come. And just before you go over to the next lesson, the last thing I wanted to show you is that I've created a map of Xcode for you so that you'll be able to refer to it if any of those names sounded confusing. Like, where is the status bar? Where is the navigator pane? Where is the file inspector? Where do you run your app, or where do you change your panes? And especially in the beginning, it might be quite helpful for you to download that. So I'll include a link to that in this lesson as well. So that's all from me for this lesson. I will see you on the next lesson, where we are going to create our very first I Am Rich app. So see you there. All right, guys, it's Angela from the App Brewery again. So at this stage, I'm presuming that you've probably at some point in your life done a tutorial or a lesson somewhere else out there on the internet. And inevitably, at some point, you'll probably get stuck on a problem. Now, I spend a lot of time thinking about how I can make the course such that you get stuck less often. But with programming, it's almost a core part of the learning process that you do get stuck and you get yourself unstuck. So I tend to find that when I get stuck on something, I try to see it as a challenge, because usually when I solve it and when I figure it out, there is a huge sense of satisfaction, and there's usually some associated growth. Now, having taught over 100,000 students online and offline, I've seen people struggle in lots of different ways. And I just wanted to summarize the steps that you can go through when you get stuck on any sort of programming problem, and the framework that you can use to get yourself unstuck in the quickest way possible. Now, the first step is to evaluate what is the expectation versus what is the reality. What did you expect your code to do, or what did you expect to happen, and what actually happened? So every time you run your code, think to yourself, what do I expect to happen? And then see what really happened and try to figure out what is causing the difference. Now, with Xcode, it's very helpful in pointing out errors in your code. And it almost does it too well, where it starts feeling a bit like a nagging parent. It starts giving you warnings and errors. Oh, you forgot to capitalize that, or I don't know what you mean when you're writing this. But it can be really helpful as well. And when you get a little red error in your code, it usually is accompanied by a little bit of text. And this is the error message. And most of the time, it might seem like these error messages are written by aliens because they don't seem to make any sense. But you can quite easily figure out the human meaning in English for it by just putting it into Google. And you'll usually get lots of different answers as to what the cause might be and how you can fix the problem. And one of the websites, if you don't already know about it, it's going to shortly become your very best friend, and that is stackoverflow.com. So I recommend searching for any errors that you come across into Google and then heading towards the Stack Overflow websites that come up as a result. And this is exactly what real life developers do every single day. And in fact, I've worked in teams where we will all just go to the pub and have a drink and end the day if Stack Overflow is no longer working. So it's not cheating, it's all a part of the developer workflow. Now, if that still didn't help, or you're confused by the results that you're getting back, then it's a good idea to re-watch some of the video up to the point when the code started breaking or it started doing something unexpected. Because in the videos, there are always step-by-step instructions, and it's really important that you check to make sure that you haven't made a typo here or there, or you haven't capitalized something that shouldn't be capitalized, and just re-watch the video right before when your code broke in order to try and figure out what might have gone wrong. Now, the next step is you can check your code against my code. At the end of every tutorial module, there is a completed project that you can download, and you can scroll through the completed code, compare it to your own, and see if there were any typos, any errors, any mistakes. And if it helps, you can even copy and paste sections from the completed code into your own module just to see if that line or that paragraph helped to fix the issue. And if that still doesn't solve it, then the next step is head towards the Q&A. So underneath every lesson, there is a Q&A section. And it's a good idea to check in the lesson when your app has broken to see whether if anybody else had similar issues to you. And if you can't find anybody with the same issues, then ask in the Q&A. But make sure that you ask your question in the lesson where you're having the issues. That way it makes it much easier for other students to be able to learn from your mistakes, and also for me to be able to quickly identify what the problem might be. And if you have a question about anything in the tutorial, it's a good idea just to include the timestamp at which it occurs in the video, so I can quickly watch it and figure out what you're referring to, so that I can better answer your questions. Now, when you're asking questions in the Q&A, the way to get the most helpful responses and solutions is by following a 4-step approach. So firstly, tell us, so myself and other students, what did you expect to happen? Then what actually happened? And then include a screenshot of all of your code that corresponds to this situation, and then include a screenshot of the debug console that includes any errors, if there were any errors or if your app has crashed. So in order to take screenshots on the Mac, this shortcut is going to save you a lot of time, and it might be worth noting this down in your notebook. When you use Command, Shift, and 4, you get this little crosshair that shows up, and you can start clicking and dragging the area that you want to take a screenshot with, and it will save it automatically to your desktop, which then you can upload into the Q&A area for the lecture. And the parts that are really helpful to help you diagnose what went wrong are the code that you've written, and also whatever is written in the debug console. So this is the part that's in the bottom half of your screen. And this is super helpful for trying to figure out what happened, especially if you scroll right to the top. That's usually where the most helpful messages are. So that's just a brief step-by-step process on what to do and how to get help when you get stuck. And it's important to remember that everybody gets stuck sometimes. I've spent days trying to find a bug in my code, and it turns out to be just a comma that was misplaced or a semicolon that was accidentally deleted. And one of the greatest joys for me anyways is figuring out these problems and fixing them. So don't worry if you do get stuck. Everybody will try to help you. And just remember that getting stuck and solving it is all a part of the learning journey. All right, so let's embark on our journey to create our very first app. While making Hello World was fun, you're never going to be able to upload it to the App Store, and it's not terribly interesting. But instead, today we're going to make a very, very simple app that somebody has managed to sell for $999.99 on the App Store, and they sold something like 8 copies. And this is, of course, the famous I Am Rich app. So there was a guy called Armin Heinrich who, back in 2008, made an app that did literally nothing. It was a single red ruby that would show up on screen, and it was meant to remind you and others when you show it to them that you were able to afford this, i.e. paying $1,000 for an app that does nothing. I'm not sure how I would feel if a friend actually showed this to me, But at the time, it was actually a very genius idea. He priced it at the maximum amount that the Apple App Store allowed you to charge for an app, which at the time was just under $1,000. And he got around 8 purchases with 2 refunds. I'm thinking that's probably 2 kids who got beaten up really badly that day. And Apple actually took down the app the day after he released it. So there's still, 6 people out there with an actual copy of the app. And there's actually clones of this app on both Android and Windows, charging something like $500 for it, which Google and Microsoft seem to have no problem with, which is very interesting. So this is what we're going to make. And our version looks a little bit nicer with flat design, and it's going to be something that you'll be able to have on your phone and you can show people. Maybe not that you're rich, but at least you can design and make apps. So most importantly, this tutorial is more about getting to grips with Xcode, with the integrated development environment, the IDE, getting to know some of the buttons, getting familiar with designing and sizing and placing user interface elements, as well as some of the housekeeping around app creation. So how do you put in assets? How do you organize your image assets, etc., etc. So this is what we're going to create, and it's going to be a very quick and very easy tutorial. So let's get started. All right, so go ahead and crack open Xcode. And we're going to show you a couple of ways that you can get started. So there's 3 ways of starting a new Xcode project. One is clicking here on the welcome screen. An alternative way is, of course, going to File, New Project. And also you can use the shortcut, which is just Shift-Command-N as well. And we'll be using a lot of these shortcuts because when you're doing a lot of coding and a lot of design in Xcode, it can speed things up quite significantly.
So that's why in this lesson, I've also included a link to the Xcode keyboard shortcuts. This is a PDF file that contains some of the most common shortcuts that you'll find yourself using on a regular basis. And it might be a good idea to just print it out or save it to your desktop and start learning some of these shortcuts, which will make your life a lot easier in the future.
All right, cool. So let's go ahead and start a new project. And now it gives us a couple of choices for what template we want to use for our new project. So currently we've got iOS selected. We could make a watch project or tvOS, macOS, cross-platform games, etc. But today we're just going to stick to iOS. We're going to select single view application and click next. Next we're going to add the product name. So our product is called I Am Rich. And you can leave the team as none. Organization name, again, you can put in, either your full name or a organization or company that you belong to. And the organization identifier is really important. So if you haven't seen the Hello World app tutorial, just to quickly explain, this is what's called a reverse domain name. And it's the way that Apple chose for you to set a bundle identifier that is unique and identifies your app uniquely on their app store. So the organization identifier is what your domain would have been, so londonappbury.com, reverse, so with the com at the beginning, or co.uk or whatever. And this is just because, each organization will have a unique URL, and this makes sure that their app is unique on the App Store. So if you don't have a website, or if you don't have a company or organization, you can simply put com. Your name, for example, com.angela. There's probably not another person with your full name who's made an app called I Am Rich, but if they have, it's easy to change the bundle identifier later down the line, so don't worry about it too much. Alright, so we're going to keep the language selected as Swift. Objective-C is still supported as one of the languages that you can use to make iOS apps, but it's gradually being phased out, and we wouldn't recommend anybody to start. If you're starting to learn about iOS development now, you should start with Swift. We're going to keep the rest of these things unchecked, making a very simple app. We're not going to be doing any unit testing, and also we're not going to be storing any data, so we'll leave those unchecked and just go ahead and click next. Now it'll ask you where you want to store your project. You can either leave it on your desktop or somewhere else. It doesn't really matter. But one thing to note is that make sure that you keep this box next to source control unchecked. So Git is a way of managing different versions of your app, but we're not going to be using Xcode for version control. Instead, we're going to be using GitHub, and we're going to introduce you to that in a later tutorial. So keep this unchecked and just go ahead and click create. Okay, and that's your project all set up and ready to go. So in the next lesson, we're going to be looking into the storyboard and looking at how we can design our app so that it looks and feels exactly the way we want it to. All right, see you on the next lesson. All right, so now that we've set up our I Am Rich project, I just wanted to show you a couple of things. So when you look in the navigation pane on the left, you should be inside the project navigator. And if you look in here, there will be a number of files, and together all of these files make up your app. So some of these files will have a little swift bird icon, and these are the code files. So they'll contain the logic that makes up your app. And then there's other files with a yellow icon, which are the design files. And the first of these is the main.storyboard. And as the name suggests, this is where you'll be doing the majority of your design work for your app. There's also the launch screen.storyboard. This is where you'll design the loading screen. So the screen that comes up before your app loads up. So here you'll be putting in your company logo or your personal logo. So remember to check that you're inside the main.storyboard before you start designing your app. Otherwise, it can get very confusing when you run your app and you don't see it show up. And finally, there is the assets.exe assets folder. This is where we'll be putting the images for our app icons and any other image assets that we'll use in our app. All right, so now let's go ahead and go into the main.storyboard and start designing our app. Now, the first thing that you'll notice is this single screen setup. If you remember when we set up the project, we selected single screen template. So there's just one single blank screen. And you see this little arrow over here. Now this arrow dictates where the starting screen is for your app. So for example, if we had two view controllers in our app, then we can actually specify which view controller we want the app to start up on, the left one or the right one. For this app, we only have one screen, so let's just get rid of that other screen and set our view controller as the first view controller. Now inside the main.storyboard, we currently have the iPhone 8 canvas selected. So you can change that by clicking this button down here, and you can change the 8 Plus or to change the orientation of your canvas and design it any way you wish. Now for this app, we're going to keep it in iPhone 8 orientation. And don't worry if you see a different word here, say iPhone 6, 7, 8, 9, or whatever future one may be. Unlike these simulators, which have all of the different generations of iPhones from 5 through to 10, the canvas down here are size classes, and they're there to represent specific screen sizes. So for example, you'll notice that there is an iPhone 8 that you can select, but there isn't a 6 or a 7. And that's because they all have the same dimensions, 4.7-inch screen. So this iPhone 8 canvas encompasses all of those other phone sizes, 6 and 7. And you can select this one to design for all three of those phone sizes. Now that we've selected our desired canvas size, I'm going to make this pop down again. So I can do that by clicking on this button. And remember that especially if you're working on a laptop, a 13-inch or an 11-inch, you want to try and maximize the screen real estate you have. So try to get rid of the panes that you're not currently working on so that you end up with more space to think and more space to create your apps. So the next step is to draw your attention to this little button over here. And if I click on it, it will show up my object library. Now, the object library is exactly as it sounds. It's a library of objects, things such as spinner wheels or toggles or buttons or progress bars. And we can either view them like this, where we see all the icons and you can scroll through it easily, or you can have it like this way and you can scroll through them and search for the object that you want to put onto the screen. A much easier way though, and the one that I recommend you do, is to simply just search for it. So we're looking for a label. So if I start typing label, then it will narrow in on the one that I'm looking for. And once you found it, all you need to do is just to click and to drag it onto your screen. Now, as you can see, when you drag any objects onto your canvas, you get these blue lines that pop up. And these are the guidelines. They help you to design your app so that, for example, if you wanted your label to be horizontally centered and vertically centered, then you can simply place it when the two guidelines pop up like so. Now, the next step is I want to change the text that's inside my label. And as we saw before in the Hello World app, you can either double click on the label or you can simply go into this field in the Attributes Inspector and you can type the text that you want. Now, when you hit enter, it will automatically resize to the exact size that is needed to contain all of your text. And we can just simply position it back again. Now, the next thing I'm going to do is I'm going to change the font size to make it a little bit bigger. I'm going to make it a 40-point font, just so that we can see it much more easily on our app. And I'm going to place it up to the top of my app. And I'm going to change the color of my text to a white color. And you can either choose it down here or you can go through the recently used colors. But either way, my text is now white. Now, here we have a bit of a problem because if I select away from my label, then because the text is white and the background is white, it's very difficult to see where my label is. So here's where the document outline comes in handy. If you pop it open by, again, clicking that tiny button, remember, then you can select the label. So that's the one with the L symbol, and it's called I Am Rich. So when you click on it, it will select your label. Now, in order to make life a little bit easier for ourselves, we should really change the background color so that our label actually stands out. So in order to do that, I'm going to select the background view, either inside the document outline or simply selecting it inside my canvas. And I'm going to change the background color to a new custom color. So you can either select one of the recently used colors or some of the common colors, or you can select this option, which is custom, and that will pop up the Mac color picker. Now, you can either go for the crayon tab, where you've got all of these pre-specified colors that Apple has created so that you can easily select a color, or you can go into the sliders over here and select RGB sliders to either slide around and pick a color, or more commonly, you can insert a hex color code in here. And the hex color code is a specific code that specifies a particular hue of a color. So in my case, I'm going to put in 34495E. And this code gives me this beautiful midnight blue color. Now, if you have a designer on board, or if you're working with a client who has a designer, very often they will give you specifications such as which hex color codes they want for a particular screen in your app. And this is how you can specify a very specific color. Now, this is a really good time to point out a really neat resource. So if you head over to flatUIcolors.com, then you can find palettes that have been specially designed for the iOS ecosystem. And there's not so many to choose from, so it's quite easy to narrow down on one that you quite like. And you can simply click copy, and it will copy the hex code of that color that you have selected, and you can put that into your custom color slider, and you can end up with the color that you have selected. So this is a really popular tool amongst my students, and it'll help you to design beautiful looking apps really, really easily. Now, if you're interested in a lot of these design aspects and some of the tools and techniques, then make sure that you check out the module that is all about app design that is included in your course, which I've especially made to teach you all of the different aspects of user interface and user experience design. Now, the next aspect of my design that I want to change is the font for my label. So if you go ahead and select our label here, and you can go into this T symbol to change the font type. So you can see at the moment the font family is grayed out and we're unable to switch or change our font style. So if you wanted to change that, you have to change the font from system to custom. And now you can pick and select whichever font it is that you want for your label. Now I'm going to stick with Helvetica Neue, but I'm going to change the style from regular to thin. And I'm going to make sure that my size is still 40 points. And now I have a slightly more stylish looking font. All right, so now that's done, you can see that my label is kind of randomly somewhere on the screen. So this is a bit of a problem. And I want to teach you guys some more precise design methodologies. In a lot of cases, when you're working as an iPhone developer and you're working with a client, the client might have a professional designer on board who will specify the exact positions and sizes and colors of all the user interface elements. So for example, they might want their labels in a certain place, on a certain size, or their buttons somewhere specific. And in order to do that, what you're going to do is you're going to click on the label to select it. And instead of being in the Attributes Inspector tab, we're going to go into the Size Inspector by clicking on this little ruler symbol. And I want you to change the X position of the label to 108, the Y position to 100, the width to 160, and the height to 50. Then we're going to go back into the Attributes Inspector and center align our label. So now, if you look at your canvas, it should look exactly like my canvas because we've specified the exact positions and the exact size of our label. So this makes our design far more precise and far more consistent. So in this lesson, we've learned about customizing labels and positioning. In the next episode, we're going to talk about image assets, how to incorporate them, how to use them, and how to make them look good on screen. So that's all to come. I'll see you in the next lesson. In the last lesson, we created a UI label, we resized it and positioned it using the size inspector. In this lesson, I just wanted to cover briefly how positioning works. So when you're designing your own apps, you'll be able to do it easily and quickly. So let's imagine we have an iPhone with a grid layout and we've positioned a UI label onto the screen. In order to position your designs on iOS, you have to imagine the screen as a graph that's reversed. So the top left corner is your origin, so 0, 0. And your x-axis extends horizontally to the right, and your y-axis extends downwards. So a normal graph, whereas the y-axis would be going up, in this case, the value increases as you go down the screen. Now, if we're looking at a iPhone 6, then the x-axis would be 375 points wide, and the y-axis would be 667 points long. Now you can find all of these values for different screen sizes on a website called Paint and Code, and I've included the link to the resource in the text below this video. So you can take a look at it and check out the different screen resolutions and sizes of all the iPhones. Now coming back to our canvas, when you're positioning your user interface elements, say this label that I've got on screen, the point that you're positioning is also the top left corner of that user interface element. So it could be a button or a label or whatever. And you're essentially specifying where that point lies on this graph. So it doesn't matter if your user interface element is a square or a rectangle or whatever. All that matters is the position of the top left corner. Everything else is determined by the size, so the width and the height. Now, if you imagine this square that we're trying to position on our iPhone 6 screen, we can first extend upwards to check out the X value, and then we extend horizontally to find the Y value. So say in this case, our X value is 46 and our Y value is 90. Then we can go over to our Xcode and position this square. So X value was 46 along the horizontal, and Y value was 90 along the vertical. And there we go. It's designed and positioned exactly how we want it to be. So take a look at the different sizes of different screens, and you can try to play around with positioning in Xcode. So that was the lesson on positioning UI elements, and there's a couple more of these tutorials on how to design better in Xcode in order to equip you with the skills to make your app look more beautiful. In the next lesson, we're going to be incorporating image assets, and we're going to be using image views to display our diamond on the screen. So I'll see you in the next lesson. So in previous lessons, we've created a Xcode project called I Am Rich, and we've designed the user interface to have this beautiful midnight blue background, as well as a UI label that reads I Am Rich. We formatted the position of the label, as well as its appearance, and now we're going to incorporate some image assets. So we want to have a diamond that displays somewhere around here. And in order to display images, we need something that's called an image view. So let's go ahead into the object library. So let's search for image view, and there it is. And it tells you that it displays a single image or an animation described by an array of images. So we won't worry about the animations. In later lessons, we're going to cover that, and we're going to be creating our own. But for now, all we want to do is to display a single image. So let's go ahead and just drag it onto the screen. Now, if you take a look here in the Utilities pane, make sure that your Attributes Inspector tab is switched on. You can see that this image view has a number of properties. So you should imagine image views like a picture frame in real life. So your picture frame will have different properties as well, say the size of the picture frame or the color of the picture frame. And similarly, UI image views have these properties, the size of the image view, as well as the background color, the tint color. But the most important is its image property. So this is the picture that you're going to slot into that picture frame or the image view. In order to be able to slot an image in here, we have to have included images in our project. I'm going to show you shortly how we do that. But first, let's use our design skills that we acquired earlier on to design this image view. So making sure that your image view is selected either on the canvas or in the documents outline, we're going to head into the size inspector pane, so denoted by the little ruler, and we're going to change the position to 53 on the x-axis, 250 on the y-axis, so making it just a little bit higher, and then we're going to change the width to 270 points by 270 points, so a nice square. And that looks great. So the next stage is incorporating some image assets. Now, if you want to find out a bit more about positioning and you haven't watched the last episode, I would suggest go and have a look at it. It's only about 3 minutes long, and it'll clear up all of your positioning woes. So now we want to be able to slot some images into this image view. In order to do that, we have to head over to this folder, which is the assets.xc assets, Xcode assets folder. And you can see that we've already got one folder here. Even though it's empty, it's got a number of slots that we can fill. So these are the app icon images that Xcode expects every project to have. So when you're uploading your project to the App Store, Xcode will check to make sure that you've got the app icons for all of these slots. Now, in order to download the image assets that we have created for you, head over to the link that's appbrew.co/p/iOS12-course-resources. Now, I've included this link in the resources section of this lesson as well. So if it's easier, you can go ahead and click on it too. Now, that should take you to the entire resources page. And this page is designed to put all of the links and all of the resources organized by module onto the same document. So whenever you're looking for any sort of link or reference that I mention, then this is the place to go to. So currently we're on module 2 and we're building our $999 app. And if you have a look over here is our I Am Rich image assets. So if you go ahead and click that, then download should begin automatically. And if you're inside Chrome, then you'll see it show up down here. So this is a zip file. So if you just go ahead and click on it, then it will expand the folder and you'll see it over here. So now if we go ahead and double click to open it, then you can see that I've created all of these app icons for you at different image sizes. So now make sure that you're inside assets.exe assets, and we're going to drag on our first image asset, and that is the diamond.png image. So if you just click and drag this image over to this pane over here, just below where it says app icon, and drop it, then you can see that you've got the diamond image being placed in one of 3 slots. Now in the next lesson, I'm going to talk about these 3 slots and what the 1x, 2x, 3x means in greater detail. But for now, just be aware that we need to have different images at different sizes in order to display it properly on the iPhone. So for all of the iPhones that is below the iPhone 4, then they need 1x sized images. And for those phones that have a Retina screen, then you'll need the 2x size. Now for the ones which are Super Retina, which are the iPhone 6 Plus and the iPhone 10, then they will need an image that is 3 times as large as the 1x size. And in order to generate these different sizes, we can head over to a really neat tool called the App Icon Generator. And you can access that at appicon.co. And we can head over to the Image Sets tab, and we can select our design base size, which is going to be 3x. And we're only going to need images for iOS, so let's just uncheck the one for Android. And now all we have to do is drag our diamond image over here, and when we click generate, it will automatically generate and download our image set over here. So now if we go ahead and open our image set.zip, then you can see that we've got the diamond image.png, diamond at 2x.png, and diamond at 3x.png. So now if we head over here, I'm going to go ahead and delete this diamond image. I just wanted to show you the 3 slots, and instead I'm going to select all 3 of these by holding down the shift key, and I'm going to click and drag these images over here. And you can see that because they were named with this convention of at 2x, at 3x, then when you drag it into here, Xcode automatically knows exactly where to place it inside all the slots. So now that we've added our diamond image to our image assets folder, when we head back over to our main.storyboard, we can go ahead and set it to be the image that's going to be placed inside our image view, or our picture frame rather. So let's go ahead and select our image view, and we're going to go over to the attributes inspector, and we're going to change the image property to our diamond image. So as soon as I start typing diamond or D, then you can see it starts suggesting the images that I can place in there. And the one that it knows about, and the only one that it should know about, is the image called diamond. And you can see that this name comes from the name that we've given to our image asset over here. So if that's lowercase, then over here it'll show up as lowercase as well. And once you hit enter, then your diamond image will be placed inside the image view. Now you might notice that that diamond image looks a little bit different to how it looks over here. It's a little bit stretched right now. And that's because currently one of the other properties of our image view, namely the content mode, is set to scale to fill. So that's trying to stretch the image as far as it will go to fill the entire image view. Now that's not what we want because it'll distort our image. So let's go ahead and click the drop down menu and change it to aspect fit. And now it will try and fit the image to the widest part of the image view, and it will look a lot nicer. So there we have it. We've got our image view designed, and we've incorporated our first image asset. Now, when you're creating your own image assets for your own apps, then just go ahead and create an image 3 times the size that you need it to be. So for example, over here, our diamond image is 270 by 270 points. So that means that the 1x image will be 270 pixels by 270 pixels. The 2x image will be double that. So that will be 540 pixels by 540, and the 3x image will be 3 times as large. So you want to start out, whether if it's in Photoshop or Illustrator or Sketch or any sort of graphics package you have that you want to use to create your images, you want to start out with the largest possible image. So in this case, it will be 3 times 270 or 810 pixels by 810 pixels. Design your image at that scale and then drag and drop it into a service such as App Icon Generator, and then get it to generate all of the 3 sizes. And the beauty of that is that it'll automatically name all of your files in a format that Xcode will recognize. So when it has that @2x before the .png, then when you drag it into your assets folder, it'll automatically know to put it into the 2x slot. So that's how you can go about creating your own image assets for your own apps. Now, we've got our diamond images in, but we still don't have any app icons. Now, to save you the trouble of having to generate all of them, I've already generated everything for you. So you can go ahead and just select from icon 20, hold down shift all the way to icon 1024, and you can click and drag it until these blue boxes appear around each of the slots, and then go ahead and drop it in. Now, when you do that, the last one is going to have a slight issue recognizing it. So if you see any unassigned warnings down here, then just make sure that you click and drag this image into the 1024 App Store slot, and that will get rid of those warnings for you. Now, at this point, you might notice that our iPad icons are blank, and that's because we're not creating an iPad app, we're creating an iPhone app, so we don't need those to be there. But occasionally you'll get a warning from Xcode that tells you that a 76 by 76 app icon is required for iPad apps. An 83.5 app icon is required for iPad. And the reason is because when we created our app, we didn't explicitly state whether if we're going to be creating an iPhone app or an iPad app, because by default, we create universal apps that target all devices. So let's go ahead and change that drop-down menu to the iPhone only app. And you'll notice that after you do that, you can go ahead and hit Control B to build, or you can go into Product and Build. And what this does is that it will refresh your project and it will get rid of any unnecessary warnings. So that gets rid of the requirement for the iPad app icons. Now, we still have one last warning over here. And remember, the yellow triangles are warnings, whereas the red ones are errors. So the warnings are there to remind us to check and make sure that we've got everything exactly the way we want it to. Now, this warning says views without any layout constraints may clip their content or overlap other views. Now, to translate that in English, it means that it's unhappy with this label I am rich because it doesn't have any rules associated with how it should be displayed when this app is being rendered on iPhones of different screen sizes. So, for example, if we were to run our app on a very small phone like the iPhone 4S, then you can see that everything is shifted out of place and it no longer looks as nice as we designed it to be. So in iOS development and design especially, there's a concept called auto layout and setting constraints. And this is a topic that we're going to be tackling a little bit later on once we've gotten the basics of designing and creating our apps down. So for now, you can safely ignore this warning. Alternatively, if you really want to get rid of it, you can select your label, go ahead and click on this button over here and click on Stack View. And this will get rid of any warnings that you have in your project. So in this lesson, we've learned about image views, we've learned how to use them, and we've also learned about incorporating image assets into the asset folder. So in the next lesson, we're going to be covering the difference between pixels and points and the reason behind these naming conventions like at 2x and at 3x. So I'll see you in the next lesson. Alright, so in today's lesson, we're going to learn about points versus pixels. Now, you would have heard me mention these two things just in passing in some of the tutorials. And also, when we incorporated some of our image assets, you would have noticed that some of them were at 1x, some were labeled at 2x, some at 3x. So let's explain exactly what is going on behind the scenes. And to do that, we have to understand points and pixels and the difference between them. So let's first start with pixels. So pixel is a contraction of the word pixel or picture element, and they're simply squares of color that together make up an image. So if you think about video games back in the old days, when computers had very, very limited processing power, all the animations had to be created with very few picture elements, and that's why they looked kind of jagged. So if we take a look at this image of the London Atbury logo, you can see that it sort of looks okay. It doesn't look too pixelated at this size. But if I zoom into it, you'll start to see these pixels forming. Eventually, when it's this size, you can clearly see all the edges are jagged, made up of various pixels. If we want to display beautiful images, then we need to ensure the resolution is high. So that's pixels. What are points? Points are a measure of length. A single point is defined as 1/72 of an inch. Very often when you're designing it in Photoshop or Sketch or whatever, you'll see the resolution being 72 ppi. Now, what does that actually mean? 72 ppi is actually short for 72 pixels per inch. That means within a single inch on screen, there should be 72 pixels or squares of color crammed into it. So now coming back to our image assets, you can see in these folders we've got the 2 times image assets or 3 times image assets, and for iPhone notification you can see that the size is defined as 20 points. So that's a set size on screen. Why do we need large and small graphics for the same size display? Well, this is where Retina screens come into play. Now, we've all heard about, the beauty of Retina screens, how amazing they are, and we can see for ourselves that they are so much sharper. And the reason why they're sharper is because on a normal screen, you have a single pixel in a single point. So 1 pixel equals 1 point. So that's on a normal screen. But on a Retina screen, they've managed to cram 4 pixels into a single point. So overall, you can see that the lines are less jagged. So essentially, if you're looking at a 1x image, in a single point, there will be 1 pixel. And if you're looking at a 2x image, then in a single point, there'll be 4 pixels. And in 3x images, which is for the iPhone Plus screen, which has ultra high resolution, you're able to cram 9 pixels into a single point. Now remember that the point is the length of measure that doesn't change. So you're cramming more of these pixels into a fixed size. And this is why when you compare an iPhone 3GS versus an iPhone 6 Plus, it's a whole world of difference in terms of resolution. So nowadays, in most of the development projects or app projects, you'll see people have stopped creating and providing 1x images because the app itself doesn't support an iOS version that's low enough that can be used on an iPhone 3GS or an iPhone 4. So the screens which actually require image assets at 1x. So in most cases, it's very easy to understand, why you wouldn't want to just provide a 1x image and allow the computer to scale up because it would look blurry. But what about the other way around? One of the most frequent questions we get is what happens if you try to downscale an image, i.e. only provide 3x assets and let the iPhone or let the computer downscale it for the lower resolution screens? Well, the problem here is that for the very thin, very small components of your image, say if you had lines in your image that were 1 pixel thick, they would actually completely disappear when downscaled to a 1x image. So from our point of view as iOS developers, or indeed as designers, we have to make sure that we provide all the icon image assets for all of the different size categories. So if you take a look at the course resources list for this module, you can see that there's a link to Apple App Icon Guidelines. And this takes you to a really riveting read that's written by Apple called the Human Interface Guidelines. But in it are some really useful pieces of advice, all about how you should design your app icon, but also all of the icon sizes that you would need for all the different places and purposes. So have a read of that when you're designing your app icon. If you found this episode interesting and you want to learn more about how digital graphics developed over the years, there's a link, again, in the course resources list to a YouTube video by the guys at Ahoy. It's a really nice summary of the history of graphics, especially with relation to video gaming and how we managed to overcome some of the constraints of computing in order to generate really awesome graphic animations. So yeah, check it out if you're interested. Now, in the next lesson, I'm going to be showing you step by step how you can design your very own app icons and app image assets. So for all of that and more, I'll see you on the next lesson. All right, guys. Now, as you know, in all of the projects that we get you to build, we've already created all of the designs and the assets that you'll be using to build the apps. This makes your life a lot easier, and it means that you don't have to spend time creating all of these design assets by yourself. But in the future, when you're building your own apps, you'll probably want to create your own app icons and your own image assets. So I just wanted to quickly show you how you can do this in the easiest and fastest possible way. So in order to do this, we're going to use a browser-based tool called Canva, and it's completely free to sign up and to use. Now, in the later parts of the course, when we talk more in depth about app design, I'll be showing you how to use more professional tools such as Sketch and Marvel. But in this case, we're just going to sign up for a free account on Canva. So just head over to canva.com and go to Education and go ahead and sign up for an account. And once you've signed up and logged in, then you should see a page that looks something like this. Now, in order to create an app icon, we need to create a new design that has custom dimensions. So we're going to choose this, and then we're going to type in 1024 pixels by 1024 pixels, and just check that you've got pixels selected and click Design. So now here's our blank canvas that we're going to work with in order to create our app icon. Now you can head over to the Elements tab to see a whole bunch of things, such as different shapes that you can use. So if you wanted to add a circle that is some sort of horrible yellow color, then you can. Or you can click on the illustrations to use some of their free illustrations for your app icon. And Canva's really nice in helping you figure out where is the middle of things. For example, when you drag it close to the center, you get these margin lines popping up just as you do in Xcode. And you can also search through their giant list of images and icons just for whatever it is that you want. So for example, if I wanted a clock, then you can see that some of these are paid for, but most of them are for free. So I'm quite happy with my design. I'm just going to change the background to something completely weird and wacky. And you can, of course, upload your own images that you find on the web or that you own. So once you're done with your design, then simply go ahead and download it as a PNG, and we can move on to the next step. Now, as I mentioned in the last lesson, you'll need to create your app icons in a whole range of different sizes. Now, if you didn't want to spend your time resizing app icons, then a really neat tool is something like appicon.co, which is an app icon generator, which you can also use for free, which will automatically generate all of the app icon sizes that you need. So all you have to do is drag on that design that you created just now, then select the icon you want. So for example, if you have an app for iPhone, iPad, and Apple Watch, then you'd keep all of these selected. And if you didn't need Mac and Android, you would unselect those. So in our case, I only want app icons for iPhone and iPad. So I'm just going to click the button to generate. And we've now got our app icons as a zip file. And if you unzip it, so on a Mac, that's simply just double clicking on it, you will end up with a folder that's called assets.xc assets. And if you expand that folder, there's something called appicon.appiconset, and in there, there's all of your app icons. Now, for the keen-eyed amongst you, these names might seem a little bit familiar, and I'll show you why. So let's open up Xcode and let's create a new Xcode project. Now, it doesn't really matter what you put here because we're not going to be actually using it. I just wanted to use this project to demonstrate to you how you would incorporate those images that were generated automatically. So over here, you can see we have this folder called assets.xeassets, and the app icon generator also gave us a folder called assets.xeassets. So what you can do is you can simply right click on the assets.xeassets folder and click on Show in Finder. So now this is where this folder resides on your computer. And if we just bring up that other folder that we had inside our downloads folder, you can see that they are named identically, appicon.appiconset. And what you can do is you can simply delete it over here by hitting Command and Backspace. That puts it into the trash. And from your downloads, the folder that contains all your app icons, you can simply click, drag, and put it into your assets.xeassets folder. And you can see that in the back, automatically, we've got all of the app icons in all of the sizes that we needed. And it's been placed into each of the placeholders completely automatically. Now, you might get a little warning here, and if you click on it, it tells you that the app icon set has an unassigned child. So sometimes with these automatically generated icons, you might get one too many designs or one too few, and you can see if you scroll down to the bottom, there's one image that's been unassigned. So that means that there's no space for it to go. So just click on it and hit the backspace to delete it, and your warning will go away. This is just a very quick and very easy way of creating your app icons. Now, by using the app icon generator, you can also generate image sets in 3x or 4x sets for iOS or for Android. And it works exactly the same way. So you just drag and drop the image that you want to create in 1x, 2x, 3x, or 4x, and then you just click generate. So in the future, once you've completed the course and you're creating your very own apps, this is a very quick and easy way of generating your app icons and your image assets. So I hope this has been helpful, and I'll see you on the next lesson. All right, so this is the moment that we've been waiting for. All of our hard work, we finally made the I Am Rich app. So let's give it a spin and run the app. So firstly, let's recap that down here, you're able to set the canvas size. And we have designed our app on an iPhone 8 size canvas. So when you switch down to a smaller size, such as the iPhone SE or the iPhone 4, it will change your design. Now, in the Dicey tutorial later on, we're actually going to be addressing auto layout and how to set constraints. So how to set up rules that determine where your images and where your labels should be displayed on the screen in relation to the size of the screen, so that our design can look good on all screen sizes and orientations. But for now, we're going to keep it as our iPhone 8 canvas. And we're going to run it on the same size simulator. So if we go into this drop-down list, by default, the iPhone 8 Plus is selected, but we'll just go ahead and change it to the iPhone 8 to match our canvas. So we're building our I Am Rich app onto the iPhone 8 simulator. So there's a few ways of running your app. You can either press the play button over here. So the top bar is actually very similar to iTunes, and by pressing play, you'll build and run your app. Alternatively, you can go into Product Run, or you can just hit the Command R button, which is what you'll be doing as you're running your app more frequently. So again, I'll point out, have a look at the keyboard shortcuts document, and you can start practicing using some of these shortcuts. They'll make your life so much easier in the long run. So let's go ahead and click Run. And we can see that in the status bar, it's telling us that it's building. So the first time that you load up your simulator, it's going to take a little while for it to boot up. And the simulator is essentially an application that's pretending to be an iPhone running on your Mac. Now, it's got artificial constraints in terms of memory and storage. Obviously, the memory capacity of your MacBook is far superior to your iPhone or iPad. But it does have simulated constraints. So when you do try to use more memory than you can on a normal iPhone, it'll crash your app in the same way that it would do on a physical device. So the first time you load up the simulator, just give it a bit of time for it to boot. And then once it does, it will automatically load up and switch on the app. Now, this is really important because if I just go to Hardware Home, when the app is first loading up on your simulator, you'll see the home screen like this. It's very tempting to just click on the icon to launch the app. Now, the reason why you shouldn't do that is because when Xcode opens up the app by itself automatically, that's a connected session. So the simulator and Xcode is connected. So Xcode knows what's going on the simulator, and you can receive debug logs, etc., which are really useful when we start trying to figure out what the errors are. But when you just click on the icon, it actually loads up the last version that you installed onto the simulator, which is older than the version that we're currently trying to run. So for example, let me show you this. If we go into Hardware Home, you can see the icons over there, and I'm just going to stop this session over here. And then I'm going to change this so I delete the image view of the diamond, right? So this is a different version from the previous one. But if I go ahead and press run and I click on this one, it'll still show me the older version until Xcode actually kickstarts the latest version. So always let Xcode open up the app. Don't tap on the app icon. Especially when you're running it on your phone, because you're so used to it, it's just a very natural thing to do. But this can be a source of errors later on. Okay, cool. So let's just undo that. This is another helpful hint. So you can use Command Z to undo any action that you just did, and Xcode remembers your steps. And the other thing is that you can hit Command S to save your project, but in most cases you won't need to because Xcode auto-saves every 2 or 3 seconds. But if you're paranoid like me, then having this Command S twitch in your left hand is probably not a bad thing either. All right, so that's it. So we've managed to build our very first iPhone app. We've designed it, we've incorporated labels and image assets, and we've run it on the simulator. So in the next episode, we're going to explore how to take this app onto a physical device. Now that requires a few steps just because of the security settings that Apple have put around being able to load up an app onto your phone. But we'll show you how to do that in the next episode. I'll see you on the next lesson. All right, so this is the moment that we've all been waiting for, when we get our app that we've built in Xcode onto our physical iPhone. So in order to do this, we have to do something that's called side loading. So similar to downloading, it's essentially installing the Xcode project onto your phone and being able to open it and view it on the iPhone. Side loading is in fact something that's actually quite new to Xcode. So this feature was released in Xcode 7, so the previous version of Xcode. And what it allowed people to do was to be able to have the apps that they've built, that they've coded up themselves, loaded up onto their own iPhones. It sounds crazy that this is something that Apple has only recently allowed you to do for free. But essentially all that it means for us is that we don't have to get an Apple developer program until we're truly ready. It's a membership which costs $99 per year on a rolling basis. So if you're not yet ready to upload your app, say if you're still building it or you're still testing it, then there's absolutely no need to sign up to it straight away. You can use your normal iCloud account in order to download apps onto the iPhone. Now we're about to take you through how to sideload your app onto your phone, and these are some of the things that you need. You need your login details for your normal iCloud account, so this is the one that you use to download apps from on your phone. So you need those details handy. You need your iPhone, you need a USB cable to be able to connect your Mac and your phone. You need Xcode open as well as internet connection on both the phone and the Mac. So once you've got all those things ready, go and head over to the next lesson where we'll show you all the steps that's required in order to download your app onto your phone. All right, see you there. All right, so now that we're ready to sideload the I Am Rich app onto our iPhone, I'm just going to run you through the steps that are required in order to achieve this. Now, because of Apple's stringent security requirements, there's quite a few hoops that we have to jump through. The best thing to do is to watch this video from beginning to end once, then watch it while you do it, because it's quite fiddly and there's quite a few things that has to happen in sequence. But don't worry, because we'll guide you through every step of the way. Just before we get started, one thing to keep in mind is that if at any point you see a pop-up occur from Xcode that says something like keychain wants to use something about keychain, something with a lock, something that looks like this basically, make sure that you put in the password for your Mac. So this has to be an admin password to your Mac for the user that's currently logged in, and it's the one that you use to log onto your computer basically. And then make sure that you click always allow. Now, this is something that can trip students up, and remember that if you accidentally click deny, there's a few steps that you have to go through in order to fix this, and it's quite burdensome. But I've included a link to how you can fix that if that does happen to you. So again, if you head into the course resources list, you'll be able to see down here in module 3 for sideloading in iOS, there is a section where it says troubleshooting keychain problems. And if you do come into those issues because you accidentally clicked deny, then you can go through all of these steps in order to try and fix it. But the best way is just to keep an eye out for this pop-up, and if you see it, click always allow. So we've got our completed I Am Rich Xcode project that's open. First and foremost, the most important thing you have to ensure is that your Xcode version matches with your iOS version on your iPhone. So firstly, let's quickly do a version check. This step is really important because if the versions are unmatched, your Xcode won't be able to build your app onto your phone. So firstly, go to Xcode, go to About Xcode, and you can see the version. And at the time of recording, we're currently running Xcode version 10.0. So in the future, that could be 10.1, 10.2, etc. But the important thing is that if you're running Xcode version 10, you have to make sure that your iPhone has also been updated to the latest version of iOS. So that's iOS 12. So if you haven't done that, then this is a good time to just pause and make sure that you've updated all of your software so that they play nice with each other. Now, let's say that, for example, you're running Xcode version 10.1, and on your iPhone, you've got iOS version 12.1. Now, that number in purple is really important because it doesn't matter if you're using Xcode 10.0, 10.1, 10.2. Now, as long as those numbers match between your Xcode and your iOS, then you are good to go. Now, if they don't, then this is a good time to update both your Xcode and your iOS to the latest versions so that they do match. And this will ensure maximum compatibility and reduce any sources of errors when we try to run our app onto the phone. So you can check the iOS version by going into Settings, then General, then About, and there we go, 12.0. So iOS 12.0 matches with Xcode 10.0, but not 10.1. For that, you would need to update to iOS 12.1. All right, next step, we need to head back to Xcode and go into the I Am Rich project folder in the Navigator pane. And then we're going to select Targets, I Am Rich, and then make sure that we're under the General tab. So when you're here, you should be looking at a screen that is pretty much exactly the same as mine. And the first thing to make sure is that we've got a unique bundle identifier. So here it should have a reverse domain name structure. So com.johndoe is the example account I'm going to show you. If you want to know more about the bundle identifiers, you can look back at the previous lesson when we talked about that in detail. But as far as we're concerned for now, all you need to make sure is you put in your full name in here and that it's unique. If somebody else called John Doe made an app called I Am Rich, then you can just go ahead and add in your middle name and it should work just fine. Right, next, we have to make sure that this checkbox next to automatically manage signing is ticked, and this will allow Xcode to create provisioning profiles, set up your developer certificates, and do all of the code signing for you. Now, we used to have to do all of this manually, and it was a lot of hard work, but since since Xcode 8, this is something new, and hopefully it'll make things a lot easier. Great, so make sure that's checked. Next, we're going to go and look in team. So at the moment, no team is selected, and what we're going to do is we're going to add an account. There we go. Xcode takes you to the preferences panel, and we're going to add in our Apple ID. So this is the iCloud account that you normally use to download apps. So it doesn't have to be a developer account, which you have to pay for. It can just be a free iCloud account. I'm just going to put in my burner account details to show you the whole process. So you put in your email in the Apple ID, and then I'm just going to put in the password and click sign in. There we go. So you're now added as one of the Apple IDs that can develop apps. So if you click on it, you can see over here, you've got your name, personal team, and role as user. Now, if you have a Apple developer account, it will just say your name or your organization name, and the role should be agent. But for now, this will do just fine. Now that we've added an account, let's go back to this general tab and change the team from none to that account that we just added. It should appear in the drop-down list. Now, at this point, you might see some further errors come up because nothing worth doing is easy, right? So this says that it's failed to create provisioning profile and no profiles were found. So in order to fix this, we have to proceed to the next step. Now, firstly, you have to make sure that your iPhone is connected to your Mac using a USB cable. Just check to make sure that the connection is working by looking for the charging symbol. Now, once you've done that, head over to Product, Destination, and you should be able to see your device listed under device in here. Now mine's called Angela's iPhone, yours will be called something else. But usually if you only have one device connected to the Mac, whatever shows up here should be your iPhone. So I'm just going to click that, and you can see over here now the destination's changed. So this shows that we're building the app I Am Rich onto Angela's iPhone device. Now this is also a place where you can select the simulators or your device. Alright, now at this point your errors might all disappear, but you might get a different error which says the app ID com.johndoe.iamrich cannot be registered, and instead you have to change your bundle identifier to a unique string to try again. So that's basically saying that there is somebody else out there who has claimed the com.johndoe bundle identifier on the App Store. So in order to make this unique, we can either add in a middle name or we can add in some numbers, right? John Doe 123. And now if I click on try again, then it will try to register this new bundle ID and the new name for my app. And you can see that now we should have no more errors left. So there's a couple of things to check if you see any errors down here. One is making sure that your app is plugged in via USB and that you've got it selected over here as your device. So you can go over this way, or you can go through Product Destination to choose your device. But either way, you should see your own physical device listed up here in the status bar. The next thing to check is make sure that your team has been selected and click on any fix error buttons that you see down here. Now finally, make sure that your bundle identifier is unique, and if you get the error that I showed you earlier on, just try to change this part to something completely different, or try to add some numbers or add some letters. Just as you would register for a username, you can try to make it more unique in case somebody else has taken your bundle identifier already. So we'll keep Angela's iPhone selected, and I'm just going to go ahead and click run. Now, the first time that you connect up your phone to the Mac, you'll see a lot of things happening in the status bar here. Now, it'll say that it's trying to create symbol files or it's indexing, and what it's doing is it's basically trying to grab all of the hardware and software data from your iPhone so that Xcode can know about your device. And can build projects appropriate to that device. For example, what size is the screen, and very cleverly even knows what is the color of your phone, because my iPhone is actually a white iPhone, which I think is very clever. All right, so after all of that hard work in the status bar, we can see this error message. And this is basically telling you that you have not trusted the developer profile, so the iCloud account that you just set up on your phone. So let's go ahead and do that. Click OK and dismiss that alert, and we'll head into settings, then General, then scroll down and you should see Profiles and Device Management. Now, this is quite important. If you haven't tried to run the app onto your phone first, that will only say Profiles. So we first have to fail in order for this to work. And then we're going to click on Profiles, Device Management, and there it is, Developer App. And you can see the app that you're trying to build, and you can trust this developer on your iPhone. Go ahead and click Trust. And now we're done. Now we have to go back into Xcode and run the app again. So just to confirm, we're running I Am Rich onto Angela's iPhone device, and we're going to click Run. And this time you can see everything works perfectly. And we've managed to successfully sideload the app onto our iPhone. Now, I know it's a little bit more complicated than it needs to be, but all in the name of Apple security. So make sure that you followed all of those steps and just go back and watch the video if anything looks different or, works slightly different when you try it out. So one last tip before you head off is that if you have an iPhone device that can not upgrade to the latest iOS version. So for example, if you have an iPhone 4, then you actually can't update to iOS 11, for example. So I think the last version that you can update to is 9.3. So if you're in that situation and you're confused about how to match it with your Xcode version, because at the moment we're running Xcode 9.0, so you would need iOS 11.0. Now there's actually a way of getting around this. And in this situation, what you tend to see is that you see your phone show up here, but then it says lower than deployment target, and it won't let you run your app onto your iOS device. So in these cases, what you're going to do is you're going to go onto the general settings pane, as we were before, and you're going to scroll down to this part where it says deployment info, and you're going to change the deployment target to the iOS version that you've got on your phone. So say if you can only update to 9.3, then you're going to choose a minimum version of 9.3. And then if you head back over here, you'll see that your device is now accepted, and that little excerpt that says lower than deployment target should disappear. So you can also change this deployment target to your iOS version. So now that you've managed to install your app onto your phone, you can go ahead and show everybody that you know and show them how awesome your app is. So we're going to get ready to go on to the next project, which is building a app challenge. And I'm going to tell you all about it in the next lesson. So I'll see you there. Now, one of the new things that Apple introduced is something called wireless debugging. And that basically allows us to run our app through the air over a wireless connection. And that's really awesome because what if you want to build your apps in a cafe on the go and you forget your USB cable? Well, in this lesson, as a bonus lesson, I want to teach you how you can run your apps through the air using wireless debugging. Now, this is completely optional, and in most cases, you would probably prefer to have your phone plugged in via USB because everything will just run that much smoother and that much quicker. But this is a neat thing to learn, and I want to show you how you can do it. So the first time you do this, you have to have your phone plugged in via USB. Make sure that you've got your phone plugged into the computer and your phone is charging to make sure that the connection is valid. The next thing you're going to do is you're going to go into Window, and then we're going to go to Devices and Simulators. Now here you should be able to view your phone under the Connected tab here, and all we're going to do is just to select this Connect via Network checkbox, and we're going to make it checked. All right, so now we're going to close this down, and I'm going to unplug my phone from the USB, and then we're going to go to Product, Destination, and you can see that my iPhone is showing up and it's available to run despite it being completely unplugged from my computer. And now we can go ahead and click play. And now my app is installed and running on my iPhone completely wirelessly through the air. Okay, things are getting serious. We're getting on to our first coding challenge. So I just want to take a few moments to explain what exactly the challenges are and why they're really important. So first and foremost, we've designed the syllabus and the curriculum to slowly ramp up your programming learning. So building knowledge on top of previous knowledge and slowly ramping up the difficulty. And the gradient of the ramp is determined over years of testing of the course, making sure that each step is not too big a jump so that it won't be too difficult to scale. So one of the important things to understand with learning programming is that it's very easy to teach you a lot of information, but that information doesn't become knowledge until you put it into practice and becomes your own. So as you're scaling this mountain of information and you're learning more and more things about programming, about all things related to iOS development, is that there's a lot of information and there's a lot of new concepts that you're taking on board. So without a way of solidifying that information, without a way of using what you've learned, that information will go away, which is where the coding challenges comes in. So the idea is that we ensure you understand and retain the information that's presented in the tutorials by getting you to do these coding challenges. Sometimes they're coding challenges, sometimes they're design challenges. And these challenges roughly outline the steps that you need to undertake in order to build the final product. So in the beginning of the challenge, we'll show you what the final product should look like, and we'll take you through the steps that are necessary to get you to that final product. But all of the coding, all of the designing, all of the creative part is all on you. There's no screenshots, there's no videos of me showing you step by step how it's done. But at the same time, there's no new concepts that's presented. So it's all stuff that you've done before, that you've learned about in the tutorials previously. And it's just a way of solidifying that information and making it your own. So without further ado, let's get on to the first challenge so that you can learn by doing instead of hearing me talk about it. All right, see you there. All right, so first things first, what are we going to build with this challenge? Well, it's very simple. It's using all of the skills that you've learned from the previous tutorial, from the I Am Rich tutorial. And now that you've been rich, it's time to be poor. So we're making an app called I Am Poor. And it's going to look like this. So it's got an app icon of a piece of coal. And when you tap on it, all it does is shows you that I am poor and displays the image of the piece of coal. So this is something that you could show people when you're walking down the street and people are asking you for money. You can show them this app, or you can not because they might just steal your phone. But the important part is getting your head around Xcode and all of its various buttons and various inputs and various tools and dragging and dropping and all of these things. In the next few lessons, there's going to be a few steps which you have to complete by yourself in order to create this app. And once you've got it up and running, either on the simulator or on the phone, and it satisfies some of the basic criteria like having a label saying I am poor, showing the image view with the coal image that's adequately resized, as well as being able to change the background color and just making it look nice. So it's a very simple challenge and we're going to guide you through it. So see you on the next lesson. So in order for us to work on our first challenge, we have to download a project stub from GitHub. Now, what exactly is GitHub? You might have heard of this service, especially if you work within the tech community, but it's essentially a place where programmers can upload their code and share it with others. And at its heart is a piece of technology called Git. Now, Git is an open source project that was started by the founder of Linux, Linus Torvalds. Both GitHub and Git have a number of features that are really useful for developers, but the most important feature is version control. Now, what exactly is version control? Let's think about a problem. Say if we had two people, Yolanda and Peter, who both wanted to work on a piece of code. Now, they can either share this piece of code by, Yolanda first getting it and working on it, then later Peter gets to work on it. But the problem is that there's a lot of waiting and there's a lot of lost time. So what's another option? What if Yolanda and Peter both download a copy of the code and work on it separately? But the problem here is that you might get broken code, you might end up losing files, and bits of code might get overwritten. So it's a really disorganized and poor solution. But if we had version control, then the master copy can be stored on a central server where nobody can edit it directly, but can edit versions of it. So then both Yolanda and Peter can get an updated copy of the master file and work on their own versions locally. Now, when Yolanda is done with editing her file, she can upload and merge her branch with the master copy. So the master copy is now updated to the latest version, i.e. Yolanda's version. Now when Peter is ready to work on the file, he can download an updated version of the file from the server, and everybody is always working on the most recent version. Now what if Yolanda and Peter were both working on the exact same part of the code file? Then what happens is that the first person who's ready to merge, say Yolanda, gets to merge her file with the master branch as usual, no problems there. But when Peter wants to merge his version, and he will get an error telling him that there's conflicts between his code and the master copy. So he'll get to manually review the differences. Now he can either override the master copy, having reviewed the differences, or he can change his own copy so that that part isn't affected. And finally, he can edit the final version so that it incorporates parts of both files. So this way, lots of people can collaborate on the same project without having problems with working on different versions of the file. Now, usually GitHub and Git are used for code files, but it doesn't have to be. You can keep different versions of your PDF files or Word documents. The benefit is that if you save and commit each version of your file, you have an infinite timeline of different versions of that file. So say if you wanted to not just undo the changes within the last day, but you wanted to undo the changes to how it looked in the last month, then you could choose to wind back to that particular version. So this is a really, really useful tool for software developers especially. And in a later episode, when we teach you more about command line tools as well as Git, we'll dive into teaching you a bit more about version control and how you can use it for your own projects. But for now, all that we need to know is that GitHub is essentially a cloud-based service that allows software developers to upload their code and share it with others. And that's exactly what we're going to do. You're going to use an Xcode project that we've shared on our GitHub account. And the reason why we've built these skeleton projects for you to download and use is because in iOS development, there's a lot of tedious tasks such as dragging and dropping and designing the layouts. And we think that, once you've done these tasks 1 or 2 times, you don't need to do it again and again. It becomes very, very tedious. So we want to teach you as much as possible, as fast as possible. And that's why we've created these skeleton projects with the designs already set up, with the image assets already incorporated. And this way it saves you time, as well as getting you to learn more things and do more interesting things. So in the text below this video, you'll find a link to our public GitHub account, and it will take you to the IMPOR directory where our skeleton project is hosted. And in order to make a copy of this Xcode project, you have to go to clone or download. If you're familiar with Git and the command line, then you can go ahead and clone the repository. But if you're not, then just go ahead and download the zip file. Now, the zip file will show up in your downloads folder, and then you can click on it to unzip the file, and you should be able to find a folder called iMPOR master in your downloads file. Now in here, there's all the files and image assets that we've already incorporated, and all you need to do is just double click on the Xcode project to open it. Now you might get an alert like this, and you can go ahead and just click open. And we promise that there's nothing bad on these files other than perhaps bad jokes. Alright, so now that you've opened up the Xcode project, the first thing to do is to edit your bundle identifier. In here, we've left a placeholder for where you can put your name, and just make sure you update this before you carry on to do anything else. Otherwise, when you try to build it, you might have a few errors. Alright, so first things first, go ahead and have a look inside mains.storyboard, and you can see that we've very kindly left it completely blank because you're going to be doing the designing on this project. But if you have a look in the assets.exe assets, we've very kindly done all the dragging and dropping and incorporated all the image files that you need for this challenge. All right, I think it's time to get onto the challenge. So if you head over to the next lesson, there'll be instructions on what the first step is to do. All right, see you there. Alright guys, we're back with another app tutorial, and this time we're going to make a Las Vegas dice shaker app. This is going to be really useful for all of those betting needs of yours. So in the previous two tutorials, we've learned about the interface builder, how to design and lay out our app, and you've actually had a go at doing it yourself by making I Am Poor. So if you haven't done the challenge I Am Poor, I strongly urge you to go and do it before you continue, because it's really important to get the hang of all those little buttons in Xcode, and it's only when you start doing it without the tutorials that you really get to grips with the whole thing. So go ahead and finish that challenge if you haven't. And for those of you guys who have already completed I Am Rich and I Am Poor, it is time to start building the Dicey app. Now, this is actually a very simple app, and let me just show you what it looks like. So here's Dicey, let's launch it, and it's just two dice images with a logo at the top and a button at the bottom. When I press the roll button, you'll see that the dice faces change, just like a real dice shaker. Now, you're not going to be able to see this, but just trust me on this. I'm going to shake my iPhone, and you can see the dice changing its dice face. All right, cool. So this is what we'll be building, and it's a very simple app, but it's a really fundamental app to get to grips with some of the most important parts of app programming. So up till now, we've only been really working with interface builder and designing and image assets. So it's all about the view and the appearance. But in this tutorial, we're going to be diving deep into coding, and we're going to be addressing some of the most fundamental parts of iOS development. So we're going to be looking at collections, namely arrays. We're going to be seeing how to link up your design with your code. We're going to look at IB outlets, IB actions, how they work, and some of the common bugs that arise with those things. And finally, we're going to be looking at randomization, methods, functions, and all of the core pieces that really make up an app. So it's a very simple app, it's a very simple tutorial, but it's going to cover pretty much 90% of the stuff that you're going to use on a day-to-day basis when you're developing apps. So I can't wait to get started teaching you guys. So head over to the next lesson once you're ready, and we're going to learn how to make the Dicey app. All right, so first and foremost, we are going to start a new Xcode project. So you're already pro at this, so you should know what to do. So again, you'll see the Xcode welcome screen, and we're just going to click on create a new Xcode project. And we're going to choose single view application under iOS, click next, and we're going to name our product Dicey with 2 E's because that's obviously cooler than 1 E. Now, team, you can leave none if you don't have one. Organization name, put it as your own name, and organization identifier. Again, this is a reverse domain name with either your full name or your company web address. So if you get confused about any of what I've just spoken about, go back to the I Am Rich tutorials, and we've covered all of this in detail. So take a look at that if any of this sounds confusing. So make sure that your language is selected as Swift and keep all of these 3 unchecked. And we're just going to click next. Cool, I'm going to save it on my desktop, making sure that the source control is unchecked, and I'm just going to go ahead and click create. All right, so now that we've set up our new project, we're going to go ahead and design the storyboard. So head over to main.storyboard over here. And remember, if you don't have your file navigator showing, you can toggle it like so. Great, so now we can see our design canvas, and we're going to go into the object library over here, and we're going to search for UI image view. And there it is, image view. So we're going to drag it onto the canvas, and we're going to align it. So as soon as you move it around, you can see that Xcode starts being helpful, or sometimes not so helpful, by giving you all of these margins. So we're going to shift it right up to the top left corner, and then I'm going to toggle it to make it fill the entire screen. And I'm going to show you a bit later on how to set up constraints and use auto layout to make your screen look beautiful no matter what screen size you're running your app on. So that's all to come, but for now we're just going to drag on a UI image view and make it fill the entire canvas. So now that you've got your image view, which again, as a reminder, an image view is just a picture frame. In order to add an image to our image view, we first have to have those images incorporated in our Xcode project. And if we have a look over here in the assets.xc assets folder, you can see that we've got absolutely nothing, nada in here that we can use. So first, of course, we have to add our image assets. So we've pre-made the image assets for you in all the right dimensions. Now, in order to download the image assets for the Dicey project, we're going to go again to our trusty course resource list, and we're going to scroll to our current module, which is module 5, Build an iOS Dice app. And you can see over here we have a link to download the Dicey app assets. And once you click on it, download should start automatically. And if you're using Chrome, then you can just go ahead and click on this in order to extract the zip file. All right, so once you've downloaded and extracted the image assets, you should end up with a folder that looks like this. Now, when you use an online service such as appicon.co or one of the other apps that you can get off the Mac App Store that generates app icons in all of the dimensions that you need, what you'll end up with is a folder that looks something like this. It's called appicon.appiconset. And if you expand it, you can see there's a whole bunch of images in there, and there's something called a contents.json. Now, this is a file that is going to tell Xcode where to place all of these images into the app icon slots. And I just want to show you quickly how you can really easily incorporate all of these icons into your project and make your life a lot easier. So firstly, we're going to go into our Xcode project, and at the place where it says app icon, making sure that you're inside the assets.xc assets folder, we're just going to right click on this and we're going to say show in Finder. Now, this is going to bring up the assets.xc assets folder inside Finder, and you can see that here there is a folder that is named appicon.appiconset, inside of which there is a contents.json. So currently this folder is completely empty other than this file, which says that there's a whole bunch of things that it's expecting, all of these empty slots. Now, what we're going to do is we're going to delete or throw this into the trash, and we're going to get rid of it. So now you can see that app icon has disappeared from our assets.xc assets folder, and you can see it says it's an empty catalog. But no worries, because we're going to import our app icon set that we have from our Dicey image assets. So you're going to take this entire folder that contains all of the app icons and the contents.json, and you're just going to click and drag it over to your assets.xc assets folder. Remember, this is the folder that is going to be responsible for delivering the assets to your Xcode project. And you can see as soon as I've dropped that in, now I have the app icons show up, and it's all been automatically added. None of this dragging individually business, which makes it so much easier and so much quicker to work with. So that was pretty much completely pain-free. Now, the next thing that we want to add into our assets folder are our dice images. Now, while this assets.xc assets folder is open, you can simply select all of your image assets and drag it into here. Alternatively, you can just drag it into Xcode just as we did before and let it go inside this pane here. So both do the same thing, and they add our images into all three slots, and everything is now filled up and ready to go. Now that we've incorporated all our images, it's important to check that your assets folder looks very similar to mine. So you've got dice 1 through to dice 6, all the dice face images. And we've got a Dicey logo as well as a new background. So once you've confirmed that you've got all the images that you need, we can go back into main.storyboard and slot an image into this image view. So again, making sure that you've got it selected either on the canvas or in the document outline. We're going to head over to the attributes inspector, which is over here, and we're going to change the image that's held inside the image view. We're going to start writing new background, and there we go. Xcode has already suggested that maybe we want the new background image. So just hit enter and you'll see it appear. A lovely green felt background for our Las Vegas dice app. Okay, so once that's done, the next step is putting in that dicey logo. So again, we're going to need a new image view. So in my objects library, I've still got image view showing up. If you don't, then you can just go and type UI image view again to search for it. So we're going to drag this one on close to the top-ish, somewhere that looks reasonably good, and just drop it down. Okay, so time for a challenge. Now, throughout these video tutorials, I'll be issuing challenges that test your understanding and your grasp of some of the things that we've covered. So there's no point just watching me do everything and follow step by step, because you're never going to be able to really make it your own. So instead, what we're going to do is I'm going to announce that here's a challenge, and it's something that you would have done before or immediately before, and you're going to try and do it yourself. So this is a good point for you to pause the video and go into your own Xcode project and try to figure out yourself. And then afterwards come back and see if the solution matches what you did. So are you ready for your first challenge? All right, so the first challenge is to simply add the dicey logo to this brand new UI image view. So pause the video and try out the challenge now. So did you remember how to do it? Now, if you didn't, this is just a quick reminder. With the image view selected, we're going to head over into the Attributes Inspector and change the image to Dicey Logo and click Enter. There we go. Now, one thing about this image is that you can see that it's slightly stretched. It looks a little bit odd, and that's because our content mode is set to scale to fill, which is not what we want, because it stretches the image in a non-proportional way. So we're going to hit this drop down and we're going to change it to aspect fit instead. Now you can see the proportions are back to how they should be, and the image looks a lot nicer. Right, so next we are going to design our dice faces. So there'll be a total of 2. So we're going to drag on 2 image views onto our canvas. Now, instead of just resizing it by eye, this time we're going to resize it more precisely. So very often when you're working as an iOS developer, especially if you're working with professional designers, they'll actually provide you with exact location and sizes of all your UI elements. So we're just going to select one of the UI image views, and instead of being in the attribute inspector, we're going to head over to the size inspector. For our first dice face, we want the X value to be 40. So right next to the left, and then we want the Y value to be 273, and the width and the height to be both 120. There we go. And the other one, we're going to resize, again, X to 215, Y is 273, and the width and the height are both, again, 120. There we go. So now, as long as your canvas is the same size as mine, just check to make sure that you're inside the same canvas size as I am in portrait, then your screen should look exactly the same as mine, because we've precisely inputted both the location as well as the height and width of our image views. So now it's time to put in some pictures. To do that, remember, we have to be inside the attribute inspector. And I'm just going to put dice 1 in both of them, because right now it doesn't really matter. So now that we've done this the proper way, this is a good time to show you a quick tip. So if you have lots of image views or buttons or whatever it is that are duplicated, such as we've got here, instead of creating them manually one by one, as we have done just now, you can also just click and select the item that you want to copy and hold down Command C to copy and Command V to paste a copy of it. Now that's pretty standard. Now another way of doing this is simply selecting the item you want to copy, holding down the Option or the Alt button on your keyboard, click and drag, and you will create a new copy of whatever it is that you selected. So that means that you can select more than one item, and then again hold down Option or Alt, click and drag the mouse, and you'll end up with lots of copies of what you had previously. All right, so let's make sure we get rid of all of these so they're not cluttering up our screen. Right, so just one last step to complete our design, and that's having a button. So a button that's called roll, and when you press it, we can change the dice faces. So again, we're going to head over to our object library, and we're going to search for button or UI button. And there we go. And we're going to click and drag it onto the screen. Now, it doesn't matter right now where you leave it. We're going to adjust that later on. But firstly, we're going to modify the appearance of this button to something that pleases us. So we're going to change the title of the button from button to roll, or something else that makes sense to you. We're going to change the font by clicking on this small T button here and going from system to custom. And I'm going to change the size to maybe 30 or 40. So this depends on you again. See what looks right to you. After all, you are designing your own app. And there we go. There's our roll button. Now, the blue doesn't really show up very nicely with the green, so I'm going to change the text color to white, and I'm going to change the background of the button to have a color. Now, unintuitively, the button background color isn't located near the rest of the color settings, but instead it's quite a few scrolls away down here. And I'm just going to pick something that I used recently, like this nice salmon color. But you can also change it to something of your own liking, and then picking any color that takes your fancy. But I'm going to stick to a salmonish color. And then we can just adjust the button to make it look reasonably nice. And there, I'm happy with my design. So go nuts. This is your design. Do whatever you like. You can really make it your own. Now, just before I end this lesson, I just wanted to point you towards one thing that you might notice up here, which is this little yellow triangle, and it's got a little number next to it. And this tells us that we've got one warning on our current file. And when you click on it, it brings up the error pane on the left-hand side and tells you why it's showing you an error or a warning. So warnings are yellow and errors are red. If you have any errors in your code or in your project, then you won't be able to build it or run it. But if you have a warning, then you can still build it, but it's just kind of Xcode giving you a hint saying, hey, maybe there's something wrong here. You should check it out. So this one says that views without any layout constraints may clip their content or overlap other views. Now, what does that mean in English? Well, at the moment, we haven't defined any rules as to how all of our image views and background views should be displayed. So that means that if we try to run this app on a very small device, say something like an iPhone SE, iPhone 5 sized, or even smaller like an iPhone 4, then you can see that we've lost our roll button and our right dice looks like it's been trimmed off. Now, a little bit later on, we have a whole module dedicated to this, which is called Auto Layout and Setting Constraints. Now, if you want to skip ahead and learn that module now, then it's completely up to you. But what I recommend is to simply ignore this warning for now and continue learning along the track that we've designed, which is getting you started on the programming and getting an overview of Xcode projects and iOS apps. And then only when you reach the module, which is all about setting these rules and constraints, then do we come back and fix our design and make sure that it looks good on all devices and all orientations. And it's perfectly safe to ignore this warning for now. Alright, so that's all for this lesson. In the next lesson, we're going to be looking at how to link up all of these designs with code. How we can start making the roll button actually do something when we click on it. How we can change the dice image faces, all by writing our own code. All that and more in the next lesson. So I'll see you there. Okay, so now that we've created our designs for our beautiful dicey app and that you're happy with how it looks, the next step is to actually let the code files know about these designs. So as you can see, we're currently in the main.storyboard, which is a design file. And if you actually right click on it and go to open as source code, you can see that this is actually just XML code, which stands for Extensible Markup Language. And it looks very similar to HTML for those you guys who've dabbled in that. If you've never dabbled in any sort of HTML, CSS or anything, it doesn't matter. Don't worry about it. I'm just showing it to you to show off how much I know about coding. Just kidding. So the important thing is that whenever you're making designs, in the interface build, which is the canvas view, whenever you're changing anything or when you're adding something, Xcode is actually very cleverly writing the XML code for you. So this makes life a lot easier for us, and we don't have to concern ourselves with this at all. But in order for us to write some code that changes the way that the app behaves, we need to let the code files know about the designs, right? So the things that we're going to change in our app are going to be the dice faces. So we're going to change these images randomly to show different dice faces when we press the roll button. We also need to let the code file know about this roll button so that it knows when it gets pressed and whether if it needs to change its appearance. So these are the two cases in which you need to link up design with code: when you want to change the appearance of something, or when you want the code file to know when an action has been performed on something. So I'm going to show you how we do that. First and foremost, we're going to go into this two little circle icon at the top, and this is the assistant editor. It's really useful because it allows you to split the screen into two, and you can see the design file next to the code file. Now, I'm working on a 13-inch MacBook at the moment, so I'm going to need a bit more real estate. And some of you guys might be working on even smaller screens if you're using the MacBook or the 11-inch Mac. So we're just going to give ourselves a bit more room by getting rid of that utilities pane. And also, I'm going to close the document outline just by clicking on this tiny button here. So now we've got ourselves a bit more space to play with. And I'm going to show you how to link up the designs with the code. So first, we're going to link up this leftmost image view, and I'm going to hold down the control button on the keyboard, and then you're going to click and drag so that you see this blue line appearing on your view controller file. Now, you can drop it pretty much just below the line that says class view controller, UI view controller, and then it has this little pop-up. And it asks you what kind of connection do you want to make, and we want to just check that the connection type is an outlet, and the name that we're going to give it is going to be called Dice Image View 1. And the type of the UI element is, of course, a UI image view. That's the one that we dragged on, and that's the one that we're trying to set a connection for. And storage weak. Now, don't worry about weak and strong and whatever else for now. So this is something that we'll cover much later on once we've grasped all the fundamentals. So just ignore that for now and just make sure that it says weak. Now, I'm just going to take a moment to quickly point out something. Whenever you see programmers naming their variables or naming anything, most of the time, you'll see this type of convention. This is called camel case. So the first word begins with a lowercase letter, and every subsequent word is capitalized. And this is very common in programming because it allows you to differentiate each of the words quite easily. And it's called camel case because the camel has a lower head than the rest of the humps. Or I think that's why it's called camel case. Or it might just be because I have an overactive imagination and there's a complete different reason why camel case is called camel case. But either way, when you're naming your variables, make sure that the first word is not capitalized and every subsequent word is. Okay, so once you've checked and that your little pop-up looks exactly like this, we're just going to go ahead and click connect. And there you see, Xcode has written a line of code for us. I'm just going to give it a bit of space. So it's always important to try and keep your code as tidy as possible. I'm not a tidy person, but I'm a tidy programmer, just because it helps you so much when you're debugging. When you've got thousands and thousands of lines of code and everything's all mushed together like spaghetti, it's a really tough job. So make life easy for yourself. Give everything a bit of space. Okay, so now here we've created an IB outlet, which is what this is called, Interface Builder Outlet, to this particular image. And we've called it Dice Image View 1, and it is of type UI Image View. So the two things to note is the type of connection, IB outlet, and the name, which is Dice Image View 1. The other things to ignore for now is the weak and the exclamation mark. These are things that are a little bit more advanced, and we're going to come back to them once we get to that stage. For now, all we need to know is that we're making a connection between the design file, main.storyboard, and the code file, viewcontroller.swift. And this link or this connection allows us to refer to this design in our code, as we'll see a little bit later on. Now, there's something important that you should notice here, which is this little circle. Because when I hover over this little circle, it actually highlights where the connection is going to. So this is really useful. And if that circle is not like this, instead if it's empty, then it means that connection is not active. So let's go ahead and just connect up the other image view. So again, holding down Control, clicking and dragging over to here. If you don't have a wireless mouse and you're working with the trackpad, it is equally simple. Just click and drag. That's all you need to do. You might need to mess around with it for a little bit, but just Control, click, drag. And as long as you see this blue line appear, you've hit gold, basically. Now we're going to slot this just underneath the other IB outlet that we created over here. And again, making sure it is of connection type outlet. And the name that we're going to give it is Dice Image View 2. Type UI image view, storage, weak, and then we're just going to go ahead and click connect. There we go. We've got our two IB outlets set up. Now, the last one that we're going to set up, the last connection, is to the roll button. Now, this one's a little bit different because instead of being an outlet, which if you remember from early on, is something that changes the appearance of a UI element, user interface element, we're going to create something else that's called an IB action, which allows the code to respond when a user interacts with it. So same as creating the other connections, holding down Control, clicking and dragging. But this time we're just going to put it here, just above the last curly brace, and then we're going to let go. So we're going to change this connection type from outlet to action. And then we're going to give it a name called roll button pressed. And we're going to change the type from any object to UI button. And the event is touch up inside. Now, there's various ways that the user can interact with it. They can most commonly touch up inside. Now, this is nothing naughty. I know there's going to be you guys out there with a terrible mind, but all it means is that the user has touched the roll button inside the boundaries of the button and let go while they were inside the boundaries of it. So that defines a common tap, basically. Now, there's other ways that you can interact with that button. For example, touch drag outside, which means that you tapped the button, you've dragged your finger outside of the constraints of the button, and then you've let go. So that's defined as a common drag, essentially. But we're going to keep it as touch up inside, and in pretty much 99% of the cases, you will be using this particular event. So you don't even have to change it. It's the default. Okay, so check that we've got an action. We've named it roll button pressed. Type, we've changed it to UI button. The event is touch up inside. And we're going to go ahead and click connect. Now, as you can see, this looks different from this. Now, this is an IB outlet, which changes the appearance of the UI element, and this is an IB action that notifies the code when the UI element is interacted with. Now, you can see that the difference between this, other than the fact that this is IB action, this is IB outlet, are these little curly braces. Now, in programming, you have to realize that code gets executed in blocks. So these two curly braces are essentially defining what should happen when the roll button is pressed. This is the start of what will happen, and this is the end of what will happen. So you should view all bits of code as blocks of code. This is a block of code, this is a block of code, and this is also a block of code. So say if I wanted to change the dice face, I would put my instructions in between these curly braces. If I were to put my instructions here, for example, outside of this closing brace for this block, then it wouldn't happen in synchrony with this roll button pressed action. Okay, so that was basically us setting up 2 IB outlets and 1 IB action. Now you'll have noticed that when you try to connect a UI image view, when you look at the connection types, it only has an outlet or an outlet collection type. But when you try to link up a button, you've got both the outlet and the action types. Now, why is that? It's because the button is slightly more advanced than the image view. The image view, you can only really change its appearance. But the button, you can actually change both its appearance as well as notify the code when it gets tapped. So buttons have both actions and outlets, and image views have only outlets. And that's something that's quite important to understand. But we're going to be doing this again and again and again. So if this is the first time you're encountering IB actions, IB outlets, don't worry if it doesn't all make sense immediately. We're going to let you do this a few times and you're going to eventually understand exactly what it is that it does. So in the next episode, we're going to talk about a really common error that new iOS developers make, and it is related to the IB outlet and IB action connections. So it's really important episode to watch because it happens so frequently. We see it in our in-person programming boot camps. 99% of people will make this mistake. So I'll see you in the next lesson and we'll talk about one of the most common errors and how to debug it. All right, see you there. Last episode, we learned about how to link up our design file with our code file by creating these IB outlets and IB actions. Now, today, we're going to talk about one of the most common mistakes that people make when they're new to iOS development. And I'm first going to replicate how this mistake gets made. So if we have a look over here, my first IB outlet is called Dice Image View 1, which is exactly how we wanted to name it. But the second one, I've accidentally spelt it wrong. Now, the error happens when you try to go and fix it. So let's see if I can do that. So instead of calling it, I can't spell Image View 2, I'm going to call it Dice Image View 2. Right. Okay, so now it looks great. I've fixed the spelling error. But the first indication of a mistake that we're about to make is if you look at this little circle. Do you remember before we mentioned that when the circle is filled, it means that the connection is active. But now the circle is actually empty and it's not linked to anything. And if I go ahead and run this app right now, you will see it crash and, well, hopefully not burn. And now our app has crashed. So what you notice when your app crashes is you'll get this red highlighting here. And usually, if we had a little bit more space, you can see that it has a little bit of text that says thread 1 signal sigbot. Now, this is not the most useful part to figure out what's actually gone wrong. The most important part that will help you sleuth and figure out what caused the crash is down here. And this is, of course, in the debug panel. And whenever there's any errors that gets printed or outputted here, it will pop up automatically. Now, if you don't see this in all of this text, it might be because this is actually toggle closed. And the buttons for it are down here. And they're also super tiny. So we can get rid of the left side pane or the right side pane, and we can toggle between the two of them or have both of them show up, which is how you should have it. So make sure both of these two buttons are blue so you can see everything inside the debug console. Now, when you look at the debug console, the most useful piece of information is inevitably at the top. And what you're searching for is some sort of reason why your app has crashed. And if you scan through all of this, you'll see something like this. Terminating app, which means your app got terminated, i.e. it got crashed, due to uncaught exception, NS unknown key exception, and the reason for the crash is because inside this dicey view controller, there's a class that is not key value coding compliant for the key I can't spell. Now, this, to translate into English, means that The design file was looking inside the viewcontroller.swift file for something that was called I can't spell. And if we take a look at our code, well, that's because we changed it and we deleted that thing. So if I hit Command Z to go back on this file, then you can see that previously this outlet was called I can't spell. And when I restore it to this, then you can see our little outlet indicator is now filled once more. So what's happening here is we have a design file that is pointing towards something called I can't spell inside the view controller file. And you can see this when you toggle open the right hand pane and you go to the connections inspector over here and you select the item for whom you want to see their connections. So you can see that this image view has a referencing outlet to something called I can't spell inside the view controller. And it's exactly this that is actually breaking our file at the moment because it can't find it in this view controller file. Now, why is this happening? I thought we were just dragging and dropping and adding images. Well, remember how I said previously that when you're doing all of this design in your main.storyboard or in your interface builder, you're actually getting Xcode to write code in the background. And if you scroll all the way down to the bottom, you can see that there's a whole bunch of connections and they have something called an outlet. Now, there's one outlet that's pointing towards a property called dice image view 1, and there's another one pointing towards something called I can't spell, which no longer exists, and that is why we're getting this error saying that this class is not key value coding compliant for the key I can't spell. So if you make a mistake in how you've spelt something over here, or if you wanted to simply delete it outright, you have to remember in the back of your mind that you can't just do it inside the code file because there's a counterpart inside the design file. And just now I showed you that there's this connections inspector which you can look at. You can also right click on any element and you can see all of its connections. Now, when you say want to delete that line of code that we had earlier on, you can't just delete it in the code file. You first have to find the element that it was linked to, right click on it, and click on this tiny little cross to break that referencing outlet. And then next, you can go ahead and delete this line of code. Now, that is one way of doing it, but what if you simply just wanted to change the name? Well, the easiest way of doing this inside Xcode is right-clicking on the name and then going to this part where it says refactor and rename. And now it'll show you all the places where it was used, firstly in the viewcontroller.swift and secondly inside the main storyboard as an outlet. And if you edit it over here to dice image view 2, then Xcode will edit its name everywhere. And now if you click rename, then you can see that little circle is still filled in and the outlet has now been changed to point towards dice image view 2. So this is an error that trips up newcomers to iOS development all the time. And in order for you to not have your apps crash and have something terrible happen to you, just remember to come back and have a look at this lesson when you see that error, when right at the top you got something about this class not key value coding compliant, or something about NS unknown key exception, and remember that it's probably related to one of your IB outlets or your IB action not being deleted or renamed properly. So keep a note of this particular error and make sure you have a look back at this video if anything similar like this happens to you. But otherwise, I'll see you on the next lesson. All right, so just to recap, in the last episode, we learned about how we can link up our design with our code file using these IB outlets and IB actions. Now, this gives us exposure to these design elements in our code file. And in this episode, we're finally going to start coding and start using some of these exposures. So the first thing that we're going to do is we're going to create what's called a variable. It's basically just a container that holds data. And we're going to do that just under the class declaration right here. And I'm going to write var, which is the keyword to create a variable. First variable is called random dice index 1. And it is of type int or integer, and I'm going to set the value of this container to equal 0 for now. So if you head over to the course resource list, you'll find a Swift cheat sheet that we've created for you guys that allows you to get an overview of how various coding elements are constructed. So firstly, we're going to zoom in on the variable section. And I'm going to draw your attention to this line, which is where we create a variable. So in order to create a variable, you use the keyword var, you give your variable a name, and then comes a semicolon, and you declare the type of data that your variable is going to hold. Remember that a variable is just a container for data. And then you finally give your variable a piece of data, say a number or some text. And later on, if you decide to change your variable or change the contents, you can just simply use the name of the variable and set it to something new. So let's take a look over here at the different data types, or some of the common data types. So int stands for integer, which is whole numbers. Then comes floats and doubles. Now both floats and doubles can hold numbers with decimal places. A double simply holds a number with more decimal places. So depending on how accurate you need your data to be, say if you wanted the number of pi to 20 digits after the decimal point, then you might choose to use a double, especially for scientific calculations. But if you just needed to do some basic decimal point mathematics, for example, to input somebody's height in meters or somebody's weight precise to 2 decimal places, then a float is probably a better bet. So then we've got the bool, which stands for booleans, which can only hold the values true or false. Then finally we've got strings, which are essentially strings of characters. So most of the time that's your text. Although of course you can store a number as a string, you just won't be able to do any mathematical calculations with it. So let's go back to our Xcode project for Dicey. Now it's your turn to make the next variable. So go ahead, pause the video and make random dice index 2. It's also a variable. It has data type int, and it is also going to be set to 0. All right, so how did that go? If it went well, then it should look something like this. Random dice index 2 is the name. We gave it the var keyword, and then we're going to use a semicolon and give it a type. It's also going to be an integer, and we're going to set the value of this variable to 0 as well. Now you can see it's pretty much identical to the variable that we created just above it, but it's got a slightly different name. It's the second random dice index. Great, so why do we need these containers called random dice indices? Well, we're going to generate some random numbers between 1 and 6 essentially. So if you think about our dice faces, there's only 6 possible images that we've got. Dice 1 to dice 6. And in order for our dice app to work, we need these images to be displayed up on here randomly. So we're going to create a random number generator, and then we're going to use that number to pick out a random image so that the user can see their dice on the screen. So the next step is to create this random number, right? So previously we said that you can create a variable and then you can set it at a later stage. That's exactly what we're going to do here. So inside the curly braces for roll button pressed, remember when you press the roll button, everything between this closing brace and this opening brace is where your code will get executed. And that's exactly where we want to create our random number. So let's go ahead and delete this comment. And inside here, we're going to tap into that container, random dice index 1, and we're going to set it to a new random integer. So we'll tap into the integer data type, and we're going to write dot random. And we're going to select the first one and hit enter. And once we've inserted that bit of code, we've got this little blue part that shows up, and this is just a placeholder. You can simply click on it to turn it blue and then hit the backspace to delete it. Now we're creating a new random integer, and we have to specify the range of our random integers that we want to make. So in our case, we want random numbers to be generated between 0 and 5. So what you'll write is the lower bound so the starting point of all of your random numbers, then 3 full stops or 3 dots, and then the upper bound of all of your random numbers. So what this line of code will do is that it will create new whole numbers that are random between 0 and 5. So that means that the data that gets stored inside random dice index 1 could be 0 one time, it could be 3 the next time, it could be 2 the next time, etc. So this is how easy it is to generate random numbers using the new Swift 4.2 syntax. So this, of course, relies on the fact that you have Xcode 10 installed and you are running iOS 12. Now, if you're using an older version of Swift in an older Xcode, say Xcode 9 or 8, then you'll have to use a slightly different method because this is something that we got only very recently in Swift. And it makes it a lot easier to create random numbers. In the next lesson, I'm going to show you how you can do the same thing, but in older versions of Xcode. So now that I've created a random whole number between 0 and 5, so that's from 0 up to and including 5, then it's your turn to try this out for random dice index 2. And in this case, we want exactly the same thing. We want it to hold a random number between 0 and 5. So pause the video now and see if you can complete this challenge. All right, so it's easy enough. All we have to do is tap into this second variable called random dice index 2, and we're going to reset its contents from 0, which it originally had, to a new value. And that new value is going to be a random whole number created using this int.random syntax. And it's again going to be from 0 all the way up to and including 5. So we can have any random numbers basically between 0 and 5. Okay, cool. So just to recap, we created 2 variables that's going to hold the random numbers, and then we generated 2 separate random numbers between 0 and 5. So the important thing when coding is that you should really check to make sure that your assumptions are reflected in the results. So let's go ahead and test out our code. What I'm going to do is I'm going to use a print statement to print out the result of random dice index 1. And we're going to run the app and see what happens. So either Command R or just press the play button. So this bit of code should only get triggered if the roll button is pressed, and only these 3 lines should get triggered when that happens. Okay, great. So we've got this showing on the screen. Nothing's happened so far, and we're just going to go ahead and press roll button to trigger these 3 lines of code. Okay, so looks like it's working, right? It's generating random numbers between 0 and 5. So everything seems to work well, and I can stop my app from running and I can close the debug area. If you assume that as you're writing code, you're constantly introducing errors into it, now for some people this might not be true, you might be really, really diligent, but for most of us this happens a lot. People create bugs and the bugs get bigger the longer that you don't test your code. If you test it on a regular basis and test all your assumptions as you write them, then you're less likely to make mistakes. So in this lesson, we've created 2 brand new variables, gave it an initial value of 0, and then later on, once the roll button is pressed, we change that value to a random number. As tested, generates a random number between 0 and 5. And in the next episode, we're going to talk in depth about variables, constants, and data types in Swift. So I look forward to seeing you there, and that's all from me. Okay, so in the previous episode, we created 2 variables called random dice index 1 and random dice index 2. In this episode, we're going to dive a little bit deeper into what variables and constants are and why they have data types associated with them. Okay, so open up your Xcode instead of going into creating a new Xcode project, what we're going to do today is we're going to use a playground. Now, this is something that Apple created to help people explore various ideas, essentially test out your code without having to have it associated with a design file or indeed an app. So open up your Xcode and we're going to click on Get Started with a Playground. And today's topic is going to be about variables, constants, and data types. So that's the name I'm gonna give it. Okay, so this is a brand new playground and I'm just going to maximize the screen here so that I can show you as much as I can. Now, the first thing that you notice here is this little blue line and a little play button. And this shows that currently our playground is in the manually run mode, which means that we have to press this button every time we want our line of code to run. Now, the beauty of playgrounds is that you can write some code, test it out, and see what happens before committing to a fully fledged app. Now, before we proceed, the first thing I'm going to do is I'm going to switch off this manual run mode because I want my code to be executed automatically every single time I type a new line. So to do that, I'm going to pull up this debug section down here and I'm going to click and hold on this play button. And now I get two options. I can get my playground to automatically run or manually run by pressing the play button. So we're going to switch it over to automatically run. And you can see now you have this little blue play button and we get rid of all of those smaller buttons, and now every single time I type a new line of code it will automatically run everything I type. And already in here you can see that it's preloaded with a single variable called string and its value is hello playground. We're just going to delete that because we're going to be creating our own. So remember, the first thing we type is the keyword var to show that we are creating a new variable, and then you give it a name. So for example, my new variable is going to be called my age. Now remember that in programming, when you're naming variables, when you're naming functions, it always follows camel case. So lower caps first and then every subsequent word is capitalized. This makes it easier to see and makes it less prone to errors. Okay, so a new variable called my age, and it is of type integer, and I'm going to set it to equal 32. What if I wanted to change this variable at a later stage? What if, 1 year has passed and my age is now 33? Well, add 1 year to it. So then I would only use the name of the variable. So notice that when I'm changing the value of the variable, I don't have to use the keyword var. That var is only for creating it. So now my age is equal to 33. And that was pretty easy. And if you look on the side of your playground here, now this is the beauty of playgrounds. You can essentially see your variable values at all times. Normally when we're working within our code projects, in order to see the values of these variables, we have to make it show up on a label, which will show up on the app, or indeed we use the print statement where we get it to print to the console. Now, by having playgrounds, essentially it just saves you this step of having to print it out so you can see all the variables as and when they are created. So let's get rid of that print statement. Now, what if I wanted to make a different type of variable? Say I wanted to make a variable that held my name. Well, my name is something that doesn't really change very often. So there's no point using a var keyword to create a variable. Instead, what I can do is create a constant that doesn't ever change in value. So to create a constant, the keyword instead of var is let. And then I give it the name of my constant, which is going to be called my name. And it is of type string, of course, because name is going to be text. And then I'm going to set it equal to Angela. There we go. Now, if you try to change the value of a constant, for example, like we did with my age, my name now equals, I don't know, Jane. Xcode will complain and tell you that this is not allowed, and you can see the error reads, cannot assign to value my name is a let constant, and it points out exactly where this error is. So let's delete that line and make Xcode happy. So you can't change the value of constants. So essentially, you should consider variables and constants as containers or boxes that can hold values. And I'm going to show you in a bit more detail what I mean by this. If variables and constants are both containers or boxes that can hold values, then variables are essentially boxes that have an open lid. You can open it to put in a new value, such as a number in this case, and then you can take that value out and put in a different value if needed. But when you're dealing with constants, you're essentially dealing with a box that only allows you to put in a value once. Afterwards, you have to tape it up, seal it up, and you cannot change the value inside anymore. So variables and constants are used differently. Variables are there to keep track of the state of your app. So for example, which level is the user on, how many monsters have they killed, etc. But constants are there to hold pieces of data that never change. For example, your API keys or a URL. And constants also take up less memory space than variables. So let's head back over to our playgrounds and see what else we can do with variables and constants. Now, using variables and constants, it's quite easy to manipulate the values that are held inside. So for example, if I wanted to create a new constant called let my age in 10 years equal, then I would use my age and then I would just add 10 to it. So this is adding an integer to an integer, which of course has no problems. And my age in 10 years now equals 43, added from 33. I can do the same thing with strings, but of course you can't calculate strings. So what happens is that you can concatenate strings onto strings. So for example, let my full name equal my name plus a string that's a space plus my surname. And now you can see my full name now equals Angela Yu. So previously when we were printing out, so this is one way of doing it. Another way is using the escape backslash. Let me show you what I mean. So say if instead of writing let my full name equals my name plus my surname, what I can do is open up two quotation marks. Everything inside is going to be a string. Then I use the backslash and I use two parentheses, and inside I put in my variable, which is called my name. And then to that I add a space and I add my surname. Or if I had not just my name but my surname, then I can also just put in a space and then escape and then add my surname into here. And that would also give you the same result. My full name now equals Angela Yu. Now, of course, this isn't going to work when you mix up the data types. So what do I mean by that? If you try to add a string, so denoted by the quotation marks, called 10 to my age, then Xcode will complain and tell you that the binary operator plus cannot be applied to operands of type int and string. It's saying that you're trying to mix up a number with a string and it doesn't really know what to do with that. So that's not going to be allowed. Let's change that back to 10. So say if I wanted to print out my full details, so my age and my name, how would I do that? Well, you can use the backslash to escape your variables. Let me show you what I mean. Let's say we write let my details equal two quotation marks. So previously when we declared all our variables and constants, we've been explicitly telling Xcode what the data type will be. So for example, my age is going to hold integers or whole numbers, and my name is going to hold strings or text essentially. Now in this case, I'm actually letting Xcode infer the data type of my constant my details, because I'm opening up the 2 quotation marks, it instantly knows that it's going to be a string that's going to go inside, and the type of my details is automatically assigned as string without me having to explicitly state what type it is. Now, the beauty of this is that you cut down on typing, but the inconvenience is that it's harder for you to tell what the type is without having it explicitly written out. So different people have different preferences. I tend to prefer not to explicitly state the data type just because it cuts down on time, but occasionally when working on collaborative work, and if the style guide of the project is that we explicitly state all our data types, then that's the way you go. So it really depends on choice, and you'll get a feel for what you prefer. Now here I'm going to create a string called my details, and it's going to hold both my name as well as my age. So how do we do that? Well, what you can do is you can use the / escape. So I'm going to write a / and I'm going to open up 2 parentheses, and inside these parentheses I'm going to put in my name, the variable, and then I'm going to have a comma and a space, and then I'm going to have another escaped variable, and in here I'm going to put in my age. Now, what this implicitly does is that it converts my age into a string and combines them together into this one line, which says Angela, age 33, and that becomes my details. So we briefly talked a bit about data types, but let's make it a bit more clear. When we're talking about data types, essentially you should think about it as one of these children's toys, the shape-fitting toy that you give 1-year-olds to play with. And it's pretty simple. You take the shape that fits the particular hole and then you put it in there. If you get the wrong hole, then of course it won't fit. And this is a really good analogy for variables and constants because they all have a fixed data type. So for example, if I had a variable that could only take strings as values, then if I try to put in a string, say ABC, then there's obviously no problem and it fits in easily. But instead, if I try to put in an integer, say 12, then it would give me an error and it won't let me do it. So each variable and each constant has either an implied data type based on the first value it was assigned, or it has an explicit data type which you tell it. So let's head back to our playgrounds and let me show you a few more data types. So we've already seen whole numbers, and those are of course of type int or integer, and they're essentially just numbers, can be negative or positive. Then we've seen strings as well, so that's usually for text, and it is of type string, so a string of characters strung together, such as ABC, and they're denoted by the quotation marks around them. Now what we haven't seen is booleans. So booleans are a data type that can only hold true or false, and the type is bool with a capital, and they can either be true or they can be false. Now another data type is the floating point number, or usually declared as a float. And these are your numbers with decimal places after them. But if in your programming you need numbers with decimal places to a high degree of accuracy, say if you're doing scientific calculations, then you will need to use instead something called a double. These are essentially 64-bit numbers, so they have a higher level of precision, and that allows you to have a number precision up to about 15 decimal places, whereas the float can only give you about 6 decimal places. So those are some of the most basic data types, and you'll be coming across some other data types during our programming lessons, and we'll mention them as and when we go along. But the most important parts to remember from this lesson is that variables and constants are essentially containers for data. With variables, you can change the value that's contained, whereas with constants, you can only assign it a value once. And with both variables as well as constants, they have a data type associated with them. And this can either be inferred from the value that you place inside the variable, or it can be explicitly typed, such as here when we declare that it is a string. So that was a brief intro to data types, variables and constants. in the Introduction to Swift Programming section, we're going to be diving a bit deeper into this, as well as other programming concepts. So I'll see you on the next lesson, and we're going to continue building our Dicey app. Okay, so just to recap, previously we created two new variables called random dice index 1 and random dice index 2, and these were created as containers to store some new random numbers that we would generate. Now we've got this machine essentially that spits out random numbers in the range between 0 and 5, and then we printed out the results. So in this lesson, we're going to cover how to change the image property of UI image views and also how to create arrays. So first things first, how do we change the image views? Now we've got these two image views that are linked up to IB outlets. Now there's one way that's very intuitive, and that's of course clicking on the image view and changing the image here to say dice 2. But the problem is, once the app is up and running, we can't exactly go back into our code and try to change these properties. It won't affect the app that's already running. So instead, what else can we do? Well, the other option is that we can programmatically change it, which is what we'll do. So in order to change this image view, I'm going to have to make a reference to dice image view 1. And so we can type in dice image view 1 dot, and then we're going to change one of dice image view 1's properties, namely the image property. So remember that image views are simply picture frames, and they have different properties. For example, they have a size property, or they have a background color property. But the one that we're going to change is its image property, so which picture is slotted into that picture frame. And we are going to set it to a UI, user interface image. Now, user interface image is a data type. Just as strings is a data type or integers are a data type, UI image is also a data type. And we're going to use a special function called image named to pull up an image from our assets.xc assets folder. So if we just briefly remind ourselves what those images were called, they were called dice 1 through to dice 6. Now, you might remember when we dragged these images into the assets folder, they had a .png as the extension or the file type. Now, you don't have to worry about that. Once it goes into Xcode, it knows how to deal with all of that, and all you have to do is refer to it by its name. So let's make it the same as this one. Let's make it show the image of dice 2. Now, just one thing to note is that whenever you use the tab button or enter button, just as when I started typing named and Xcode gave me the right suggestion, it always gives you this light blue placeholder. Now, what the placeholder is telling you is to click on it and change it. And it's giving you the data type of what you should put in here. And in this one, it's a string because I'm going to put the file name of my image here. And remember that strings are always denoted by quotation marks around them. And we're going to go for dice 2. Now, if I hit run, let's see what happens. Okay, so was that what you expected? Or did you expect that our code would change the dice image view 1? Well, let's review. Where is this line of code? It's right here. And it's between the closing and opening braces of the IB action roll button pressed. As we said previously, everything in between here only gets executed when the roll button is pressed, hence the IB action. So we will only expect this line of code to execute when I press the roll button. And there you go. Okay, but now we've got the same problem, right? Every time we press the roll button, it only displays the dice 2 image. And that's not a very fun app. Now we want the possibility to display all 6 images. And we're going to pick out which image that gets displayed based on this random number that we created, right? So in order for that to happen, we have to have somewhere in our code that stores the data about all of our image names. So here we're going to introduce you to the array. Now firstly, I'm going to type the let keyword. Now previously we've seen the var keyword used for variables. And in this case, we've got the let keyword that's used for creating constants. So containers that contain data that never change. So say if I wrote something like my name, which is not likely to ever change. If at a later stage I decided to try to change my name, now set it equal to Jane, it will complain. It will not let me do this because it will say that my name is a constant and you cannot change constants. So it's actually suggesting maybe you can change my name to a variable. Now that's not what we want because we are going to create a constant that's called dice array. And it is going to hold all the names of our dice images. And I'm going to create 2 square brackets. Now in programming, you've already seen a whole load of different brackets, braces, parentheses, and it can be really confusing and overwhelming at first. It's really important to make sure that you're typing the exact type of brace or bracket or curly brace or parentheses that you see, because otherwise Xcode is going to get very confused and none of the code will work. So this is very important. Now inside these square brackets, I'm going to put in the names of my dice face images. So that's dice 1. And there we've created our first array that contains all the names of our dice images. Now let's just explain array in a little bit more detail. You should see arrays as essentially egg boxes. They contain things that are of the same type. So for example, you can't have an egg box that contains both eggs and chickens. And similarly, if you're creating an array in programming, you can't have an array that contains multiple data types, such as strings mixed with integers. The next thing to remember about arrays is how we count in arrays. As a normal human being, we would all count beginning with 1. So the stripy egg is 1 and the dotted egg is 2. But programmers, as well as computers, actually start counting from 0. So the stripy egg would be at index 0, the spotted egg would be at index 1. And so say if I created a constant called my egg and set it to the first element in egg array, as you can see above, the 0th element is the stripy egg, and the first element is the spotted egg. So when we're trying to pick out elements from arrays, always keep in mind that you start counting from 0. Now, do you remember when we created our random numbers? And I told you that this is essentially a machine that spits out random numbers in the range between 0 and 5. And that may have seemed a bit strange at first, but it now makes sense because dice 1 is at index 0, 1, 2, 3, 4, 5. Perfect. We have all the numbers we need in order to pick out the right dice image from our array. So let's go ahead and do that. So instead of typing dice 2, literally, let's try and pick it out from dice array. So just as we did with the eggs, we would type dice array, and then we would use the square brackets to pick out a particular one. In this case, it will be 1 and not 0 if we wanted dice 2. So let's go ahead and run the app and just make sure that it worked as expected. Perfect. Works exactly the same as before. Again, we still haven't really improved on our app, right? It only ever shows the second dice. Now what we want to happen is for it to show a random dice. So that means instead of putting in 1 here, which is limiting it to just the first index, i.e. dice 2, what we can do instead is put in that random number that we created up here. So we can put in random dice index 1, and then we're going to run the app and see what happens. And so it works. The app generates random numbers and uses it to pick out a particular element in the dice array and then assigns that image to dice image view 1. All right, so now it's your turn. Let's set dice image view 2 in the same way that we did with dice image view 1 and give it a random image between dice 1 and dice 6 using our dice array. So now is a chance to pause the video, write your code and run your app and see if it works as expected. All right, so did it work? Let's see if this is what you did. So we're now setting the image view on the right, which is named Dice Image View 2. So we can again check that by just going over here. And we're setting its image property to equal a UI image that's named using the dice array. And we're going to pick out a random member of dice array using random dice index 2. Let's run our app. And voila, you can generate random dice faces at the touch of a button. Perfect. So at this point, I'm going to point out a very common error that students tend to make. I said we're going to change the image on Dice Image View 2. And a lot of people just simply take this, copy and paste. Don't be embarrassed if this is what you did, because every single programmer has done a copy and paste job. But the problem with the copy and pasting code is that you tend to get errors. And what a lot of people do is that after they copy and pasted it, they might have changed this number to Dice Image View 2, but they forget to change this number to random dice index 2, and it stays as 1. And this is what happens when you keep it as that. Instead of having two separate dice, you have two dice that simply mirror each other. So this is something to watch out for. And we'll just go ahead and change it back to how it should be. So especially for those students who are starting out with learning programming, it's really good practice to type out all your code instead of copy and pasting, because you tend to run into errors. And we're fortunate here because we've only got, 10 lines of code. You know, when you're working with large projects with 20,000 lines or 50,000 lines, it can be a nightmare to try and find out what happened. So just to recap, in this episode, we created a dice array that held all the image names of our dice faces. And then we used the random numbers that we created in the previous lesson to select a random dice face for our image views. So in the next lesson, we're going to talk a bit more about how to become a better programmer, how to be tidy with your code, how to group functionality together in methods, and how to essentially reorganize our code. Until next time, I'll see you there. In this lesson, we're going to learn about reorganizing our code into functions. I'm mostly going to be working with the code file, so I'm going to get rid of this assistant editor. I can either click this button, or you can use the shortcut Command Enter to make it single screen. And then I'm going to hit viewcontroller.swift to see my code file. Now you can see that we've got a lot of functionality that's inside this roll button pressed IB action. And just to recap, we have two lines that creates two separate random numbers, and then we print one of the random numbers, and then we use those random numbers to change the image view of the dice faces. So for a dice shaker app, this is very common functionality, changing the dice face. So what if I needed that to happen elsewhere? For example, if upon opening up the app, I wanted two random dice faces instead of just having snake eyes all the time, well then I would have to put it within the view did load. And this is a function that only gets triggered at the time point when the view or when the screen loads up. So this is the perfect place to put in the code that's required to generate a new set of dice faces. Now I can either essentially copy all of this and paste it in here, and if I run it, you'll see how it works. So immediately upon the app loading up, we already see a random set of dice faces, and when I press the roll button, it'll continue to give me new random dice faces. That's well and good, but remember previously we said when you copy and paste code, you tend to make errors. And also look at how cluttered our code file has become, with loads of repeated elements. One of the most fundamental principles of good programming is called dry. Don't repeat yourself. So whenever you see repeated code such as these blocks, you should always try to package them into a function that you can call upon when needed. So the less code there is, the less errors there'll be. Let's try and see if we can package this functionality. This closing brace, remember the ones facing left, is closing this opening brace, and together everything in between make up the roll button pressed IB action. Now I don't want to put my function inside this function, that won't work. So instead, I'm going to hit enter and make my new function beneath it. So here, in order to create a new function, I use the func keyword in Swift, and then I'm going to give it a name that describes explicitly what this function achieves. In this case, I'm going to call it update dice images. Now, of course, you can name your variables and functions however you like, but just remember to give it a name that is explicit, and when another programmer comes along and looks at your code, they can easily understand what your functions achieve. So I think this makes sense, update dice images, because this block of code essentially generates random numbers and then updates the image views. So then I'm going to add 2 parentheses, so nothing goes inside these parentheses. In the Introduction to Swift programming lectures, we're going to learn a lot more about functions and their variations, and you're going to understand what these parentheses are for. But for now, we're going to leave them empty. Now I'm going to open a curly brace, and this is the moment when one of the most common programming errors gets generated. So now that I've opened this curly brace, if I leave it as it is and I click away, this closing brace, which used to close the entire class, now becomes the closing brace for this update dice images function. And the class no longer has a closing bracket, which is why there's this error. Your class was opened but was never closed. So to avoid this error, whenever you find yourself typing the open brace, always hit enter straight away. That way, Xcode automatically generates the closing brace for you, and all is well and good with your code. So just remember that little tip to avoid these curly brace associated errors. Okay, so let's check. Great. So this closing brace closes this opening brace, and everything in between is going to be the functionality of our update dice images. So I'm going to take all of this code, and then I'm going to cut with Command X and paste into here. Now, of course, you can type it all out for practice as well, but just to show you, it's exactly the same as what used to be in roll button pressed. And I'm going to get rid of this print statement because it was more for us to find out what random dice index was, rather than having any sort of useful functionality. Okay, so now that we have this function called update dice images, we can now use it everywhere where we need this functionality. So we can get rid of this code inside viewDidLoad, and instead we can make a call to the function update dice images. As soon as I start writing update, Xcode will give me a suggestion, then just hit enter or tab for it to insert it in there. Always try to save yourself work by getting Xcode to insert these function names or variable names. On one hand, you save yourself a bit of time typing. Secondly, you save yourself spelling errors. And because we're dealing with computers, the uppercase and lowercase matters a huge deal. If you typed update dice images with a lowercase d, the computer won't know what the hell it is that you're talking about because it only knows update dice images with a capital D and a capital I. So let's change that back to that, and you can see that the code highlighting goes from black to, when it recognizes, to this kind of indigo color. So whenever you have bits of code that's not got the proper code highlighting, always be wary that there might be a problem with it. So currently when the view loads, we're going to update new set of dice faces, and also when we press the roll button, we want to update a new set of dice images. Now I'm also going to call the method over here. Now at the moment I'm using the words methods and functions pretty much interchangeably. They are different, but the difference is mostly academic. For all intents and purposes, it's okay for you to assume that they're the same thing for now. In a later module, when we start talking about objects and classes and the fundamentals of object-oriented programming, we'll then tease out the difference between methods and functions, objects, classes, etc. So for now, all we have is a call to the method update dice images within viewDidLoad and another call to the method within roll button pressed. So let's run this app again, and if we did everything right, the app should look identical to the last time we ran it. Okay, so initially on loading up, I get a random set of dice faces, and also when I press the roll button, I get random dice faces. So the functionality of our app hasn't changed at all, and that's because we haven't added any new functionality. All we did was tidy up our code and group together all of that functionality within update dice images. And then we called it in view did load and we called it in roll button pressed. Now remember, when we create variables, we use the var keyword, and when we create functions, we use the func keyword. But when we subsequently decide to change the value that's held inside a variable, we don't use the keyword anymore, right? So we just simply say random dice index and then set it equal to a new value. And similarly with functions or methods, when you call it, you don't have the func keyword. Notice the difference between when I call to use the method and when I create it using that func keyword. So what exactly is so great about functions anyways? Why do we bother creating them and using them instead of just typing out and putting the code where we need? Functions are a great way to group together similar commands. Now, for example, if you wanted me to get you some milk and I was a robot, you would have to tell me line by line how to execute this action, right? I would first probably have to take money, open the door, close the door, walk forwards, turn right, walk some more, turn left, go inside the shop, etc., etc., etc. You know, this will be hundreds of lines of commands so that I can achieve just this simple task of getting milk. Now, would you want to write out all of those commands every single day if you needed milk? No, that's why we package all of these commands into one function called getMilk, and we stuff all of those individual commands inside. So whenever we call the function getMilk, the robot will automatically know to execute everything that's inside. So coming back to our Dicey project, that's exactly what we did. We had these 4 lines of code which performs a very simple functionality of updating the dice image faces. And then we've essentially just called this method every time we needed it. In the next episode, we're going to be talking about how to engage the motion sensors in the iPhone and how we can get the dice to roll and change their dice faces upon the user shaking the iPhone. So all of that's yet to come, and I'll see you in the next episode. Alright, so now that we've completed most of the basic functionality within our app, such as the ability to change the dice face images on pressing the roll button, or having new dice face images show up as soon as the app loads up, we want to explore another cool feature. We want to tap into the motion detectors in the iPhone to be able to detect when a user has shaken their phone and then changing the dice faces programmatically. Now, how do we do this? Well, let's see if we can figure it out. Whenever you're miffed about how to implement a certain functionality, the first protocol I recommend is heading over to Google and searching for the functionality that you want. So in our case, we want to be able to detect the shake motion, for example. And after our main query, it's usually a good idea to add the keywords Apple and documentation. This is just so that we can narrow down and focus our search to the relevant information inside Apple's documentation. And the first result that you'll get back is often the most relevant part of the Apple documentation that relates to what you're trying to do. Now, whereas on the other hand, if you try to go through it through the Apple developer website and search their documentation directly, so for example, detecting shake motion, then the search algorithm is not quite as good as Google's, and you get a lot of things that are actually unrelated to what it is that you're trying to find. Now, of course, try out different ways of getting to information that you need, but this is just my personal recommendation, as I find that it's usually the easiest way of arriving at the most relevant piece of information. Okay, so we've landed on this method called motion ended. And what it does supposedly is that it tells the receiver that a motion event has ended. So that's exactly what we want. So let's go ahead and implement this in our code. Now, just below our IB action roll button pressed, we're going to make some space for ourselves, and we're going to start typing the name of that method that we found, which was called motion ended. And you can see that as soon as I start typing, Xcode is already coming in and helping me out with the choices that I have. So we've got motion began, which is when the user begins shaking, for example, motion ended when the shaking has stopped, or motion cancelled. Now, in our case, motion ended is actually the one that we want because we don't really want to change the dice mid-shake, right? So let's go ahead and hit enter, and you can see that Xcode has very helpfully typed out a whole bunch of code, which is very long-winded, which means that it's very easy to make typos and spelling mistakes along the way. So it makes a lot of sense when you're writing code in Xcode to try and search through the suggestions and try and hit enter or tab to get Xcode to write all of it out for you. Now inside here, we've got a placeholder, so we can just go ahead and click backspace to delete it. So this method, motion ended, will be triggered automatically when a motion event is detected and it has ended. So in between these curly braces, we can tell our app what it should do when that has happened. So what do we want to happen? Well, we want to change the dice faces. So I'm going to let you guys pause the video here and figure out how to update those dice images. Okay, so that was a pretty simple challenge. We did it twice in the previous lesson, and yes, you basically just have to call update dice images, our beautiful function that we made in the last lesson. So you can see that potentially we have saved ourselves from writing this in 3 places. So 3 times 4 lines, that's 12 lines of code, which we've cut down massively. And it also makes our code look a lot neater and a lot tidier. So let's go ahead and hit run and see if our code actually works. So we already know that upon loading, we get random dice faces because our function update dice images gets called inside view.load, or when view gets loaded up. We also know that when we press on the roll button, we get new random dice faces, and they should be different between the left and the right. So none of that functionality is new. However, we've also included now a method that detects a shake motion on the phone, and when it's ended, we also call update dice images to update these dice faces. And now, if I want to test out the shake gesture in my simulator, of course I can't shake my Mac. That would be crazy. So don't do this. Don't do this. Instead, you should go into hardware and shake gesture, and it will simulate shaking the iPhone simulator. One thing to note for those of you guys who are testing out this app, you will have noticed that this app doesn't yet look very good when I, for example, turn it into landscape, or when I run it on one of the larger iPhone Plus sizes. And this is because we haven't set up any rules for how the user interface elements should be displayed. In a future module, we're going to dive deep into auto layout and learn about how to make our app look beautiful on every screen size and orientation. So don't worry about that. In this module, we introduced a lot of new programming concepts, and it's far more important to focus on those for now. And so there we go. We've created a Las Vegas dice shaker app that responds to both taps and shake. And in the process, we learned how to link up our design with our code. We learned about how to create IB outlets and IB actions. And then we learned about variables, constants, and data types. We touched upon randomization and creating arrays. And finally, we reorganized our code, created functions, and tapped into the motion detectors. So this is our first step venturing towards app programming. And in the coming apps and the coming modules, we're going to be looking at how to call APIs from the web, how to set up our own cloud database, and much, much more. So I hope you guys had fun while learning Swift and making the dicey app. In the next module, we're going to get you to fly solo. You're going to be creating a magic 8-ball app that gives you all of life's answers when you ask it questions. And the idea is to challenge you guys on what you've already learned, what you've already harnessed, and try to see if you've really understood it and if you can apply it yourself. So that's all from me for now, and I'll see you on the next module when we build a magic 8-ball. See you there. it's time for a challenge. So in the previous apps, we've learned a number of things, such as how to link up the design with the code, how to programmatically change the image views, how to use arrays, how to make functions, a lot of things. And we want to consolidate some of that knowledge by getting you to create your own app. So in this challenge, there's again nothing new being asked of you, nothing that you haven't done before, but it's a way of letting you fly solo and making some of that knowledge your own. So today we're going to be making the Magic 8-Ball app, or you're going to be making the Magic 8-Ball app. Now, what exactly is that? So for those of you guys who are not familiar with Magic 8-Balls, they're basically this phenomenon in the 90s where you shake this ball and then it would give you an answer to all of life's questions. So we're going to try and replicate this, but in an app. So this is what our app is going to look like. It's going to have a set of app icons, which you're going to drag and drop in there. We provided some ready-to-use assets for you. And then when you open it, it says, ask me anything, which is, of course, a label. And then here's an image view that shows you the Magic 8-Ball. And you can press the Ask button to ask it various questions, and it will give you a number of answers based on a random number generator, which you've done before. So it also allows you to shake the phone or use the shake gesture on the simulator to randomly change the image. So this is basically what we're going to be making, and the design of it is completely up to you. As long as you've got the images in there, as long as you've got a button and a label, you can make it say anything, you can make it look however you want, and really, go nuts. Make it as flashy or as crazy as you want it to be. After all, it is your own app. So without further ado, I think it's time for you to create the Magic 8-Ball. At the London App Brewery, we pride ourselves on the curriculum that we've developed that allows anybody, even somebody with absolutely no programming experience, to be able to learn how to code and how to make apps using that knowledge. Now, a lot of the curriculum is designed so that the difficulty ramps up slowly and you get the hang of concepts before we move on to the next one. And some of the more difficult concepts, we'll try to make use of them again and again. And in the previous two modules in Dicey and the Magic 8-Ball app, you created two apps using a number of fundamental programming concepts, such as variables and constants, as well as methods and functions. Now in this module, we're going to give you a bit more background on the programming concepts that you've been using so far. The way that we like to approach programming is to allow our students to use them, see it in action, see the concepts in action, see how they work in real life, and then we teach a bit of theory once you've understood what it does. And this is the first programming module you're going to approach. Now the module is split into different episodes with a title that explains what I'm going to talk about and what you're going to learn in that particular lesson. So if you are an experienced programmer and you're already familiar with types, variables, or if you're an intermediate programmer who feels that you understand some of the concepts and maybe you want to focus more on the Swifty side of programming, then feel free to pick and choose which lessons you want to watch in the programming modules. Now for complete beginners, we recommend that you watch all the videos in the programming modules and follow along with them and writing some of the code as I'm showing you. This is probably one of the best ways to really understand some of the things that you've been using so far and getting a solid foundation in your programming abilities. So without further ado, let's start the first lesson. Okay, so first things first, open up your Xcode, and instead of creating a Xcode project, which is what we've been doing so far, instead we're going to get started with a Swift playground. So go ahead and just click on this one. Now, a playground is something that Apple created that allows you to write code without having it associated with a view or design or any of the rest of it that an app involves. This is a very clean way of learning and looking at Swift code, and that's exactly what we're going to do today. So the topic of this lesson is comments, printing, and the console. So feel free to name your playground whatever you like, but if you're planning on saving it for later use, make sure it has a title that tells you what it does. All right, so let's go ahead and click next. And I'm going to save it to my desktop. Feel free to put it anywhere you like. All right, great. So here's my playground, and the first thing that you'll see is a bit of example code that Apple will include in every new playground that gets generated. And what you can see up here is that the first line here, where it says playground, a place where people can play, is green, whereas everything else is colored differently. Now, when you see something that's colored green in your code, it means that it's a comment. That means that Xcode will ignore it and it won't see it as code. So the way that you comment is by using 2 forward slashes. Now, if I delete these 2 forward slashes, you can see that Xcode is going to start giving me errors because this line was written as an explanation to the human user and it makes absolutely no sense for the computer. So let's put those 2 dashes back in and you'll see the error disappear. Now, one way of commenting is where you just use the 2 dashes to comment out a single line. But if you wanted to write a lot of comments, say you wanted to write a whole paragraph, then what you would do is you would use forward slash and a star to begin, and a star and forward slash to end. And everything in between is not compiled by Xcode and is seen as a comment. So why are comments useful? Well, one of the most fundamental parts of becoming a good programmer is having code that is easily understood. So, for example, if you wrote 100 lines today and you came back in 2 months or 6 months, will you still know how the program functions? Or say if you were working on a collaborative project with another person or a group of people, if they had a look at your code, would they understand your train of thought, your logic? And that's where comments come in. So, for example, if you are writing a function that allowed a robot to butter a piece of toast, you would give it a comment saying, this function enables the robot to butter toast. And that way, when somebody else has a look at your code, they can immediately identify what each part does, if not what each line does. So this is really good practice, and especially when you're learning, I highly advise as you're writing code to comment to yourself what it is that each part is doing or each line is doing. That way when you come back to it, everything is going to be super clear and you can start from where you left off. Okay, so I'm actually going to delete all of these comments. Now the next thing that you see is this import statement. Now it says import UI user interface kit. This is a library of code that Apple wrote that allows developers to create useful code much faster. So for example, we don't have to program up how buttons will function or create our own random functions. And all of this code is grouped together in a neat package called UI kit. And every time we import it, we can use all the things that are inside. So you should see this as a Swiss knife that you're packing along for your camping trip. Chuck it in the bag and you've got your corkscrew, you've got your scissors, you've got your knife, etc. And we'll make use of different types of Swiss knives in the coming apps, and I'll point them out as we go along. Now, the next thing that you see is this line, which creates a variable named string or str, and it contains a value, hello playground. Now, if you're still confused about variables and constants, don't worry, we're going to talk about it in the next lesson. Just go ahead and delete this line for now. Now, what I want to talk to you about today is the print statement. You've seen it a couple of times and you've used it a few times. And the reason why it's really useful is because, say we create a variable called monster health. So say if you had a game where you had monsters and zombies and good people, you would need a way of keeping track of how healthy the monster is or how close to death they are. And let's give it a random value like 19, right? Now, this is something that you should always make sure that you never do, something that I did just now. Swift is a very Zen language and it likes to have balance. What I mean by this, when you use a operand such as the equal sign or the plus sign or the minus sign, you have to give it a symmetrical amount of space around it. So here what I've done is that there's a single space between monster health and the equal sign, and then there is no space between the equal sign and the value that should go into that variable. So this is asymmetrical and Swift does not like that. You can either give it one space either side, which is advisable because this is the most clear way of seeing that, or you can give it no space. People have different ways that they like to structure their code, but for new learners, always give yourself as much space as you can. And as long as you've got symmetrical spacing around the equal sign, you won't have any problems. So keep an eye out for that. Now let's go back to what we were talking about. If we created a variable called monster health and we'll give it a value of 19, now the way that Swift Playgrounds work is that pretty much every single time that you type something new into the code file, it'll show you the values of the variables in this right pane here, which is really useful because otherwise it's very difficult to keep track of what's happening to your variables. So say if I just collapse that for a moment, if I change monster health to equal the original value of monster health, and then I add 22 to it, and then I change monster health again, you know, say that the monster's been really badly damaged, and then I divide it by 2. So this is what our programs would normally look like in Xcode when we're creating our projects. We have no visibility as to what's happening to our variables. Now, of course, I can go through it and calculate it myself, 19 plus 22, and then divide it by 2. What Swift Playgrounds allows you to do is to constantly have the variables visible at all time, what their current state is. So this is really useful. But as I mentioned, normally in Xcode, we don't have this ability. We can't peek at what's happening to our variables. And it might be that, you know, at one point I do something silly like divide it by 0, and I run my app and I ended up getting errors. But you know, without keeping track of what's been happening to that variable, I don't know why it is that I'm getting this particular error. So this is where the print statement comes in. Now, the beauty of the print statement is that you can make it execute every single time you run your app. So inside this print statement, let's put in monster health, and it will print it to the console down here. And all it does is give us visibility into what are held inside these containers, these variables and these constants. And it helps us debug and figure out why we have errors in our code. Now, if you don't see this bottom section, if you don't see the print statements coming up, it might be because it's toggled down. So just head over here to the top right corner, and it's the one in the middle with the line at the bottom, and you can make it show the debug area, which is this part. And of course, you can make the print statement say anything you like. If you remember, in our first exploration of Swift, we got you guys to type out print hello world, and it prints hello world into the console. Pretty simple. So that's basically the print statements and the console. In the next lesson, we're going to be talking about variables and constants. And we're going to understand what's the difference between them, when we would use them, how we would use them differently. And we're going to talk a little bit about the data types that are associated with variables and constants. So all of that and more in the next lesson. See you there. In the last lesson, we learned about variables, constants, and their associated data types. In this lesson, we're going to talk about one of the most fundamental pieces to any programming language, and that's functions. So let's get started with a new playground. I'm going to call it functions. Hit next, and I'm going to again save it on my desktop. Right, so here's my brand new playground, and the first thing I'm going to do is delete everything that's already written on the page, so I have a completely blank playground to play with. Cool, so the first thing I'm going to do is I'm going to create a new function. So let's just remind ourselves of the syntax that's required to create a function. If you look back at your Swift cheat sheet, you'll remember that the first thing that you have to type is the func keyword. Next, you give the function a name, so anything you like, name of function, that's what I'm going to call it. And then you give it 2 round braces, and you open a curly brace. And always remember to hit enter after you type the open brace so that Xcode automatically inserts a closing brace for you. This will prevent 50% of beginner Swift programming bugs. So this is just simply an example of how you create a function, but we're going to make one that's going to be useful. So what exactly do functions do? Well, they allow you to take a large number of instructions and package them into a function. So for example, on the right here, there's a number of steps that's required for a robot to go and get some milk. Now, if I had to tell this to the robot, if I had to give the robot each of these instructions every single time I needed milk, I would go mad. So instead, what we can do is we can package all of these steps, all of these instructions into a single function called getMilk. I can just tell the robot to get milk, and they will look at this function and execute all the steps that are inside. So let's do that with our Swift code. So making sure that your playground is blank, we're going to create a function called getMilk. So first, of course, the func keyword. Now there's something on screen that I want to point out to you. Now if you look in the margin here, Xcode is already giving me an error. And it says something like expected identify in function declaration. Now this is basically Xcode jumping ahead of the gun. I haven't finished creating my function yet, and Xcode is trying to tell me that my function is incomplete. Yeah, of course, because I'm not done yet. So sometimes Xcode can be a bit overeager. So before you've finished writing a function or creating a variable, don't worry so much about these errors. Only worry about the errors when you've completed each line and you think everything should be fine. If there's still errors or if there's still warnings, then they warrant further investigation. So let's continue writing our function and we can make Xcode happy. So first I've used the func keyword to declare that I'm creating a new function. Next I'm going to give my function a name and it's going to be called getMilk. Remember to use camel case where the first word is lowercase and every subsequent word is uppercase. This will allow your long function names to not end up like Twitter hashtags where you can't even read where each word begins and the next word ends. So I'm creating a new function, it's called getMilk. Next I have to give it 2 round brackets, like so. We're going to talk a little bit more about these round brackets in the next lesson, why they're there, how they're useful, and how we make use of them. But for this lesson, just leave them empty and go ahead and create an open curly brace. Now this is a crucial step to get right. When you're writing code, as soon as you type an open curly brace, such as what I've done just now, make sure that you hit enter so that Xcode automatically inserts the closing brace for you. And that's my function completed, and Xcode is now happy, all my errors are gone, and we've created this function called getMilk. Now, what if I want to use this function? Well, you've seen us using functions within viewDidLoad, within IB Actions. Now, in Swift Playground, you can simply call a function or use a function anywhere you like, as long as it's not within the curly braces of another function or method. So I'm just going to go 2 or 3 lines below and we're going to call the function. So I'm going to try to use it. And we call functions by calling their name. So as soon as I start typing get, already auto-suggest is telling me, do you want to use this function getMilk? And if you look at the left-hand side of this suggestion drop-down list, and you've got the word F for function. So this is my getMilk function. I'm going to hit enter, and there we go. We've called our first function, getMilk. But at the moment, getMilk doesn't do anything yet, because if you look within the curly braces of this function, there's absolutely nothing. There's nada in there. So we got to give it some functionality, right? For this lesson, as well as the next few lessons, we're going to imagine that we're programming a little robot, a little housekeeping robot. And it's very helpful. It does some of the chores and it goes to the shop and buys our groceries. So we're going to program one of its main functions, which is getting milk. In order to do that, it needs to perform a number of actions, right? So let's use some print statements to simulate those actions. So you might want to go to the shops, right? That's probably one of the first things that the robot needs to do in order to get milk. Now, of course, in reality, go to the shops is probably subdivided into walk forwards 10 meters, turn left, then walk right 5 meters, etc., etc. But for now, we're just going to leave it as an instruction. Go to the shops, and we're going to go to the next instruction. Let's say we're going to buy 2 cartons of milk. right? Maybe the owner wants 2 cartons of milk every week, so they run the function get milk. And you can see as soon as we've started putting things inside these curly braces of the get milk function, you can see things starting to happen down here in the console. And it's already printing the actions, essentially, of the robot going to shops, buy 2 cartons of milk. Next, we're going to pay, so print pay £2. And then we're going to come home, right? So that's it. 4 very simple instructions for the robot to go and perform get milk. Now I can just simply say to the robot, get milk, and it will find this function called get milk and execute everything that's inside. So saving us time and energy from typing all of these instructions out. So by having a function, we can essentially package a whole load of instructions into a neat little parcel. And every single time we need this particular functionality, such as getting milk, we just simply tell the computer the name of the function so that it can find it and execute everything that's inside. And this is called calling a function, and this is called creating the function. So in this lesson, we've created a function called get milk. And all it does is carry out a number of instructions that allows the little robot to go and get some milk. I create the get milk function up here by using the func keyword. And when I call the get milk function, I simply just call its name in order to execute it. Now you can see if I delete this line, I'll have nothing left in the console, because while I have this function defined and created, if it's not being called upon, nothing happens. So only when you write get milk and call the function does something then happen in the console. Okay, so now in this lesson we learned about the simplest type of functions, which is those functions that only package up instructions. Now in the next lesson, we're going to learn about functions that are able to take inputs. And that's a slight step up from the type of function that we've created in this lesson. So have a play around with creating your own functions that package up a number of instructions. And you can see that you can execute these functions as many times as you like. And in the console, you'll see it being executed again and again and again. So that's all for this lesson, and we'll learn more about functions in the next lesson. All right, so welcome back to the Introduction to Swift module. We are on Functions Part 2, and we're going to learn about functions that are able to take an input in this lesson. So open up the playground that we created in the last lesson. I called it functions. You might have called it something else. But basically, you should be able to see what we had at the end of the last lesson. We created a function called getMilk. And inside, we placed a number of instructions that need to be executed when this function is called. Then later on, we call this function called getMilk, and we can see in the console that function being executed. So that was the simplest type of function. Now today we're going to learn about functions that take an input. Now if we think back to our little housekeeping robot, it's a bit silly having this robot to only be able to buy 2 cartons of milk every single time, because maybe one week the master has a tea party and needs loads of milk. Maybe the next week he's on holiday and needs no cartons of milk. So it doesn't make sense to keep this hard-coded, i.e. always 2, right? So let's try and modify our function so the robot can take instruction from the master and buy the required number of cartons of milk. So I'm going to comment out this previous function by selecting all of the function. Then I'm going to hold down Command and I'm going to hit the / button. And that basically just comments out the entire block, which is helpful because we're going to keep it there just for reference, but we're going to create a new function that's able to take inputs. Now, the first thing you'll notice is that Xcode is already angry because this error says use of unresolved identifier getMilk. That's telling you it has no clue what the hell getMilk is. And of course, because we're trying to call this function and Xcode then searches through our code file to look for this function where it was created. And of course, now it's become a comment, so it's no longer code and it's hidden from Xcode. So it doesn't know what the hell getMilk is. So let's not worry about that for now, because we're going to create another function called getMilk, and this is going to be version 2. So let's lower the console down a bit, and I'm just going to create it around here. So remember, as always, we create functions with the keyword func, and I'm going to again call it getMilk. And now you see these round braces. In the last version, we left those braces empty, but this time we're going to put something in there. This time we're going to put in how many milk cartons, and it is going to be of type int or integer, whole numbers, and then we're going to open up a curly brace, and remember, always hit enter so we get the closing brace. Okay, so now I've created a new function called getMilk. It takes an input in the form of an integer, a whole number, and that input has a placeholder name called how many milk cartons. I'll show you how we're going to use those placeholders in just a little bit, but the first thing to note is that this error has now changed. This error previously said that it didn't know what getMilk is, but of course now we've created getMilk, it should know what the function getMilk is, but it's saying something different to us. It says missing argument for parameter how many milk cartons in call. So this is a parameter. This is something that we can input into the function and use it. It's saying that the getMilk function has a required parameter. You have to tell it how many milk cartons you want to buy when you call this function. So to placate it, we have to give it the parameter how many milk cartons. And to do this more easily, I'm actually going to delete this line of code and call it from scratch. I'll show you why. If I start writing getMilk, now you can see getMilk shows up, and also the parameter name shows up. Now, if I just wrote getMilk, I would have to type in all the rest of this. So if I just hit enter, it will automatically insert the correct way that this function should be called, which is of course the name of the function, getMilk, as well as the name of the parameter. And then in here goes the value of the parameter, which is of type integer. That little placeholder is trying to remind you that an integer has to go into this placeholder. So let's say we're having a tea party and I want 4 bottles of milk. There we go. So just to recap, to call a function, you first write down the name of the function, then you have the round brackets, and inside the round brackets goes any parameters that the function may have. Now, if there are no parameters, then it's of course just empty round brackets. But in this case, we've got a parameter called how many milk cartons. And we're going to give it a value, an integer value. Remember when we created the function, we said it had to be an integer, a whole number. So we gave it the value of 4. And as you can see down here, absolutely nothing happens. And sometimes this might be because Xcode is trying to run the code, in which case you'll see some sort of loading or running or doing something in here. But when it says ready, it says that means it's done, right? So absolutely nothing has happened. Why is that? Well, if we look at our current getMilk function, there is nothing in between the curly braces. So we're telling the computer to do nothing. Even though it has this input of 4, because this function does nothing, there's no outputs, there's no print statements. Let's change this. I'm going to copy these 4 lines of code from the previous function. I'm going to use Command C, and then inside here, I'm going to Command V to paste it. And then I'm going to select all of it again and hold down Command and the / to uncomment all of those 4 lines. And now, magically, you can see in the console that all of these 4 lines of instructions are carried out because this call to the function getMilk now has some instructions to carry out. Now, we mentioned that we're going to make a function that takes inputs, how many milk cartons. But if you look down here, it still says 2 cartons of milk, even though we told it to buy 4. And that's because this 2 is simply a string. It's just hard-coded. It's just written in there. So how can we make this instruction take into account this input called how many milk cartons? Well, we can delete this number 2, and we're going to use a / to escape the string, so-called. And then we're going to open and close some round brackets. Now, inside these round brackets, I'm going to call on this parameter called how many milk cartons. And now you'll see the instruction as buy 4 cartons of milk. So this part of the code is basically just referring to this placeholder, which in turn has this value inserted into it. Let's have a look at the code that we just wrote in a bit more detail. Now, again, up here, we've created the getMilk function. So this is where we define what happens when getMilk is called. And then down below, we're actually calling the getMilk function to trigger it to run. So when we write getMilk and then we insert a parameter of 4 for how many milk cartons, essentially what happens behind the scenes is this parameter, how many milk cartons, gets passed over to the function called getMilk. And then it gets put into the placeholder, and when this line is printed, it becomes buy 4 cartons of milk. So that's how it works. So now, if on this particular week I needed 4 bottles of milk, but the next time I need, say, 1 bottle of milk, and then you see the robot carrying out the instructions, changing it to 1 carton of milk, and say on the 3rd week, I really go nuts and I need 12 bottles of milk. And you can see this going into here as well. So essentially the parameter is an input, and when you create the function, you have to say whether if your function takes an input or not. When it does, you can use that parameter name, how many milk cartons, inside your function to place it somewhere or do calculations with it, or essentially use it for some sort of purpose. Okay, so we mentioned calculations just now. Of course, if you look at our function, there's something that's still a little bit off. How is it possible that when we buy 12 cartons of milk, we pay £2, and also when we buy 1 carton of milk, we also pay £2? That doesn't make any sense. So we have to do some calculations with this parameter before we can insert it into here. So let's try and do that. I'm firstly going to create a constant. Remember, constants are containers that can only have one value and it cannot be changed. I'm going to call my constant price to pay, and I'm going to set it equal to, so let's say that 1 carton of milk costs £2. Then what you can do is you can say how many milk cartons multiplied by 2, then you end up with the number of milk cartons multiplied by £2 and the total price to pay for that number of cartons. So next we've got this constant that holds a value, which is how much the robot needs to pay the shopkeeper. And you can see that in the left-hand margin, there's this yellow warning sign. Remember that yellow warnings are essentially hints that Xcode is giving you, telling you that something is probably not right, but it's not 100% sure. And this code will compile, it will run, and it might crash. So it's up to you as the human programmer to determine its importance. So let's click on it and see what it says. It says initialization of a mutable value price to pay was never used. So it's saying we created this constant called price to pay, but we never used it in our code anywhere. So let's do that. Instead of hard coding £2, I want the robot to pay the shopkeeper the amount that is held in price to pay, which is calculated from the number of bottles the robot needed to buy times the price of each bottle. So instead of the number 2, I'm again going to use that same trick, backslash plus open and close brackets. And inside here, I'm going to put price to pay. So now if we run our code, you can see that when we are asking the robot to get 1 carton of milk, so 1 carton of milk, it's paying £2. But if we get rid of this and instead we're asking the robot to get 4 cartons of milk, so the input changes to 4, then the robot is paying £8. So everything is working perfectly and our robot is getting more and more sophisticated. So just to review, in this lesson, we learned about a souped up version of the function. And now we're able to program a function that includes an input in the form of a parameter. And then we can use this input within our function to change the code, to perform calculations, and essentially influencing the end result. So in the next lesson, even though you think this is a souped up version of function, the next lesson is going to be turbocharged, supercharged. It's going to be a function that takes both an input as well as has an output. And we're going to show you also how to have a function with multiple inputs and not just one. So all of that and more to look forward to, and I'll see you on the next lesson. In the last lesson, we learned about functions that can take inputs. Now, in this lesson, we're going to soup up this function even more. It's going to become the king of functions. We're using the same file as before. I named it functions, but you might have called it something else. Go ahead and find it and open it up. Essentially, it has all the code that we wrote in the first functions lesson, as well as the second functions lesson. So far, we've had functions that essentially just package up instruction into a name of a function, which we can call. And we've also had the second type of functions, which takes an input and then uses that input in the set of instructions contained within. And in this lesson, we're going to learn about functions that can take both inputs as well as return outputs. So coming back to our little housekeeping robot scenario, we've got an issue where the master doesn't always have £8 exactly to give to the robot. So the robot has to calculate how much change it should get and then take that change back to the master. So I'm going to again comment out the function that we wrote in the last lesson. I'm doing this by command /, and I am going to copy all of this and just paste it below the previous version. And now I'm going to uncomment all of this, and voila. Okay, so now we're working on this third type of function. And you can see here we've got an input called how many milk cartons. And if we want to create a function that has an output, we have to use the return symbol, which is created with just a dash and a right-sided angle bracket. And then we're going to tell it what type of data we're expecting it to return. So I'm going to use integer again. So it's returning a whole number. And now you can see that Xcode is telling us that we've got an error. And if you click on this error, it says missing return in a function expected to return integer. So as soon as we wrote this part saying that this is a function that is going to return an output, but we haven't put a return statement in there, it starts complaining. So let's make it happy by writing a return statement. And what do we want our function to return? Well, we want it to return the change, right? Let's say that the change in this case was £2, so we'll make it return 2. You'll notice that nothing's really changed in the output. It's still saying the same. If we look at the right-hand margin here, you can see that the output of the function getMilk using 4 milk cartons is 2. So we can take that output and contain it within a variable. So in order to do that, I'm going to write var using the keyword to create a new variable, and it's going to be called amount of change. And I'm going to set it to equal the output from our function getMilk. So remember, we told it to just return 2. So amount of change right now should equal 2. Now, if I print out what happens back at the manor when the robot goes home to its master, the robot will say something like, "Hello, master, here's your change." And if you remember here, this is our little placeholder, and I'm going to put in there the variable amount of change. The robot will go to its master saying, "Hello, master, here's your £2 change." Now, we don't want this to be a fixed number. If the master needs 1 carton of milk, it doesn't really make sense for it always to be £2 change. And the other thing that you realize is that in order to calculate the amount of change, we have to know how much money the master gave the robot. So we need another input in our getMilk function. So we've got one input or parameter called how many milk cartons. The robot knows how many to buy, but we don't yet know how much money the robot was given. So let's create another input or parameter called how much money robot was given. And it's going to be again an integer. And I'm just going to collapse this right side to make the lines not wrap around. We've got the same function, but now it has two inputs. One is how many milk cartons, which is a whole number. It's expecting a whole number. And the second one is how much money robot was given, which is also going to be a whole number. And here we have an error because we've only given one input. So let's fill in the second input, which is how much money robot was given. Let's say that our robot was given a tenner from the master. Now we're going to use that parameter, how much money robot was given, to calculate how much change is left. So after we figure out the price to pay based on the number of milk cartons, we're going to create another constant called change. And it's going to be equal to how much money robot was given minus the price that was paid to get the milk. Instead of just returning 2, we're going to return change instead. All right, let's take a look at this function in a bit more detail. Now, at the top here, we've created this function called getMilk, and it takes two inputs. The first is how many milk cartons do you want to buy? And the second is how much money was the robot given? And finally, after all of that's completed, the function returns an output, which is going to be a whole number or an integer. So let's see what happens when we call getMilk down here. We give it the two required inputs. So we're going to get 1 carton of milk and 10 pounds was given to the robot. So let's see how those parameters move through that function. Firstly, these two values are placed into the function under the parameters how many milk cartons and how much money robot was given. Firstly, how many milk cartons is used to calculate the price that the robot needs to pay the shop owner, which is 1 times 2, so hence it's 2 pounds. And secondly, how much money robot was given is used to calculate the change, i.e. 10 minus 2 pounds, which is 8 pounds change. So then this function returns the number 8, and the variable called amount of change is set to equal the output of that function. And then that number gets moved into the print statement, and you end up with the result, hello master, here's your 8 pound change. So the first input was used to print the buy 1 carton of milk and paid 2 pounds. And the second input, namely how much the robot was given, is used to calculate the output, which is the amount of change that the robot received. So our function getMilk is now able to take inputs as well as provide outputs. And if we tweak some of the values of the inputs, say we wanted 12 cartons of milk and then gave our robot 50 pounds to go and buy that, and then in the output we can see what the robot does. Go to the shops, buy 12 cartons of milk, pay 24 pounds, come home, hello master, here's your 26 pound change. So in these last 3 lessons, we've covered some of the fundamentals of functions, which is one of the most important building blocks of any piece of code. So no matter how experienced you get as a programmer or how junior you are, you're always going to be using functions. So just to recap, in the first type of function, we simply grouped a number of instructions together under one name. In the second type of function, we provided that group of instructions with an input that allows us to perform calculations as well as use that input to determine how those instructions are executed. And finally, in our third type of function, which has both inputs as well as outputs, our function is able to take in information, process it, perform calculations with it, and then at the end, return an output that we can place into a variable that utilizes that out. So this is pretty much the fundamentals of Swift functions in a nutshell. In the next lesson, we're going to look at conditional statements, namely the if-else statement, and we're going to see how we can use the if-else statement to determine the resulting output of our function. So all of that and more in the next lesson. I'll see you there. All right, so in the last 3 lessons, we spoke about functions that either just group together functionality, or functions that have an input, or functions that have both an input as well as an output. In this lesson, we're going to talk about how you can determine the outcome of your program using if and else statements, which is a type of a conditional statement. It's a bit like when you go to the forest and there's 2 paths. If you choose the left side, maybe there'll be a monster at the end waiting for you. And if you choose the right side, maybe it's a castle. So today's lesson is all about how we program that. And as always, we're always trying to build fun, interesting, useful things. So today we're going to build a love calculator. I have no idea how useful this is going to be in your daily life, but it's a great example to explain if-else statements. So some of you guys might remember this practice of writing down your name and then somebody else's name, and then you cross out the same letters, and then somehow after some sort of convoluted calculation, you end up with a percentage compatibility with your loved one or unrequited loved one. So in the modern form, this is what it looks like. This is a web page that's dedicated to a love calculator, put on by Glamour magazine, and you can put in your name and then his name, Jack Bauer, and then you can check, is it love? Look, 70%, and then it comes up with some random number and gives you some sort of explainer text. So this is what we're going to recreate using our own code. So we're going to create a new Xcode playground, and we're going to call it conditional statements, and then hit next. And I'm going to save it again on my desktop. Feel free to save it anywhere you like. Okay, so here's my brand new playground. And again, I'm going to get rid of this line and this line, but I'm going to leave the UI kit, and I'll explain to you why in a little bit. So firstly, we're going to create a new function. You should be familiar with these by now. So again, func keyword, and we're going to call our function love calculator. And it's going to take 2 inputs. One is your name, and it's of course, a name is of course going to be of type string, right? And it's also going to take their name as an input, and it's also a string. And then it's going to return a number, so an integer, of how compatible you are. And then we're going to open a curly brace to define the beginning of our function code. And I'm going to hit enter to define the end of the function code. So at the moment, the function does absolutely nothing. And Xcode is complaining because I said I would return a number, but at the moment, I'm not returning anything. So in order to calculate this love score, we're basically going to create a random function using the arc for random uniform function. I'm sorry to disappoint any of you guys out there who believed in the magic of love calculators. It's just a random calculator. So we're going to create a constant called love score using the let keyword, and we're going to set it to equal arc for random uniform. So if we're looking for 0 to 100, then we should be putting 101 in here, because the arc for random uniform function returns any random number between 0 and the upper bound -1. So that's just a reminder. You've done this in Magic 8 Ball, you've done this in Dicey. So now we've got a love score, and that is between 0 and 100. And then I'm going to try and return this love score. Now you'll see that you'll see that Xcode is not going to be very happy about this. And the reason is because the output of arc for random uniform is a random number that has a type of uint32, unsigned integer 32-bit. And what we're saying here is that the function should return an integer, an int. So there's a mismatch of types, basically. So to fix this error, we can either convert this uint32 into an int, just as we did in Dicey, by writing int and then including everything that was a uint32 inside some round brackets, turning the uint32 type number into an int type number. Now, as you can see, this gets rid of the error. But A slightly easier way and slightly less confusing for our code is probably easier to just change the return type to a uint32. And there's no longer any type incompatibilities. So as you can see in the debug console, there's currently absolutely nothing. And that's because we need to call our function in order to make it execute. So let's call love calculator, and we're going to give it 2 inputs. So my name, Angela, their name, Jack Bauer. All right, so you can see in the Swift playground on the side here that it's showing me what is the value of love calculator, namely what gets returned, right? But there's nothing in the console because it hasn't been printed. So in the last lesson, what we did is we placed this number into a variable or a constant, and then we printed that constant. Let me show you a different way of doing this. We can simply just print the output of this function by enclosing it in a print function. So this way, everything in between these round brackets gets printed straight away. And every time you run this code, you will get a new number being printed, and the number will be always between 0 and 100. So this is not a very exciting love calculator. We want to be able to give the user some sort of interpretation, right? And this is where our conditional statement comes in. We want to be able to say that after the calculation goes through, if the result was greater than 80%, then we'll give them some sort of interpretation where you're super compatible and you're going to be together forever and ever. But otherwise, then there is no love possible between the two of you. So it's pretty easy to implement this in code, and I'll show you how we do it. So once we've calculated the love score, we're going to use an if statement and check if the love score is above 80. So we'll just write love score. If love score greater than 80, then open curly brace, and remember, every time you open a curly brace, always hit enter. If love score greater than 80, what should happen? This is the code that determines what should happen when love score is greater than 80. Currently, nothing happens, but we're going to change that. If love score is greater than 80, then return a string that says, you love each other like Kanye loves Kanye. There we go. But what should happen if the love score is not greater than 80, i.e. else return no love possible, you'll be forever alone. Great. So now we have 2 potential scenarios. If the love score gets calculated randomly and it happens to be greater than 80, then we'll give the user the interpretation, you love each other very much, but otherwise we tell them no love is possible. So as you can see at the moment, Xcode is highlighting this part and giving me errors. And that's because when we created the function, we said that it should return a unsigned integer 32-bit number. But at the moment, we're returning strings, right? Because strings are denoted by the quotation marks. So to fix this, we simply have to change the return type to make it match. So let's change that to a string, and Xcode will be happy now. And we can get rid of this return statement because it's no longer necessary. So in the console, you'll see that it'll print the message that is appropriate depending on the random number. So at the moment, the random number is 78. This is, again, the beauty of Playground. It gives you a peek into the value that's contained in your variables, which you normally don't get access to when you're writing code. So at the moment, the score is 78. So that means that it won't be able to trigger this if statement because it's not greater than 80. Therefore, it goes to the else statement, and you get in the console returned no love possible. You'll be forever alone. So you can try that a few times and it should work predictably well. Now, it would be great if we can show the user the actual love score as well as their interpretation. So how do we do that? Well, as you know, we can only return a single type, which is a string. So we'll have to turn this love score number into a string and include it in this output. So what we can do is at the beginning, we can say your love score is, And remember, we're going to use the escape the string method. So where we use the backslash and 2 round brackets. And then inside the brackets, we put love score. Now, and then I'm just going to write the same over here. And you'll see in the output, it says your love score is 41, no love possible, you'll be forever alone. Great, so that seems to work pretty well. But at the moment, our love calculator, 80% of the time, the user will end up down here where it says no love possible, you'll be forever alone. And only 20% of the time, when the love score is greater than 80%, do they get, they love each other like Kanye and Kanye, which is a bit mean. So it makes sense to me to have a third tier in between, maybe numbers between 40 and 80, just to tell them that they love each other a little bit, right? So how do we do this? So to write our middle condition, we're going to use else if as the keyword. Else if love score is greater than 40 and love score is less than or equal to 80, then return So let's take a look at the way that the program works right now. Firstly, the function gets called and there's 2 inputs, 2 names. They get completely ignored because love calculators don't really care. So we generate a random number using arc for uniform function. And remember, this is something that is included in the UIKit library. So you only get access to this function if you import the UIKit library. So then we calculate a love score between 0 and 100. So our love score at this time happens to be 6, which is super low. Now, then the computer goes through the checking process. First, it checks if it's greater than 80. And if it is, then the computer stops and returns this line. But if it's not, then it goes and checks against this line. Is it between 40 and 80? No? Then it goes to the last line, which covers all other cases, i.e. in our function, everything that is below 40. And it returns your love score is blah, no love possible, you'll be forever alone, which is what we see out here in the console. Now, you can run it a couple of times, just check your code and see if it works in all cases. And of course, you can change the interpretation strings to whatever it is that you want to write. Now, you can see very easily how this string can be placed into a label in our app, and we end up with a love calculator app. And believe it or not, there's actually apps out there that charge people for this functionality. That took us, 2-3 minutes to write? So the world of possibilities. So the most important thing that you learn from this lesson is this checking mechanism that we implemented. And this is called an if-else statement. First, we have some sort of value to check against, namely love score, and the checking goes through its stages. Whenever it evaluates to true, then it stops, and it returns whatever it is contained inside the curly braces. So at the moment, love score is 49, so this statement, is love score greater than 80, is false. So then the computer skips this part and goes to the next part. Next, it evaluates whether if love score is greater than 40 and less than 80. So currently 49. Is 49 greater than 40 and less than 80? So this evaluates to true. Then that means that these lines get triggered and we end up with this return statement in the print console. So it prints your love score is 49, you go together like Coke and Mentos. And finally, if both of these were false, and finally, if both of these were evaluated to false, and the number was something like 19, then this final statement would trigger, which catches everything else, i.e. everything that's below 40 in this case, and returns a final score. So this is a bit like the example I mentioned in the beginning of this lesson. If you were going to a forest and you saw the first path and you decided to go down it, then something would happen to you. Else, if you went down the second path, then maybe you would end up with a different scenario. And finally, if you went down the default path or the third path, you would end up again with a different scenario. So this is a way for the computer to determine what it should do based on different scenarios. And we're going to use this functionality, and we're going to use this in future apps when we create choose your own adventure apps, just like Lifeline, where we determine what should happen to the protagonist or the player depending on the choices that they make. And so we're going to come back to this in later apps and later lessons. Don't worry if it doesn't all make sense just yet. The important part is just that you understand that you can determine the outcome based on a checking mechanism. All right, so in this lesson, we talked about a type of conditional statements, which is the if-else statement. In the next lesson, we've got a challenge for you. To complete the challenge, you're going to have to apply all of the things that we talked about in this programming module. You're going to be creating a function, you're going to be using the if-else statements, and you're going to create a BMI calculator in Swift Playground. So we'll walk you through that in the next lesson, and I'll see you there. All right, guys, so in this challenge, we asked you to create a BMI calculator using your newfound skills of creating variables and functions. So if you haven't seen these BMI charts, they're basically a way of classifying somebody based on their height and the weight. So for example, somebody who's taller will have a higher weight than somebody who's shorter, but it doesn't necessarily mean that they're overweight. And it's just a formal way of classifying somebody's body mass. And doctors and health professionals use it for various things. But what we're mostly interested in is how do we convert this whole formula into a program in our playgrounds. So the first thing that we asked you to do was to create a function. So I'm in this brand new playground, and I'm just going to get rid of this first variable. We won't really need it. Instead, I'm going to create a function. So we're asked to create a function that takes the person's weight and height as input parameters and returns the BMI. So this is basically computing this formula. And you can see that the most important thing about this formula is that the mass is in kilograms and the height is in meters. So if we create a function, let's call it calc BMI. And what we want is to give two inputs, right? In order to calculate the BMI, we need the height and the mass, so the weight of the person. So let's say weight, and let's first use an integer, and height will do the same. So it's called calculate BMI, and it takes two inputs, the weight and the height, both as integer data types, so that's whole numbers. And then I'm going to perform the calculation inside this method. So let's say let BMI. So now we're basically replicating this formula here. So let BMI equals weight divided by height squared. So height squared is a little bit tricky because there's a lot of programming languages where you can simply just do height to the power of 2. But Swift is not one of them. I'm going to show you how to do the power function. But let's first do this in a slightly high school kind of way. So instead of height squared, we'll just do height times height, which is the same thing. Now, mathematically, this line is completely correct if you're trying to replicate this formula. However, in Swift, evaluations are done from left to right. So the first thing that's going to get calculated is the weight divided by height, and then that result is going to be multiplied by height. And it's really easy to test this. Say if we have a number, right, that's equal to 6 divided by 2 times 2. So this is basically the same as what we've got up here. Now, if we wrote this down as a mathematical equation, 6 divided by 2 times 2, the answer should be 6/4 as a fraction. However, you can see in the playground here that we're getting the answer 6. And that's because it's first calculating 6 divided by 2, so that's 3, and then it's multiplying that 3 by 2, which is of course 6. So this is something that's a little bit awkward about Swift, and it's something that you need to be aware of when you're writing code. So instead, we have to put the 2 times 2 in parentheses to tell the computer that we want this part calculated first, and then we want the 6 to divide that number. So if you just option click, you can see that this constant number is presumed to be of data type integer, and that's because all the values that we've been inputting are integers. So if we converted this into a double, however, then you should see that we're getting 1.5, which is 6 divided by 4. So let's go and do the same for our BMI. So if we put some parentheses around the height times height, then the computer is going to first process this part before dividing the weight by it. So that wasn't so hard. And now let's try and call this function. So let's say calc BMI and giving it a weight in integers. So let's use, say, 63 and height, I'm 1 meter 80. And this is where you encounter your first problem. You can see that you're getting an error here and you're getting this debug description in your console. So if you can't see your console, just make sure that you pop it out by clicking on this button. And it says playground execution failed. And the error says cannot convert value of type double to expected argument type int. And it's even giving you a little pointer as to where this problem is. So at the moment, what we specified is that the input called height is a data type integer. So what's happening at the moment is that this 63 is being passed in here, and the 1.8 is being passed into here. And then that 63, of course, moves, and then that 63 is, of course, used here, and then the 1.8 is used in these two places, height and height. So the problem is that the data type that we specified for the height is an integer. So remember, integers are whole numbers, so they can't have decimal places. So if we wanted to be able to input heights with a decimal place, I mean, very few people are going to be squarely 1 meter or squarely 2 meters. So we need to change the data type of that input parameter. And we're going to change it to the suggested data type, which is a double. So let's change that to double, and let's also change weight to double in case somebody is 50.5 kilos, so that this will still work. And you can see that our calculation is now being processed because in the playground you see this number, which is the BMI being outputted. So this line of code simply runs this entire function, but it doesn't store the output anywhere. And that output only exists momentarily while this function is run, and afterwards it's wiped and it's gone. So in order to store this value, you might think that you can say var BMI result equals calc BMI. But the problem is that you can see that BMI result, say if we try to print out BMI result, you can see that it's empty, it's nil, it's nothing. And the reason is because what you're asking the computer is you're saying, create this container called BMI result and set it to equal run this function. You're not setting it to equal the output of the function, because if you remember from our previous lesson, the functions that have an output need this little arrow thing here. So that's a dash and an angle bracket. And you need to specify what is the data type that you're expecting to output. And in this case, it's probably going to be a number with decimal places. So let's keep it as a double. And you still have an error here because it says missing return in a function expected to return double. So up here, you're specifying that this function will output a double, but inside your function, nowhere do you have a return statement. And the classic joke is, why did the programmer go to the supermarket and never come home? And it's because you didn't tell him to return anything. So terrible joke aside, it does, however, illustrate a point that you need the return statement. And the return is what you want to output from this entire function. And that is, of course, the BMI that we just calculated. So now you'll see that when I say print BMI result, it gets printed in here. And that variable BMI result now has a value. So if we chase the logic here, the first thing that we do is we create a container. So if we chase the logic here and again play the game of pretending to be the computer, the first thing we do is create this container called BMI result. And we then set it to equal a function. So now we trigger this function and we go over here and we input 63 as the weight as a decimal number, so 63.0. And then we put the height also as an input and as a decimal number. And then we enter this main block of the computation and we create this BMI constant, which is calculated by dividing the weight. by the square of the height, and subsequently we return the BMI, which is of course going to be a type double. Now once that returns, then this entire line is replaced by that 19.44444, and it's assigned as a value to this container BMI result. And the last thing we do is we print to the console that BMI result. So let's have a closer look at this height times height. It seems a little bit inelegant to write height twice, right? And if you wanted to raise height to the power of 3, for example, then, doing this looks really, really silly. So luckily in Swift, there is a function called power. And this basically raises the first number by the exponent that you specify here. So in our case, it's height, and the exponent is 2. So this is equivalent to height to the power of 2, and this is height to the power of 3, etc. And this looks a bit neater, and it's also a lot easier to write if you're going to raise it beyond the power of 2. Now, the reason why we set this challenge is because by creating this function, you create the most complex type of functions. So ones which contain an input, as well as an output, as well as some instructions to execute. But the important thing to remember is that without calling this function, so let's comment out these 2 lines of code, you'll see that there's nothing in the playground and none of this function runs because it never got called, so it never had to do anything. And the important thing to realize is that in Swift programming, your lines of code are not just being carried out from top to bottom. Instead, they're being carried out when they're being called upon. So in this case, if we simply declared or created this function, and you can tell when we're creating functions because we have that func keyword, if we simply created it but we never used it, i.e. we never called it anywhere, then it doesn't get executed at all, and it's entirely ignored. It's only when this part of the code becomes active that the computer will search for this function called calc_bmi, and it will execute all of this code. So I hope that clears things up a little bit more. So let's continue in our exercise. So it says that if the BMI is greater than 25, then use the print statement to tell the user that they're overweight. So in this case, we've got this BMI here, and we can use an if statement to check whether if its value is greater than 25. So we can say if BMI is greater than 25, then in that case we're going to print you are overweight, but or else if the BMI is greater than 18.5 and the BMI is less than 25, then print you are normal weight. You are of normal weight. You have a normal weight. And finally, you can say else if BMI is less than 18.5, in which case we can print you are underweight. Now this code works, and it does interpret these 3 instructions literally word by word, but it's not really the way that you would do it in programming. So let's start with this value that we've got, right? 19.44. Now the first thing that happens is that the computer checks to see if it's greater than 25, which is false, right? 19 is not greater than 25, so it skips this and carries on. Now we've got this else if statement that checks to see if the BMI is greater than 18.5 and it's less than 25. Now, there's a little bit of redundancy here because if we didn't fall into this camp, then we don't actually need to check to see if it's still greater than 25, right? Because otherwise it would have triggered this and it would have been done. So this is why we use the else if statement, i.e. if it's not greater than 25, then check if it's greater than 18.5. So in this case, we can actually delete this. However, if you were just using simple if statements, so if BMI is greater than 25, or if BMI is greater than 18.5 and less than 25, then you have to realize that each of these if statements are evaluated. But if you had an else if, then it would skip all of this if this was true. So it's basically like a waterfall. And similarly, you don't actually need this last part because there's only three options here, right? Either the number is going to be bigger than 25, or if it's not bigger than 25, then maybe it's bigger than 18.5. So between 18.5 and 25. And then all that's left is all the rest, right? So all the numbers that are below 18.5. So we can cover everything else by simply using the else statement. So if we look at the flow of information here, right? Let's say that BMI was actually equal to 12, right? And then in this case, that BMI is going to be first checked against here. Is it greater than 25? No. So we're going to skip this. Next, else if it's not greater than 25, then is it greater than 18.5? It's also not true. 12 is not greater than 18.5. So this part also gets skipped. And finally, the last bucket, that all that we have left for all the remainder is this last else statement. So it's going to print underweight, right? So this is how you could potentially complete this challenge. However, if you wanted a slightly classier implementation, then maybe you want to return the message instead of returning a double. So let's say in this case, we return the string. And what we're going to do is we're going to add this string to our BMI. So what we want at the end is we want something printed like your BMI is something, right? And you are underweight, for example. So this is what we want to see down here. So in order to achieve that, we're going to say, instead of outputting a double, we're going to output the string. And instead of returning the BMI, we're going to create a new variable. And we're going to say that variable is called the interpretation. And this is going to start off just being an empty string. So if the BMI was greater than 25, then we're going to change the interpretation to equal you are overweight. But else if it's not greater than 25, but greater than 18.5, then we're going to say the interpretation is equal to you have a normal weight. And finally, for all the other scenarios, then the interpretation is simply going to be equal to you are underweight. So at this point, once you've reached this line in the code, after going through this entire if-else statement, then your interpretation is going to equal one of these statements, right? So instead of returning BMI, let's say if we returned the interpretation. And you can see down here it says you have a normal weight based on these inputs, which calculates a BMI of 19.4. But remember, we said that we wanted to see our BMI as well, right? So instead of returning interpretation, you could return, say, your BMI is plus BMI plus the word and finally, tagged to the end of that sentence is the interpretation. So now our code is going to fail. And the reason is because it says binary operator, i.e. addition, cannot be applied to operands of type string and double. So to interpret that, it's saying that you can only add together items of similar types, right? Say if a variable number was equal to 2 plus 3, right? That's easy. That's going to be equal to 5. But what if instead you try to say number equals the word 2 added to the number 3? It's going to get confused, right? How do I add the word 2 to 3? What does that mean? What do they want? Do they want something like 2, 3? Or do they want something like 5? Or what is it? It's very, very unclear. So if we're going to return a string, we need to ensure that everything that comes after the word return is of the same data type. So one way of doing this is by casting that BMI into a string. So we can write string and then enclose the double, which is the BMI, inside these parentheses so that it will convert the BMI into a string and then print it out. The alternative is we could use one single string, and it could say your BMI is, and we use string interpolation. So that's where we have the backslash and parentheses, and then inside the parentheses we put in the variable that we want to print out. So in this case it's the BMI. Your BMI is such and such, and then this is the part where we want the interpretation. So then we add the interpretation and close the parentheses. And you can see that we get the same result down here. So there's many ways of going about this. Some people are fans of one and some people are fans of the other. Basically what you're optimizing for is simplicity. Can somebody come and read this line and easily understand what's going on here? So that's not bad. We've achieved our objectives. We managed to print out our results in this format. Now there's one thing that's a little bit weird to look at, which is because our BMI has so many decimal places, when it's printed out like this, it looks a little bit odd, right? What if we just wanted maybe say 2 decimal places? So we wanted to say 19.44. Wouldn't that look a lot cleaner? So we can do that quite easily. So now we're going to convert this BMI from however many decimal places that it has into one that only has 2 decimal places. So let's say if we create a new constant, let's say shortened BMI. We're going to say string, and then we're going to specify a format. So if you scroll down, you can see that there's various ways of converting different data into strings. And there's one here which takes a format and it takes an argument. So this is the one that we want. And as you can see, it's expecting the format to be expressed as a string. And the format that we're going to specify is a percentage mark, and then we're going to put 0.2 or simply 0.2 f. And that specifies that we want to round off whatever we put in here to only 2 decimal places. So what we want to put in here is, of course, our BMI. So let's go ahead and type BMI. And now you can see that the shortened BMI is equal to 19.44. So now, instead of printing out the BMI, which is our long number, we're going to print out this string that's rounded to 2 decimal places. So we can simply write shortened BMI. And what we get in the console is your BMI is 19.44 and you have a normal weight. So of course you can change this format to however you want. So say if you only want 1 decimal place, then that's 0.1f. Say if you wanted no decimal places, 1.0f or 1.f, same thing. But for now, let's leave it to 0.2f so that we get our rounding to 2 decimal places. Okay, so for those students who are in the US, then a natural extension to this challenge is how do you make a function where instead of inputting meters and kilograms, what if you wanted to use imperial units? So a BMI calculator using imperial units. So again, as always, I really urge you, especially after you've seen the solution for the BMI calculator challenge, to go ahead and try it yourself. See if you can do it before watching the solution. As always, that's where you're going to learn, and this is simply just checking to see if you got it right. Alright, so I've got a few conversions here where 1 foot is equal to 12 inches, 1 inch is about 0.25 meters, and 1 pound is about 0.45 kilograms. So we're going to use these conversions and we're going to create a function. Let's call it BMI calc imperial units. So our inputs for this function are probably going to be, so for example, I'm 5'11", and I'm about 140 pounds. So now our inputs are 5 feet and 11 inches and 140 pounds for the weight. So for the weight, it's pretty easy. We can say weight in pounds. But then for the height, it's a little bit trickier because we have to specify height in feet and then height in inches. So the way that you would call this method is, for example, BMI calc imperial units, and pounds is easy, 140. Height in feet is 5, and inches is 11. So now we have to take these values that anybody inputs and convert them into metric so that we can still use this formula. So the first thing that you would probably do is create a constant called weight in kilos. And this would be equal to, so 1 pound equals 0.45 kilos. So it will be the input, whatever people put in pounds, weight in pounds, multiplied by that number. So now we have the weight in kilos, which is 63.5 kilos. So next, we're going to calculate the total number of inches. And we're going to use the height in feet. We're going to multiply it by 12 in order to convert it into inches and add the remainder height in inches. So if you want, you can actually change this to remainder inches if that makes more sense, but it's totally up to you. If you change it there though, you're going to have to change it here so that we still call our method as the same way that it was named. So total inches would be the height in feet multiplied by 12, 1 feet equals 12 inches, plus the remainder inches. So now we have the total inches and the weight in kilograms. So now we're ready to convert the inches into meters. So let height in meters equal total inches multiplied by the conversion factor, which is 0.254. Okay, so now we're back at where we were before. We've got weight in kilograms and height in meters, and we're ready to calculate our BMI. So this should be pretty straightforward. You've done this before. So weight in kilos divided by the power function of height in meters to the power of 2. And now we have our BMI. So down here we've said call this function BMI calc imperial units, giving in 140 pounds and 5'11". And you can see we've got our BMI out here. So that's just a quick variation on the BMI calculator for those of you guys in the US. And of course, as always, feel free to mess around with this any way that you can think of. It's only when you think of something that you want to do and make the code do exactly what you want, that's when you have the power over the program. So go ahead, mess around with the code, and be sure to show us in the Q&A section anything cool that you've made that is different from what we showed you. All right, so that's all for this lesson. I'll see you on the next module. All right, so in this lesson, we're going to talk all about loops. As I've mentioned before, the key trait of us programmers is the fact that we're incredibly lazy, and you should always have this mindset when you approach programming problems. How can I do more with less effort? Or rather, how can I not repeat myself and not have to write code that I've written before while achieving the same ends? So in this lesson, I've started a brand new playground, and we're just going to delete this first template string here. And I want to show you the most basic type of loop, and that's one where we're looping through an array. So let's say that I have an array of numbers, right? Array of numbers. And let's say that contained in this array, I've got, 1, 5, 3, 6, whole bunch of random numbers. And what I want to do is I want to loop through this array so that I can get the total of my array of numbers. What is 1 plus 5 plus 3 plus 6 plus 2 plus 7, etc. Now, if I had to do this without loops, then I would have to say something like, let sum equals array of numbers at index 1 plus array of numbers at index 2, and so on and so forth. And it's going to take a lot of repeated code. I have to do all of this manually, which is very, very painful, and that's not how we roll as programmers. So instead, what you can do is you can use a for loop. So let's first write a very simple for loop, and the type of for loops that we use in Swift is called a for in loop. And this is how it works. The first keyword is for, So you can see that it's highlighted in a different color. And the next thing that we're going to write is we create a constant that represents a single element inside this array. So let's say for number in array of numbers, so that means that the loop is going to look through this array of numbers and it's going to assign a constant to every single item. So the first time that this loop runs, if we print number, then it's going to print 1. And then the next time it's going to print 5, and then it's going to print 3. And as you can see here, it's printing out each and every single number every time this loop runs. Now, how do I know that this is not just printing it all out in one go, and instead it's cycling through this many times? Well, let's add another print statement, and let's call it new cycle. And you can see now, once it runs, that it's going to print 1, and then it's going to print new cycle, and then it's going to print 5, and then it's going to print new cycle. And you can see that there's as many loops happening as there are elements in this array. And it stops once it runs to the end of the array. So in essence, what this block of code is doing is that it's looking inside an array of numbers, pulling out the first element out of it, assigning it to a constant called number. So this is the first thing that happens. Let number equal array of numbers at the first position, and then it carries out everything that's inside the loop. So this part, right? And then what it does next, once it gets to the end of this list of instructions, then it goes back to the beginning and does the same thing with the next element in the array, all the way until it gets to the last element of the array, and then it stops by itself. So that's what it's doing behind the scenes. So let's see if we can do what we tried to do earlier on, which is making a sum of all the numbers in our array of numbers. So to do that, firstly, we're going to need a variable. Let's call it sum, and let's give it a starting value of 0. Now, the next thing that we're going to do is that every single time our loop runs, we're going to add number to sum. So the first time, number is going to be 1, so sum plus 1. So now it's 1, right? And the next time it runs, we're going to add 1 to 5, and so on and so forth. So the short way of doing this is sum plus equals number, and this is the equivalent of saying sum equals sum plus number, but it's just a quicker way of expressing the same thing. So these two lines do exactly the same thing, and they have the same values. So now let's just use one of them. So now if we want to see what the sum is equal to, every single time the loop is run, we can simply print sum. So now you can see that. First, it was equal to 1, which is 0 plus 1. The next time the loop runs, then sum is now equal to 1, and so we plus 5 equals 6. And then it goes on until it gives us the final sum of all the numbers in our array. Now, if we're only interested in that final sum, and we're not interested in the process, then we can simply cut this out of the loop, so out of these two curly braces, and put it below it so that it will print the final sum after it has looped through all of the numbers in the array, and it will print 81. So that's obviously a lot easier than previously when we're trying to grab all these elements and trying to add them together. And also, this is far more dynamic because if I add a few more numbers to this array, then you can see that it still works. I don't have to change any of this. All my code still functions. Whereas previously, I was adding together, array of numbers at index 3, at index 4, then I would have to change the body of my code. So when you're working as a programmer, you always want to try and avoid changing or having to modify the body of your code. It should try and be as dynamic as possible so that when you change the top level global variables or your constant, then everything in your code still works without you having to modify it. All right, so this is one way of using the for in loop. And remember, this keyword here can be anything you want, anything that makes sense to you. So it's usually what we would call a single unit inside the array. So say if this was, I don't know, age of dogs, right? Then it would be for age in age of dogs. And then you would be sum plus age plus equals age to find out what the overall age of all the dogs in your house would be, right? Now, of course, there's no dogs that live that long, but that's just an example. So let's move on to another example that would work. So let's say that I wanted to print out all of the numbers from 1 to 10. Then what I can do is I can say for number in 1, 2, and including 10, I want to print the number. So what it's going to do is the first time that the loop runs, the number is going to be equal to 1 and increments by 1 every single time it runs until it reaches 10. And it's going to be inclusive, i.e. it's also going to print out 10. Now you can also do what's called an open range, which is where instead of 3 dots, you have 2 dots, and you use a less than or a greater than symbol. So in this case, we're saying from 1 all the way up to, but not including 10, print out every single number that we're looping through. So it prints out from 1 to 9. And this is something that you're going to find yourself using quite frequently in programming. And I'm going to show you a practical use for it very, very shortly. Now, the last thing I want to talk about in terms of the for in loop is what if you didn't want to print out every single number? What if you wanted to increment by, say, 2 or 3, and you wanted to print out maybe all of the even numbers, for example? Then this is a case for using the keyword where. So for number in the numbers 1 to 9, where number modulo 2 is equal to 0, i.e. so if you've used any other programming languages or done some math before, then you'll know that when we say something modulo 2, it means we're looking at the remainder. So for example, 2 modulo 2 is going to equal to 0, right? But let's say 3 modulo 2 is going to have a remainder. Divided by 2, then it's going to be equal to 1.5. So there is a remainder. It doesn't divide cleanly. Whereas 2 divided by 2 is going to equal 1. And say 4 divided by 2 is equal to 2. And there is no remainder. So in those cases, the modulo is going to equal 0. Whereas something that doesn't divide cleanly, the modulo is going to equal 1. So simply by saying number, so in this case it starts out being 1 and steps through until 9, where number modulo 2 is equal to 0, i.e. it divides by 2 cleanly and therefore it must be an even number. Then and only then are we going to run the code inside this for loop, which is printing out the number. So we're getting all of the even numbers up to 9. So if I change this to a closed range from 1 to and including 10, then it'll print out 10 as well. And you can do the same with modulo 3 as well. So printing out all the numbers that are divisible by 3 between 1 and 10. And this will come in really useful in a lot of cases, especially if you're doing game programming or doing anything that involves graphics as well. So that was a brief intro into for in loops. Now in the next lesson, I want to show you a practical example of writing a program where we need a for in loop. So I'll see you there. So in the last lesson, we looked at the for in loop and all of its various iterations, using a for in loop with an array or using a number range. So in this lesson, I want to show you a practical use of the for in loop so that we can do something actually useful rather than just showing you these examples. And what we're going to do is we're going to write out all the lyrics to the song 99 Bottles of Beer. So just to remind you, the 99 Bottles of Beer song lyric looks like this. 99 bottles of beer on the wall, 99 bottles of beer, take one down and pass around 98 bottles of beer on the wall. And it goes down all the way to no more bottles of beer. And then we restart to 99 bottles of beer on the wall. So the idea is, how can you use a piece of code that you can write to print out all of these lyrics into the console? Now, if you want to have a bit of a challenge before I show you how to do it, based on what you've learned on loops so far, then feel free to go ahead and pause the video and come back to check the solution later on. Alternatively, you can follow along with me and I'll show you how we can do it using the for in loop and using a range. So the first thing that we're going to do is we're going to create a new function. And the function is going to return a string, i.e. the song lyrics. And then we're going to print that output. So first thing is creating a function that's called beer song. And it has no inputs, but it does have a string as an output. Now inside this function, we're going to create a new variable called lyrics. And it's going to be of type string. And its starting value is going to be an empty string, so nothing. And finally, we're going to return our lyrics as the output. Now, outside this function, I'm going to print the output of this function. So I'm just going to call beer song inside the parentheses, and it's going to print lyrics into the console, which of course right now equals absolutely nothing. So this warning is telling me that I have never changed the variable lyrics and that I should consider using a constant or using a let instead. But of course we are nowhere near done yet, so we can ignore that yellow warning safely. This is simply Xcode being preemptive and nagging us to check our code. So that's fine. The next step is adding a for in loop. So what we're going to do is we're going to say for number in 1, 2, 5, and including 5. So remember in the last lesson we talked about closed and open ranges. In this case, this is a closed range. So we're going from 1 all the way through to 5 and including 5. Then we're going to use this number to create our lyrics. So right now, if we simply print number, you can see that because we're calling our function here, so this is all being activated, and every time it's activated, this for loop is going to run 5 times from 1 all the way through to 5, printing out the number in each case. And that's because of this line. If we delete that, then nothing is going to be outputted because our lyrics is currently an empty string. So if our lyrics were something like gobbledygook, you can see that we've created lyrics here. We're returning lyrics as the output of this function, and then we're printing the output of this function on line 16. So it gets printed in here. But because our lyrics is empty, then nothing is printed. If any of that was confusing, make sure that you have a look back and re-review the lessons on methods, especially the ones where we talk about inputs and outputs. All right, so in the last step, we created this variable called lyrics that's currently empty. And remember that lyrics only exists inside this function, i.e. we can only access this variable inside these curly braces of the beer song function. If we try to do anything with lyrics outside of it, you can see that the auto-suggest isn't even giving me anything. It doesn't exist, right? So this is really, really important. And we're going to talk about this later on as well, when we talk about scope. But for now, just know that lyrics only exist inside this block of code. So now that we've seen what number looks like every single time this loop runs, we're going to incorporate it into our song lyrics. So I'm going to create a new constant called new line, and new line is going to be a string, and it's going to be equal to a string where we have the lyrics to our song. So the first line says 99 bottles of beer on the wall, 99 bottles of beer. Take one down and pass it around, 98 bottles of beer on the wall. So you can see the repeated parts are all of the text, whereas the numbers are the things that change. So let's just copy this lyric over and put it inside our two quotation marks. Now, in programming, a new line means something specific, so we can't have that. Let's tag it on at the end of the previous line so that it will all be interpreted as a string. And remember that when you have something that truncates, i.e. the second part is going onto the new line, that means something entirely different from simply hitting enter and making a new line. So sometimes you might see that on my screen, something has gone onto the second line, but it doesn't mean that I've hit enter and made a new line here. It simply means that it's wrapping around. So the best practice is to always try to give yourself as much horizontal space as possible so that your code will try and be on the same line, and it makes it a little bit less confusing. Cool, so we've now got this string, but at the moment it's not dynamic at all. It's completely hard-coded, or it's static, because every single time it's going to be equal to the same thing, right? Every single time this loop runs, and it's going to run 5 times, then we're simply going to create a new line that's just a string, which is kind of boring and that's not what we want. In our case, we're doing a very simplified version first. We're going to go from 5 down to 1. So we're going to go from 5 bottles of beer down to 4 bottles of beer and all the way down to no bottles of beer. This way we don't get so much printed out in the console and it will be easier to see. And then after we understand how it works, we're going to fix it later on. Always try to cut down a problem to its simplest form and then break down the problem and tackle each bit at a time. All right, so we're going to try and get this printed. So it'll be 5 bottles of beer, then it'll be 4, then it'll be 3, and it'll be 1. But let's change this 5 so that instead of being, static 5, so it's actually a dynamic number. So this is where I'm going to use that number that we've got here. So every single time it goes through the loop, this constant number is going to take on a new value. It's going to start from 1 and it's going to increase by 1 until it reaches 5. So the first time it runs, number is going to be equal to 1. And let's add it here as well. So if we now print this new line, and we can see what it looks like, you can see that it's run 5 times. A number is inserted into this string every single time, and it takes on a different value every single time this is run. So first time it says 1 bottle of beer on the wall, 1 bottles of beer. Take one down, pass around 4 bottles of beer. So you can see that what we're trying to achieve is we're trying to go backwards, right? We're trying to go from 5 down to 1 rather than from 1 down to 5. So what can we do? Well, the simplest way of doing this is simply by saying 6 minus number. So 1 plus 5, 6 minus 1 is going to be 5, 4, 3, 2, 1, right? So let's just do this very simple modification to make the code do what we want it to. Not saying this is the best solution, and I'm going to show you a more sophisticated version of this later on. But let's just try and keep it simple so we can understand exactly what's going on. So now instead of 4, so this is going to be 6 minus number minus 1. Alternatively, you can also just say 5 minus 1. So now we've got what we wanted, which is 5, 4, 3, 2, 1, and then it goes from 4, 3, 2, 1, 0. So this is exactly what the lyrics should look like, and we're more or less happy with that. So now what I want to do is, instead of printing new line here, I'm going to add the new line to our lyrics every single time the loop is run. So I will say lyrics plus equals new line. So remember, as we said in the last lesson, this is the equivalent to writing lyrics equals the current version of lyrics plus new line. These two lines are the same. So we're going to favor the slightly shorter version, and we should now see lyrics being incremented every single time, and then it's going to be added together, and finally we're going to output lyrics from this function, and we're going to print that output on line 16. So all of this gets printed down here. Now you can see that everything is on one line and it's all a bit squished. It's kind of difficult to see what's going on here. So we're going to use a special symbol that creates a new line, and that is the \n. So first we want a new line here, and you can see that every single time this line gets inserted into lyrics, it goes in as a new line. The next thing is that I want this sentence to be on a new line as well. So I want each sentence to have its own line. So I'm going to add another / in front of take one down and passed around. So now you can see that it's formatted a little bit better. The last thing I want to do is I want to have another line, an empty line, between each of these sets of lyrics. So when it goes from 5 to 4, I want to add another new line. So I'm going to add one right here. And you can see that this is formatted now exactly how I want it to. And it looks a lot more clear than before. And that is the power of the new line. So wherever you want a new line, you can simply write a \n, and you will get this effect in your console, which will make your outputs look so much more clear. So there's one last problem, which is if you look at the last set of lyrics in this song, the last thing it says, no more bottles of beer on the wall, no more bottles of beer. And it goes all the way back to the beginning. So what we can do is, outside this loop, we can add this new line to the lyrics. So we can say lyrics plus equals this line. And we can modify it with the same structure. So new line here, and new line here. Although it doesn't really matter because it's right at the end now. And we tag that last line of lyrics to our song. So now here's a challenge. Can you make our song, instead of running from 1 to 5, so 5 bottles of beer down to no more bottles of beer, can you make it run from 99 bottles of beer down to no more bottles of beer? So pause the video and give it a go. All right, cool. So, as you might have figured out, this is the important part. This is where we decide the upper bound of our range. So at the moment, it's looping from 1 through to 5. But what if we made it loop all the way to 99? So the problem now is that we're hard coding this part because we're saying 6 minus number, and you can see that we're getting some pretty weird outputs here, starting still from 5. So what we need to do is 100 minus number, 100 minus number, minus 1. And now you can see that it works, but that was kind of hard-coded, right? What if we wanted to change this to, 70 or something different? Then we have to change this number all over again. We have to dig through our code, in the body of our code, and start messing with this number, which is not cool. So instead, I want to show you something else. Now, instead of doing it like that, what we can do is we can bracket this range, and we can use a function called reversed. And what this does is it reverses the order of which the loop is run. So instead of going from 1 to 99, it will start from the highest number, so 99, and go down to 1. So now what we can do is we can get rid of all these hard-coded bits and instead simply have number being printed. So now, if you have a look at our output, you can see that it does exactly the same thing. It runs from the upper bound all the way down to the lower bound, and then it adds this final lyric after the loop has ended. And now, if we change this to say 70, then our code is going to start from 70 and go all the way down to 1. Or if we change this to 54, it's now dynamic. We don't have to touch any of the things inside the body or we're changing. Now, it can still be improved further because instead of putting this number in 99, hard coding it essentially and changing it every time, what we really want to do is, what if we could put it in as an input to this function? So you've learned about functions with inputs and functions with outputs. If you want to challenge yourself, see if you can make this 99 use the input that we give to this function. So the case would be, we would say something like beer song with this many bottles, and it would be something like 99. Can you make the code work so that when I call this line on 18, that I would get 99 or 25 or whatever it is input here being printed in the console? So going down from 25 down to 0. So if you want to challenge yourself, pause the video and give it a go. All right, so how did that go? Now let's keep this line as it is, and we're going to modify our function so that this works. So now if you remember, the functions with a input, they go in here and they're called parameters. So currently the parameters are empty, i.e. this function doesn't take any input, and that's why we're getting this error here. It says argument passed to call that takes no arguments. This function is created and defined saying that it can't take any inputs. So let's fix that. Let's use this thing that we wrote here as the input parameter, and we had to say what data type it is. And it's of course going to be an integer in this case. There's no 99.9 bottles of beer on the wall, right? So now this looks like it's working, but it's actually still using this hard-coded 99 here because we're saying it should start from 25, remember? So we have to use that parameter inside the body of this function in order to make it dynamic. So instead of 99, I'm going to use that parameter name, which is called with this many bottles. So if you read this code, it kind of says for number in from 1 to with this many bottles, which is 25. So when we call this function beer song and we say that the parameter with this many bottles is 25, then 25 gets moved into here and then it gets used right here. So now our code is going to start from 25 and go all the way down to 1, which is exactly what we wanted. Now, here's a good point to show you a quick tip. And this is something you might have seen if you've been messing around with Swift or with Xcode. And it's the fact that Swift has the ability to define both an internal parameter as well as an external parameter. And here's why we would want to do that. So when we're calling this function beer song with this many bottles, that makes sense semantically, right? You might say that in English, sing the beer song with this many bottles, and it's number 25. But when you're using it inside your code, you're saying for every number in 1, 2 with this many bottles. That doesn't really make sense grammatically. So what you might want is to have a different name for your parameter inside your function and outside your function, i.e. when it's being called. So we can do this by adding another parameter name right here. So the first name is the outside parameter name with this many bottles, and the inside parameter name is total number of bottles, for example. And then we can say from 1 to total number of bottles, dot reversed, so starting from total number of bottles all the way down to 1. And that makes a lot more sense when you're reading this code as a human, right? And a lot of programming, a lot of good programming, is about making your code really, really clear. Even if somebody comes along with no clue about what your app or your code does, they should be able to read through it quickly and get to understand what you're trying to achieve so that they'll be able to debug it or add features to it with ease. So another thing that you might have seen is the underscore. So instead of having with this many bottles as an external parameter, I can change it to an underscore. And that means that I don't have to use an external parameter. It gets rid of the need for an external parameter. So this is the case where if your function name is already descriptive enough, say if it was like beer song for this many bottles of beer, and let's change that to beer song for this many bottles of beer. And this is a case where my function name is already descriptive enough so that I don't really actually need another parameter here, right? Like number of bottles of beer. That seems really, really extra. And this is something that, we do a lot from Objective-C. So the previous version of the programming language that was used to create iOS apps used Objective-C, and Objective-C is historically known as being very, very wordy, or rather what they like to call specific. And they had these super duper long method names that were really, really descriptive. But Swift, or a Swifty way of doing it, tends to have a short and sweet method name, but has a descriptive parameter names. So a more Swifty way of doing this would be something like this. Print beer song for this many bottles of beer. So we're putting 25 and then changing the external parameter to for this many bottles of beer. And that should now work if I delete this. So that is our beer song. Now, of course, there's still a few improvements that can be had in this beer song. And if you're interested, you can continue polishing it. So one thing I would point out is that 1 bottles of beer on the wall does not make sense in English grammar. So it would be 1 bottle of beer. So if you wanted to further narrow this down, you can think about how you might fix that. The other thing that doesn't make sense is 0 bottles of beer. Instead, if you look at the lyrics, it should say no more bottles of beer on the wall. So that's again something that you could fix. So this is a very brief example of something practical where we're needing a for loop in order to achieve it. Because you do not want to have to write out the whole lyrics to 99 bottles of beer. That is very, very tedious. But right now, with my code, with the power of code, I can write, 1,000 times the lyrics for 99 bottles of beer, where I start from 1,000 bottles of beer and go all the way down to 1. And you can see that my code is doing all of this for me without me really having to lift a finger. Well, I did lift it to write the 1,000, but you get what I mean. All right, cool. So I hope that has been interesting. And I will put this code up to the resources of this lesson so that you can have a look at it and you can modify it as you wish. So that's all for this lesson. In the next lesson, I've got another challenge for you. A bit of a brain teaser for those of you guys who are up for it. And it also involves loops. So see you there. Now, if you're interested, you can actually have a look at this website called 99bottlesofbeer.net. And here, they've actually got the same program written in over 1,500 different languages. So for example, you can see how would you do it in C, or how would you do it in C++. Interestingly, Swift is not yet a submission on here. So for those of you guys who are keen, you can go ahead and submit a new language with your solution so you can improve my solution, make it cleaner, make it shorter, make it sweeter, and you can maybe get your name listed on here as well. So have a look at that if you're interested in how the same program is written in other languages. All right, so we've learned a little bit about loops. We've seen how it can be implemented in a real life example. Now we're going to do a little bit of brain teaser now, and this challenge is completely optional. It's only for those nuts out there who really enjoy a little bit of a brain teaser and a little bit of algorithms. So the idea is that we want to print out all of the Fibonacci numbers until a particular predefined iteration. So Fibonacci numbers are a sequence of numbers where you add the last two numbers in the sequence together to get the next number in the sequence. So the first two are predefined, 0 and 1, and the next one is of course 0 plus 1, which is still 1, and then it's 2, and then 1 plus 2 is 3, 2 plus 3 is 5, and so on and so forth. So this is a sequence of numbers that are seen very much in the real world. So if you search for something like Fibonacci patterns, then you can start seeing all of these golden ratios, all of these patterns being seen in the real world. And it describes a lot of the things that we find really, really attractive, a pattern that humans perceive to be really, really appealing. So these are all related to the Fibonacci ratios. If you look at this where we go from 1, 1, 2, 3, 5, 8, it's the same structure as this picture here. So mathematicians have done a lot with Fibonacci numbers, but in our case, we just want to be able to print out the sequence of Fibonacci numbers until a certain index or until a certain iteration. So in this case, iteration 1 is here because these two numbers are predefined, and then 2, 3, 4, 5. So essentially, we want a function that we can say, let's call it Fibonacci, and we can give it an input, and let's call it Fibonacci until, let's say until 5, right? Then we want to be able to see 1, 2, 3, 4, 5. So we want to see all of this printed in our console here, up to the point that we have defined. So if you're up for the challenge, then go ahead and pause the video now and create this function called Fibonacci, where you can give an input and it will print out all of the numbers until that particular iteration point. So for example, if you've created your function and you put this function call in, you should get all of these numbers printed into the console, and that's where you win. So if you're up for the challenge, go ahead and pause the video now and give it a go. If you are not up for the challenge, then just simply skip to the next lesson. This is an unnecessary brain teaser that I quite enjoy, but not everybody does, and I understand that. It's not required for you to be able to make apps. It's a bit of a math problem that some people enjoy, and it can be fun for some people. But if you're not one of those people, then just go ahead and skip to the next lesson. Now, if you wanted to try this out and you got stuck, then I will also run through the solution coming up next. But make your choices. So either skip or pause, and I will see you at the next point that you choose. All right, so we have the goal of printing out this sequence in our console using a function called Fibonacci. So the first thing is, of course, creating this function called Fibonacci, and it's going to take an input. So the external parameter is going to be until, so until which iteration, and the internal parameter, let's just call it n. So in this case, n equals 5, and it will spit out this whole sequence. Now, if n equals 6, then it will continue into 13, and so on and so forth. So let's go back to 5 and try to print out all of this. So n is going to be an integer. We're not going to be working with decimals. And we're not going to return anything either. We're going to do all of the printing inside our function. So once we call it, the print functions will run inside this Fibonacci function. So how do we do this? Let's break down the problem. Essentially, we want to start off with 0 and 1 in our sequence. So we'll just say print 0 and then print 1. So this is just to get it onto a new line. So we've got 0 and 1 already printed. Now the next one is where our code and our for loop is going to begin. So the next number, this 1, is going to be calculated from 0 and 1, right? So let's say that we create a variable called num1 and it's set to equal to 0, the first number in the sequence. Then we have another one called num2 and it's equal to the second number in the sequence, which is 1. So now we can calculate the third number in the sequence by saying let num equal num1 plus num2, right? So that works. So if we now print out num, then you can see that it's going to print 0, 1, and then it's going to print the third one in the sequence. Now, this is not very helpful because the next step, we're going to have to reset num1 and num2 because we have to shift everything up by 1 now, right? Because num1 is now going to be equal to 1. Num2 is now going to be equal to num. And then the third number will be num1 plus num2 again. So we would have to do this until the nth iteration. So whenever we're seeing ourselves repeating the same code many, many times, then it's probably a good point to be using a loop. So let's delete all of this part, but keep these two, var num1 equals 0, var num2 equals 1. So these two are predefined already. And let's figure out how we can use a for loop to calculate the next sequence for however many iterations we need. So let's say for iteration in 0 to n, so starting from 0, going up by 1 each time until the upper limit n, or until the point that we specify. And that's just defining how many times we want our program to run. Now, inside this block of code that's going to be run many times, so we're going to create a new constant called num, and we're going to let it equal num1 plus num2. So now we're going to print this new number, and that will be 1, right, in this case. Now, at the moment, it's looping through this many times, and it's always printing 1. And that's because we have to update these two numbers to make them always the last two numbers in the sequence. So if we get up to this point, currently num1 equals 0, num2 equals 1, and num equals 0 plus 1, which is 1. So we're here. So now I have to make num1 become 1 and num2 become 1 as well. So to do that, I'm going to say num1 now equals num2. So the first number that we're going to add is now shifted up to the next one. And then num2 is going to equal the current value of num, which is now the third value in this sequence. So basically, num1 has gone from 0 to 1, num2 has gone from 1 to 1. And now you can see that what's printed in here is the Fibonacci sequence. So now, if I go and make this some crazy number, say 20th iteration, then in here, what's going to get printed is all of those numbers that gets calculated by our little bit of code here. So that is a very quick solution to printing out all of the numbers in the Fibonacci sequence until a specified iteration. And if you break it down, it's actually very, very simple. So let's go from the top. We created a function called Fibonacci that takes a upper bound, so the last iteration that we want, and we're saying it's the 20th, right? So now we print 0 and 1 because they are the pre-specified sequences. We can't work them out. They're just the first two numbers that we start with. Then we set num1 to be the first item in the sequence and num2 to be the second item in the sequence. So these two. And then we work out the third item in the sequence, which we've called num, by adding num1 to num2. And once that's done, then we print out this third item in the sequence. So we're shifting it up by 1 so that num1 and num2 always represent the last two items in the sequence. So there's many ways of solving this, including some more elegant but far more complicated ways, such as using recursion. But this bit of code is very short, and it's probably the clearest way of representing what we're doing in this loop. Now, one last thing that I'll add to our understanding of for loops is that you don't always need this name here. In this case, we're not using this thing iteration at all. We're not using it anywhere inside our code. We're not saying, if iteration equals 0. We're not using it. So what we can do is we can simply replace it with an underscore. So in this case, all we're saying is that this loop should run from 0 until n. So 21 times if you think about it, right? 0 to 20. So that was a little bit on how for loops work in Swift. And if you're interested in more of these kinds of algorithms or brain teaser problems to practice your programming, then there's a really great website called projecteuler.net. And they've got an archive of loads and loads of problems like the ones that we showed you just now. So they're sorted by how many people have solved them. So obviously starting from 1, you've got the easiest because they're solved by the most people, and then all the way down to page 13 where you've got the hardest problem where only 200 people have solved it. So if you're interested, it's a cool way of working through and doing something that will improve your programming skills day by day, because you're making your code carry out a specific bit of logic and calculate a problem for you. So the first one in the list is, can you list all the natural numbers below 1000 that are multiples of 3 or 5? So remember in the last lesson when we talked about the modulo, this is going to come in really handy for this problem. So only if you're up for it, and it gets quite challenging quite fast, I have to say, then this is a good place to have a play around and try and improve your programming on a daily basis. So that's all from me for now in this lesson, and I will see you on the next lesson. All right, welcome back to Module 8. We're going to be building our 5th app, which is the xylophone app. So let me show you what it does. We've got a beautiful xylophone app icon, and then if you tap on it, we've got 7 keys that allow you to play a simple tune. Okay, so I'm terrible at the piano, but I'm sure the musicians out there will be able to play much more sophisticated tunes, even though you've only got 7 keys to play with. Now, the aim of this module is not so much to learn new programming concepts. The main thing that we want to teach you using the app Xylophone is how you can go about finding out, using Apple documentation, using Stack Overflow, using the tools that professional programmers use to get help, to figure out for yourself how to build new functionality. And the example we're going to use is how exactly do you get the iPhone to play sound? Now, some of the code that we'll be writing, that we'll be using, will seem unfamiliar. Don't worry if it does, because in later modules, as we start learning more intermediate and even advanced programming concepts in Swift, you'll understand what it is that you're writing. The point is to make you a more self-reliant programmer. So essentially, what we want you to get out of this module is, in the future, when you're building your own apps that uses a certain functionality that we haven't taught you in any of these tutorials. Because if you think about it, an iPhone has many, many capabilities. and we're not going to be able to cover every single one of them. So how do you find out for yourself how to implement somebody else's code, or how to implement a code recipe that enables you to play video or take photos using the camera, etc.? And that's what we're going to be covering in this module. So without further ado, let's get started. Alright, so first things first, we're going to download the skeleton project from the London App Brewery GitHub repository. So the URL is shown in the text below, but it's basically github.com/LondonAppBrewery/xylophone. And then we can download the zip file by going to clone or download and then hitting download zip. And the zipped file will appear in your downloads folder, and then you simply have to click on it to extract the files. And then if you open up the file that you extracted, which is called Xylophone Master, you'll see the Xylophone Xcode project. So double click on that to open it, and go ahead and click open when it prompts you there. Great, so here's our skeleton project, and the first thing that we need to do is to change the bundle identifier. So if your screen looks different to mine, just go over to Xylophone and then go to Targets here, Xylophone. Now, if you don't see this middle panel here, it might be because it's shrunken, like that. And then make sure the General tab is selected, and then you should see it here, the bundle identifier. And you're going to change this part where it says your name to your name, or your company domain, like London App Brewery. Cool. So once you've done that, let's have a look inside the main.storyboard. I'm going to show you around. So you can see that we've already designed a screen with 7 buttons, and they've been given a background color and designed to look nice on all screen sizes. By now, we're happy that you know how to drag buttons onto the screen, so we're going to try and save you from doing the tedious work by giving you a skeleton project to start with. So the other thing that you should have a look is, if you hit this button to show the assistant editor, remember that's when it splits the screen into 2, showing both the design and the code files. Now I'm just going to give myself a bit more real estate by collapsing that side. And sometimes Xcode gets a bit confused where it doesn't really know which is the corresponding code file. And usually what happens is that when you look up here, it says manual, and we have to change that to automatic, and then you'll see that it should be viewcontroller.swift. And this, of course, is the corresponding file. So I wanted to show you that we've linked up all 7 buttons to a single IB action. Now, I'm sure you remember how we linked up IB actions, which is where we held down Control and then we clicked on the button and then we dragged it over like so. Now, we've done this for all 7 buttons, making them all trigger the same IB action called Note Pressed. I'm just going to go ahead and cancel that because it's already there. And you can check this by hitting this little icon here, which is the connections inspector, and you can see as you select each button, it shows you what it's linked up to in the view controller file to an IB action called Note Pressed. And so is this one, and so is this one, and so is this one, so is this one, etc. Now, the other thing that's really important here is that if you go back into the attributes inspector, remember the one with the shield symbol, and if you scroll down all the way to the bottom, if you select one of these buttons and under view, you'll see there's a property called tag. Now, tag is something quite useful, because without this property tag, I wouldn't be able to connect all 7 buttons, same IB action, and be able to differentiate them. So the way that I do differentiate them is using this tag property. So as you can see at the moment, I've got the first button selected and the tag is 1. The second button selected, tag is 2, 3, 4, 5, 6, 7. As you can see, the 7 buttons have each been assigned a unique tag property from 1 through to 7. And this is going to be really useful for us to be able to figure out which button the user pressed. Let me show you how this works. If we go into the code file and head into the part between these curly braces, which is the part that determines what happens when any of these keys are pressed. Remember, all 7 are linked to this one IB action. Now, what should happen? Well, I want to figure out which button was pressed. So what I'm going to do is I'm going to use a print statement, And inside the print statement, I'm going to print the sender, which, as you can see here, is of type UI button. So the sender is the button that triggered this IB action. Sender, and then I'm going to use the dot notation to access a property of the sender. And the property I'm looking for is the tag property. There we go. And then we're going to run our code and see what happens. So here I've got my iPhone simulator running the app as it is, and you can see that at the moment the code file doesn't do anything other than this single line, which prints the tag property of the button that triggered the IB action, i.e. the button that was pressed. So if I press this one, what do you think will show in the console? 7, right? Because the tag of this one was 7. This tag was 4. This is 1, 2, 3, 4, 5, 6, 7. And this basically makes life a lot easier for me, because then what I can do is I can say, for example, if sender.tag equals 1, then I'm just going to use a print statement for now. Print play middle C, i.e. the sound, right? And then else if sender.tag equals 2, then print play D. So this is showing you that I can use this information, the sender and the tag property, to determine which key was pressed, which button was pressed. And based on that, I can determine what to do next. So if this button was pressed, then I'll play middle C. This button was pressed, then I'll play D, etc. And we're going to implement that sound playing ability. But for now, I just wanted to show you why this tag property is so useful. Essentially, if we didn't have this tag property, what I would have to do is to create 7 IB actions, each with a different name. So it would be note 1 pressed, note 2 pressed, note 3 pressed, and it would be very, very tedious and repetitive. The most fundamental rule of being a good programmer is laziness. We don't want to do things repeatedly for no good reason. The less lines of code, the less opportunities for error. That usually means that it's better code. And go ahead and have a look at your own Xylophone app and have a play around using the print statement and sender.tag. And what I talked about just now will make a lot more sense once you mess around with your own code. So as always, there's nothing that you can break when you're writing code. Nothing's going to crash and burn. Nothing bad will happen. The worst case scenario is just that it won't work. So don't be afraid of just experimenting with things, trying things out. Break things in order to understand what it does. One of the other things that you might notice in the design file is that when you click on these buttons, you get these little blue constraints popping up. And that's because I've set up the design file so that these keys will look good on any screen size. So I know that some of you guys are running your apps on, say, an iPhone 7, and some people are running it on an iPhone 6 Plus, etc. There's different screen sizes. Now, if these weren't implemented, you'll get really funky, odd-looking keys. And in the next module, when we learn about auto layout and setting constraints, you're going to learn all about this, and you're going to understand how it works and start using it to make your own designs look great on all screen sizes. But for now, don't worry about them. Just leave them as it is, and in the next module, we'll talk about it in more detail. In the next lesson, we're going to figure out how to play some sound using AV Foundation, which is the library of code that Apple wrote to enable playing sound. So all of that and more in the next lesson, and I'll see you there. In the last lesson, we spoke about the tags that were assigned to each of the buttons, and we use this sender, which is the button that triggered the IB action, i.e. the button that was pressed. We used that sender and grabbed hold of its tag property in order to print out which button was pressed by the user. Now in this lesson, the important thing is not about teaching you a particular aspect of code or a particular aspect of Swift, but it's more broad than that. We want to equip you with the skills to be able to find out for yourself how some of these methods work, or how to go about finding out implementing certain functionality that you might need in an app that you build. So for example, if after the course you want to build an app that involves using the camera or tapping into the camera, but we don't currently have an app in this tutorial series that covers tapping into the camera. And if you think about it, there are so many different things that are available to you through the iPhone. It's not possible for us to teach you every single method or every single API. This is a skill that is really crucial to going from being a learner programmer to an actual programmer. And the skill is being able to find out for yourself, finding the resources, knowing where to look in order to implement anything that you wish, anything that the iPhone is capable of. So let's start with the premise. We want to be able to play a sound, just one sound, say note 1, when we click on any of these buttons. How do we go about implementing the functionality of playing sound? I'm going to show you a good workflow. So first of all, head over to your browser and go to stackoverflow.com. Now, if you're not familiar with Stack Overflow, this is basically a Q&A site that allows people to ask questions relating to something that they don't know about. For example, if we look at some of the top questions featured on the homepage, this person has an Android problem and it's something to do with, and they have a problem with loading the widget when image view is clicked. What we're going to do is we're going to go over to the search bar over here and we're going to search for what we want, which is playing sound in Swift. Let's go ahead and search for that, see if anybody's asked this question. In most cases, any functionality that you're looking for to find out how it can be programmed, somebody will have asked a question about it on Stack Overflow. Now, there's a lot of answers that's come up. Some of them have a lot of votes, which means that there are other people who are interested in this question. That might mean the question is particularly well worded, or it's something that a lot of people need, such as playing sound. And then you can see here there's how many answers have been provided. And there's a difference between the answers that are filled in green versus the one which are empty. The ones which are filled in means that the person who originally posted the question has explicitly accepted one of the answers as the correct answer because it solved their problem. So you're going to have better chances looking at the questions with a high number of votes, high number of answers, and also with an accepted answer. So let's have a look in here and let's see what their problem is and see if it's the same as ours. So this person wants to create and play a sound in Swift that'll play when they press a button. That's pretty much exactly what we want. So let's see who's answered it and what they said. Now, people on Stack Overflow tend to be very helpful, and they tend to provide code snippets of how you can implement their answer in your own code. So let's have a look at the first person who answered. So they said that they've managed to implement this bit of code into their Flappy Swift, which if you look at the top bar here, I can tell that they're making a game. Well, Flappy Swift also gives it away, but they're also importing SpriteKit, which is the library that's used for game development. And here they've also got a class called Game Scene. So these are all dead giveaways that they're developing a game using SpriteKit. Now, we can still apply the same Swift code to our app, even though we're not making a game. So let's see if we can try and implement this. So first, they've imported AV Foundation. They've also imported SpriteKit, but we've got the equivalent for our app, which is UIKit. So we don't need that, but let's put this into our code. And below the import statement, I'm going to add their import AV Foundation, which stands for Audio Visual Foundation. Now let's go back over here and see what else have they got. Next, they've got a sound path that they've created, and they've also created a new audio player, and they've placed that just below the class declaration. So let's try putting that in here. Now, if we read through this code, they're creating a new variable as denoted by the var keyword called coin sound. Let's change this to make it more relevant to ours. Xylophone sound, and then their sound file is called coin.wave and ours is called note1.wave. So we can change that coin to note1. Now you can see Xcode is coming up with some errors here, and if you click on it, it tells you that NSBundle has been renamed to bundle. Now this is something that is happening because Swift is a very young language. It was only released 3 years ago, and it does undergo changes in terms of how things are named or what methods are called, etc. So you do get errors like this. So in these cases, there's two paths to take. One is that after a few of these, clicking on the suggestions and hitting enter, you will eventually get to a point where Xcode is happy. And this is in fact the syntax for the current Swift version, which is Swift 3.0. Now, this is one way of doing it. The other option is to go back and explicitly search for our query, which is play sound Swift 3.0. And there we go. And we've got a bunch of questions and answers that relate to this. And this one is probably the most relevant. How to play a sound in Swift 2 and 3. Let's click on it and see if somebody's provided a good answer. So here they've shown you the syntax for Swift 2.3, and here is the syntax for Swift 3. So if you're a tinkerer and you like to fiddle about with the code until it starts working, then that's one option. The other option is to see if somebody else has provided a solution already, and then you can use this new solution. So in this case, they've actually got this line, which replaces our line here. And it's, in this case, you're declaring a constant called URL, and it holds the path of your sound file, which theirs is called sound name. So ours is called note1, and the extension is not MP3, but it's wave. So we'll change that. So this line creates a reference to where that sound file is located. So later on, when we create our audio player, we have to tell it where the sound is located, so we'll pass it this URL. Now, they've also declared the audio player slightly differently from the last version. Instead of var audio player equals AV audio player, they've got var player is of type AV audio player with a question mark at the end. Now, the question mark denotes that this is an optional, and in future modules, when we dive into more intermediate Swift programming, we'll talk more about optionals. The main thing to focus on is that this lesson, even this module, is not about learning new code concepts. It doesn't matter if you don't understand the code at this stage. This module is more about how to find out for yourself how to implement certain functionality. So let's go with this Swift 3.0 code because it is obviously more up to date than the last one, and hopefully we'll have less breakages in our code. So I'm going to get rid of this line from the last answer, and instead I'll have these two, and then we'll go back to see what else we need. So their URL is actually located in the function which gets triggered when they need to play the sound. And for us, that's not right up here. Instead, it's actually inside note pressed, because that's when we want the sound to play, when a button is pressed. So let's get rid of this print statement and instead put in this line where we create a URL that points to the location of our note1 file. Now let's see what else we have to do. In the next part, they have this do catch block, which I'm going to copy and put into here. Now I'm copy and pasting this in order to show you how everything works as fast as I can. But when you're learning how to program, it's really good practice to just type everything out. The more you type, the more practice you get. And the other problem is that often when you're copy and pasting code, when that code includes these curly braces, it's very, very easy to accidentally copy one too few of these braces or copy one too many. And you end up with a lot of errors that just don't make any sense. If you can, try to write it out. Try to write out the code line by line. Now, of course, for this particular lesson, it doesn't matter. You can just watch as I go along. So I'm going to show you quite a few ways in which people have implemented this playing sound functionality. So let's go with this 3.0 answer that we found on Stack Overflow. Now, first, we've got this do and catch block. In this module, there's a lesson that is specifically aimed at teaching you what this do catch block means. For now, all we need to know is that this is a way of catching errors where you try to do something, and if that action triggers an error, then it gets caught in the catch block and it gets printed into the console. We're going to find out a lot more about do catch blocks in the 4th lesson in this module. So I'm not going to explain it in too much detail. I'm just going to try and implement this person's code and see if it works. very often when you're using code from the internet, it might not work. There might be something that you haven't set up quite right. There might be something that you might have missed out, but usually it just takes a little bit of tinkering. And again, don't be afraid. You cannot break anything. So just try everything, tinker with everything, chop and change. And eventually, as long as it works, as long as you get your desired end result, in this case, it's playing a sound, playing note 1, then our code is successful. And then we can go through the code and try to understand it. So let's test it out and see if it works. Okay, so it's not happy with this error.description. So let's see if we can delete that and see if it's happier now and if it'll build my app. So now we've launched our app. I'm going to try and click on it, see if it works. Great. So we've just implemented sound playing ability. And notice that every single button is playing note 1. And this is because we've only programmed our app to play note 1. We haven't told it to play a different note for a different button. And we're going to do that in a future lesson. Again, to stress, this lesson is all about experimentation. The goal for this lesson is not even to write any code. It's about experimenting and implementing solutions that we can find. So now that we've tried this way of doing it, if we head back over to Stack Overflow, you can see, and we searched for playing sound in Swift again. And we have a look at that question we were on. So this was the first answer we found. And this is essentially a Swift 1 answer. Now we found the one that was upgraded to Swift 3, so the syntax changed ever so slightly. You have this do catch block that didn't exist before. And we've successfully managed to implement it in Swift 3. But if you actually scroll down, there's quite a few other answers that also solve this problem. For example, this person decided to use something called Audio Services Create System Sound ID. Now, as you can see, his code is a lot shorter than ours. And that might be one of the reasons why you might want to implement this instead. So let's see if we can implement this in our code instead of using the previous example. Now, he says that first you have to import Audio Toolbox, which is different to what we have. We've imported AV Foundation. So let's change that to Audio Toolbox. Next, I'm just going to copy and paste this code over. Now you can see it's already starting to give me errors because I got rid of that previous import, which is required in order to use AV Audio Player. So let's go ahead and delete that, as well as these lines. Now be really careful when you're deleting lots of code when that contains brackets, because for example, if I delete everything up to here, my code will break, and I'll show you why. Do you see now I've got one closing brace here, and if I double click on it, it shows that that closing brace is closing the note pressed IB action. So there's a problem. Which one then is closing this one? The class. Remember, every single code file has a class at the top and it needs to have a closing brace. So this originally was for closing the class, but just now when I deleted that whole block of code, I also deleted a closing brace that wasn't meant to be deleted. So let's put it back in, and instead let's put in this guy's code. Again, you're going to need to do a bit of fiddling about, so you can either just click on the suggestion, hit enter every single time it gives you a new suggestion, or you can actually just edit it to make it look like what it does on the screen. And then there's a problem here, hit enter. But before we hit run, let's change the resource name to note 1, and the extension stays the same as wave. So let's run this app and see if this other solution works as well. Great, so that also works. And we've just shown how you can implement the same functionality using completely different code. So whenever you're looking for how to implement a certain functionality and you're searching in Stack Overflow, if one of the answers don't work for you, the first thing to do is have a look at the comments below the answer. Other people might have had issues with it too, and they might show you some of the ways in which you can fix your code to make it work. For example, this block of code no longer works from Swift 2 upwards. So Swift 2, 2.3, Swift 3, etc. And if you look down at the comments, somebody has actually very helpfully said, in Swift 2, remember to use the do catch block. And so, when you're looking for solutions and you try out one of the solutions, you tinker with it, it doesn't work, have a look back to see if there's more helpful hints, or have a look at one of the other answers and see if that might be able to help you. Now, in very rare occasions, Stack Overflow might not have the answer. So what else can you do? Well, there's another resource that's similar to Stack Overflow. It's again a question and answer forum, but it's hosted by Apple. And this is the Apple Developer Forums. And everything that I'm going to talk about in this lesson has a link in the text box below. So check it out and bookmark them for future use. So once you're here in Apple Developer Forums, you can search and ask a question. It's very similar. So let's search for playing sound Swift, exactly what we typed into Stack Overflow, and see what we've got here. And you can see here you've got playing audio in Swift 2.0. And generally what happens in the Apple Developer Forums is people encountering problems and trying to find other people who've encountered the same problems. So this guy's actually come into some sort of problem, and somebody from Apple is actually trying to help him down here. So let's go back and see if there's another one. So let's go back and see if there's another question that might help us a bit more. What about this one? Simple Swift sound code, iOS. So this is a question with an accepted answer, and that accepted answer or correct answer is highlighted in green below the question. So here they provided some sample code that allows you to play sound. And if we have a look at it, it looks very similar to the first answer that we found on Stack Overflow, which is again creating an AV audio player and then playing it using the do catch block. And if you implement this, this will also work for playing the sound. We've already tried it out before. It's along the same vein. So basically, have a look between Apple Developer Forums and Stack Overflow. You'll usually be able to find the answer that you're looking for. And if you can't, there's always the option of posting your own question. Now, the way that Stack Overflow works is that people amass reputation depending on how many upvotes they get on their questions and answers. And if you are somebody who provides an accepted answer, you also get boosts in your reputation. So it is kind of gamified, and Stack Overflow is a really, really great resource full of experienced programmers who are willing to help. So now the other thing that you might be aware of is the Apple documentation. And online, Apple hosts their guides and sample code, as well as their API reference. Now, the problem with this is that when you're trying to search for how to do something in here, when you have absolutely no idea what code you should implement, it can be very difficult to find exactly what you need. So for example, if we search for the same thing here, so we've got some example code regarding Scene Kit, which is not what we want, something about AirPlay, something about Apple Design Awards, using Swift with Cocoa and Objective-C. A lot of this is not relevant, and the unfortunate thing is that the search functionality of the Apple documentation is not great. But if you do persevere, hidden amongst all of these results is something that is probably relevant. So here we found the working with audio documentation. So they've got some video from WWDC, and they've also got some documentation and sample code. So let's have a look over here. Do you remember earlier on when we used AV Foundation to play our sound? Let's have a look at the guide and references. And you'll find a lot of information about how AV Foundation works, and you can read through this and really understand how the playback works, or how Audio Player works, or how AV Foundation, or what else AV Foundation allows you to do, etc. Now, the only thing about these guides is that sometimes they're not quite updated. If you navigate over here, you've got something called Playing Sounds Easily with the AV Audio Player class. And you can see that they've got some example code and some explanations about how AV Audio Player works. The unfortunate thing is that iOS apps used to be programmed in Objective-C. And a lot of the documentation that Apple wrote relates to that language, Objective-C. And Objective-C and Swift are actually quite different. So when you're looking at this documentation, a lot of their sample code is actually written in Objective-C, which makes it very difficult when you're trying to just find some code to implement that carries out the functionality that you're looking for. So we actually recommend you use the documentation in a different way. The documentation is great and you will learn a lot from it, but don't expect to find, code blocks that you can implement easily. You'll find those within Stack Overflow or within the Apple developer forums. But once you have found them and you've implemented them, then you can actually read up on what it is that you've got. So for example, here we're using something called Audio Services Play System Sound. And if you hold down the option button, you get this little question mark that comes up when you hover over any of these methods or properties. So if I just click here, Audio Services Play System Sound, while the option key is held down, it actually shows you the documentation that relates to this method. And you can read up on the description or how it works, and you can learn quite a bit about it by doing this. The other thing that you can do is you can hold down Command and click on the method, and this takes you to the place within the Apple library where it was declared, again with more information and background on what it is that you're using. Now, another really great resource is Apple's API reference, which you can access at developer.apple.com/reference. Here, you can find all of the methods and classes that are contained with those libraries that we've been using. So for example, if I go down to the media and web section, you'll be able to find Audio Toolbox, which is one of the libraries that we used, and the other one was AV Foundation. So if you click on that, you'll get taken to a page where it explains how you can use this framework in more detail. You'll find all of the classes that you can use under this AV Foundation, and here you can search for the thing that we use, which is AV Audio Player. Here we go. And if I click on here, it takes me to the reference for AV Audio Player, and you can select your code language, whether if it's in Swift or Objective-C. And it tells you what it does. An instance of the AV Audio Player class called Audio Player provides playback of audio data from a file or memory. And you can find out some really interesting details about it. For example, it actually says that Apple recommends you use this class for audio playback unless you are playing audio captured from a network stream or require very low latency. So for example, if you go back to your Xcode project and you run the code using this version of the sound playing code, you'll find that the latency for playing sound is much lower than when we used AV Audio Player in the previous version. So this might determine what code you might implement. And there's a lot of these nuggets in these references that you can find. You can also find all of the methods that's associated. So we had Audio Player play. You can use Audio Player pause, or you can have stop. You can check to see if it's playing, etc. So you can find out a lot more detail about this AV Audio Player that we used previously. So essentially, to summarize, when you are in the market for finding out how to code up a new functionality that you've never done before, say you want to play video, your first port of call should be searching to see if somebody else has tried to implement this on Stack Overflow or on the Apple developer forums. See if people have provided sample code. Use that sample code to implement the functionality within your own app. And you might have to fiddle with it a bit, chop and change your code. And once you have implemented the code and it works, then you should find out how the code works. And that's either by looking at the documentation for the methods that you're using, or if within the code snippet that you just found on Stack Overflow, there's programming concepts that you don't understand, like guard or do catch, then a really good resource is the Swift Programming Language Guide, which is a book that Apple wrote, which you can actually get on iBooks, as well as at this link here, which will be in the text below, where you can find out all of the fundamental Swift programming concepts. such as what are strings, what are basic operators, and these are a lot of the things that we're going to go through in this course. Having done the introduction to Swift programming, you would have gotten a good understanding of functions as well as variables and constants. Now, in future Swift programming lessons, we're going to dive deeper into optionals, into classes and objects, but of course, we're not going to be able to cover every single tidbit of the Swift programming language. So this is a really good resource for you to refer to when you get stuck on certain parts of Swift programming. And the API reference is a really great place to find out more about these methods and classes that you're using, such as AV Foundation or Audio Toolbox, etc. Now, in the next lesson, we actually detail the code that we recommend for you to implement the xylophone playing sound capability. So have a look at the next lesson if you haven't managed to implement the sound playing ability yet. Alternatively, if you've already managed to follow along with one of the answers on Stack Overflow or what I've written on the screen, then feel free to skip to the lesson afterwards where we explain this do catch block and what it means and how you use it. So I'll see you on the next lesson. All right, so now that we figured out how we can use the tag property of all our buttons to determine which button was pressed, we're going to move on to the next part where we actually play a single sound. So if you have a look in the left-hand folder here, there's something called sound files, and contained within, we've included 7 notes of the xylophone. And if you click on them, you can preview the sound, and you can even swap in your own sounds by just deleting these. You can drag in your own WAV files or MP3 files. Okay, so let's go back to the viewcontroller.swift file, and I'm going to get rid of the assistant editor because I'm just going to be working inside the code. So press this little button up here, and then we've got a full screen page of code. Now, I'm going to delete this print statement because we no longer need it. We understand how the tags work and how we can use them to determine which button was pressed. So our aim is now to play a single sound, which is note 1. We're just going to play that every single time any button is pressed. For now, later on we're going to make the sound file that gets played match the button that was pressed. But for now we just want to play a single sound. So I'm going to show you a recipe, a number of steps that you need to carry out in order to play sound. So the first step is below the import UI kit. Remember that we mentioned that UI kit is just a Swift knife in the form of a bunch of code that Apple wrote to give you certain functionality without you having to write the code yourself, such as the arc-for-random function. Now, this time we're going to import a different code library, and it's called AV Foundation. And this is a package that allows us to tap into the audio-visual components in the iPhone, and we're going to use it to play a sound. So once you've imported AV Foundation, next you're going to go over here, and after the part where it says UI View Controller, you're going to write a comma, and then you're going to write AV Audio Player Delegate, this one. There we go, hit enter. Okay, so that's step 2. Step 3, we're going to declare a new variable with the var keyword, and we're going to call it audio player. Again, using camel case if you remember. We're going to give it a type, AV audio player, and we're going to use an exclamation mark at the end. So I know that a lot of this code looks very new. Don't worry about it for now. For this app, we're going to be using a programming recipe. So it's basically just the step-by-step number of instructions that you carry out in order to achieve some sort of goal or task. Now, why we use the exclamation mark and what exactly are delegates will be explained in future modules. So this is essentially a recipe of a number of steps that you need to go through in order to play sound. So step 1 was import AV Foundation. Step 2 was adding the comma and the AV audio player delegate. Step 3 was creating a variable called audio player that's of type AV audio player with a exclamation mark at the end. And step 4 is creating a sound URL that contains our sound file. And that's going to be inside note pressed. So I'm going to create a constant using the let keyword, and I'm going to call it sound URL. And it's going to be set to equal bundle.main.url. And I'm going to use the suggestion that Xcode gave for resource with extension. I'm going to hit enter. And the resource here is the name of my sound file, which happens to be note 1. I'm going to insert the string note 1 over here. And the extension is, of course, the file type, which is wave here. So over here, you can just type wave, and that's your sound URL completed. Step 5, I'm going to set up the audio player to try and play the sound. So first I type do and open and hit enter to close the brace. And in here, I am going to set my audio player to equal try AV audio player contents of URL, which is the URL that we just created. So we're going to set up our audio player with the sound file. This is the equivalent of opening up that CD player and putting in your disk. So the contents of the audio player is going to be sound URL. And that's, of course, the path, the directory path of where that sound file is. So this line, sound URL equals bundle_main.url for resource, sets up the location of where our sound is. In this line, we try to initialize or set up our audio player with the content of sound URL. So then sound URL, we're going to give it a exclamation mark, and then we're going to move on to step 6, which is a catch block. So open curly brace and hit enter. And then in here, we're going to print the error if there are any errors. So I'm going to explain do, catch, and try in the next lesson, but essentially it's just a way for us as programmers to figure out if anything went wrong, then why it went wrong, so that we can print the error into the console and we can figure out where our code has broken. And I'll show you how we use that in the next lesson. Okay, so now after we've done the do and catch block, we're going to finally try and play the audio. So audio player dot play. And now if we run our app, let's see what happens. Okay, so we've managed to play our first sound. The only thing is that all the buttons play the same sound, but this is expected because if you have a look at our code, we're setting the sound URL to just be note 1. We haven't changed it anyway. And in the next few steps, we're going to use our code to modify which sound gets played depending on which button gets pressed. But the main thing that I wanted to introduce to you in this lesson is the idea of following a programming recipe. So the next time that you need to play a sound, you can essentially follow those same 6 steps to play any sound that you've included in your project. A lot of times we get asked by students, how do you know how to do all of this? Do you remember all of this code? And the answer in most cases is no. Most programmers won't remember by heart all the different methods, all the different API calls that you can potentially use. But what we do remember is, for example, the library that is needed, such as AV Foundation, or the methods that we use in order to play sound. And it's very quick and easy to find them at a later stage from the documentation. But at the end of the day, it's really helpful to have your own set of recipes for certain functionalities, such as playing sound or playing video or tapping into the camera. These steps don't really change in future projects that you do. So what some programmers do is that they like to collect together recipes, which are step-by-step instructions essentially in how you implement certain functionality. And that's something that you can start doing already. Place the code into a Swift playground or use a note-keeping app such as Evernote to document those steps. And the next time that you want to create an app that has that functionality, it's easy to go and search for it and then just implement it. In this lesson, we learned about how to use programming recipes to implement certain functionality. In the next episode, I'm going to explain to you something that I did in this lesson, which is the do, catch, and try block. The important thing is that don't worry if you've just written a bunch of unfamiliar code. In the coming modules, you're going to learn more in depth about what each of these things do. The exclamation mark or what is a delegate, etc. All of this will be understood in future lessons where we go into more advanced Swift topics such as delegates and protocols, optionals, etc. All we want to show you in this lesson is how do you take somebody else's programming recipe or somebody else's code example and implement it in your own code in order to achieve the ends that you're looking for. So again, it's just to reiterate that you don't have to understand 100% of everything that you wrote in this lesson. In the coming modules, in the coming lessons, when we start diving deeper and deeper into Swift programming, it'll all become clear. But for now, it's about how you deal with that uncertainty as a new programmer, and yet despite that, how you can still use it to achieve your ends. So we'll see you on the next lesson when we talk about do, catch, and try. All right, see you there. Okay, so this is the code that we wrote in the last lesson. And I just want to take a moment to explain this funky section where you've got a do block, a catch block, and this keyword try. Now, it can look very confusing, but I'll show you what it does. So essentially, the trouble comes along when we are trying to set what our audio player should play. So remember, in our analogy, this is like opening up the CD player and placing in that CD. Now, if I give myself a bit of space and I just drag this part out of the try block and then leave it there, and then I'm just going to comment that out of the code. Here is the functionality that we essentially need, setting the audio player to contain a URL of what it should play. And that's done by initializing the audio player with the sound URL that we created up here. Now, as you can see here, we've got an error. And it says that call can throw, but it's not marked with try, and the error is not handled. So what does that mean? If I hold down my command button and I press on the AV audio player, I go over to the AV Foundation library file. And over here you can see the method that we're using, which is contents of URL. And at the end, it's got this keyword throws, which means that when you execute this method, it can throw an error if something goes wrong. For example, if your file that you tried to get it to play was corrupted, then it will throw an error telling you that there's a problem. So that's why we need the try. But the problem with just having try is that if it does throw an error, it's not caught. And in Swift version 2.0, Apple introduced this new do catch statement where you write do, which is what should happen, and then you have catch, which is what should happen if there is an error, in which case you probably would want to print the error to the debug console. So there I've essentially just rewritten what we had before. Now let's try and run this with a corrupted file. So at the moment I'm trying to play note1.wave, and I'm going to click on my sound file and change the format to MP3, which we know it's not, it's a WAV file. So this is basically just an incorrectly named file. And we'll change the extension to MP3. So here we're trying to locate the file that's called Note1 with extension MP3. And as you can see, it exists, note1.mp3, but it's actually not an MP3 file. And if you tried to read it as an MP3, it wouldn't work. So let's try running it and see if our do catch block actually catches the error. So I'm going to click on one of these buttons here, and you can see here in the console debug, it pops out with an error. And it gives you an error code, which is really important. So now what I'm going to do is I'm going to copy this error code, Command C, and then I'm going to go to a website called osstatus.com. The link will be in the text box below this video. This is a really useful website. It's not created by Apple. It's actually a third-party tool. And what it allows you to do is to look up those error codes. So I'm going to paste that error code that I had from before, and I'm going to hit the search bar. And hopefully this is going to tell me what that error means. So it tells me that the error is audio file invalid file error, or audio file stream error. because of invalid file. So, and the description says this file is malformed or otherwise not a valid instance of an audio file of its type, which is true because we changed its extension to MP3, even though it's actually of type WAV file, even though it's actually a WAV file. So this is the beauty of error handling. When you have a large code project or large app that has, maybe 20,000 lines of code, if the sound files haven't been corrupted, you wouldn't know if random errors can occur. And by having this error catching mechanism, you can figure out what is the problem and fix it. So this is a great website to bookmark, by the way, for all your future app development needs. It served me quite well. Now let's head back into our app and let's just fix that by changing this to WAV and by changing our file extension back to WAV as well. Okay, so now our app should work as it did before. And I'm going to show you something else. Now, what if you had a really small app project where you were pretty much 100% certain that there's absolutely no way that it can throw an error? Well, there is a essentially manual override, if you will. Instead of using the do catch block where you catch the error and deal with the error, you can also force this line to run by adding an exclamation mark after the try. Now, this basically says, I don't think that this line will ever throw an error. My sound files are always going to be perfect and there's never going to be anything happening with this. Now, this is a very brave statement to make, and Swift kind of reflects this. Whenever you're using an exclamation mark, it's basically saying, I'm doing a manual override. I know what I'm doing. Machine, you can step aside and, let the master do its work. And Swift then becomes hands-off and lets you essentially screw up all by yourself. This is a very brave way of going about things, but in certain cases you might need it. In most cases, I would advise to catch the error and deal with it rather than this way of just sticking your finger in your ears and going la 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 la. So in this lesson, we introduced you to one of Swift's error catching methods. And there's actually a few more, which we might explore in later modules. But essentially, Swift was designed to be a very safe language. It's created in such a way that alerts the programmer whenever they're trying to do something that is very risky. Namely, it can create errors. So keeping that in mind, we want to try and be as safe with our code as possible and minimize the number of cases in which it might crash. In this lesson, we learned about the do catch statement as one of the ways in which Swift can handle errors in your code. In future modules, as we come across the need to use different error handling mechanisms, we'll talk through them as we come across them. In the next lesson, we're going to go back to our xylophone app and continue building it so that we can play a different sound depending on which button was pressed in the app. All right, so I'll see you there. All right, so now we're ready to continue building our xylophone app. Now, this is the code that you should have in front of you, and it's what we had at the end of lesson 4 when we implemented AV Foundation and used the AV audio player to play a sound, namely note 1. Now, if you used one of the other suggestions or one of the other ways of playing sound, that should also work, but just keep a note of some of the differences. So now that we've created this sound playing ability inside note pressed, it's time to evaluate whether if this really is the right place to put that. Now, remember when we did the Swift programming tutorials, we mentioned that functions are for encapsulating packages of functionality together. And this seems like an appropriate example to package our sound playing functionality code all together into a single function. So let's go ahead and do that. Now, remember, when we're creating functions, we don't want to put a function inside another function. So, for example, if you have a look at this curly bracket, it encloses everything that's within the class, so everything that is our code. Now, if you go to the one slightly above it, that is the closing brace for the IB action note pressed. So we don't want our function to exist inside this other function or IB action. So we're going to declare our function just here, just above the last closing brace. And of course, remember when you're creating new functions, you need to use the func keyword. And we're going to give our function a name that is descriptive of the functionality that it contains. Namely, it's going to be play sound. And it's not going to take any inputs, so it's just an open and close round bracket. And then I'm going to open a curly bracket to define the beginning of my function. And most importantly, I'm going to hit enter so that Xcode automatically inserts the closing brace. And inside play sound, I want to have all the functionality that's related to play sound. So that's everything from creating the sound URL all the way down to audio player.play. So let's just drag all of that into play sound. Great, so now we have all of our functionality within play sound, but our IB action, note pressed, is now completely empty. Nothing will happen when we tap on one of the buttons. So let's restore that functionality here by calling play sound. And of course, when you call a function, you simply just write its name with the round bracket. Right, so now that we've isolated the sound playing functionality into its own function, and we've called it inside note pressed, the next step that we want to embark on is to be able to select the corresponding sound file when we press a particular button on our app. So when we press the topmost button, we want to be able to generate note 1. And then when we press the last button, we want to be able to generate note 7. So how should we do this? Well, do you remember this sender.tag that we were experimenting with in the beginning of the lesson? We used sender.tag to grab hold of the tag property of the button which triggered the IB action, i.e. the button that was pressed. And that tag started from 1 for the topmost button all the way down to 7 to the 7th button. What we're going to do is we're going to use this sender.tag to pick out the correct name of our sound file. So how are we going to go about doing this? Well, one way of doing it, which you're already familiar with, is creating an array of all the sound files from note 1 to note 7, so that we can use the sender.tag to pick out the correct note as and when we need to play them. So I'm going to delete this example and we're going to create an array. And of course, all our variables and arrays are usually declared just below the class declaration, which is this line. So I'm just going to put it below the audio player variable. Now, you're pretty familiar with arrays by now, so go ahead and have a go at creating an array called sound array that contains all of the names of the sound files from note 1 to note 7. So pause the video and see if you can complete the challenge. All right, so how did that go? Well, let's try and create that sound array. Firstly, we're going to use the let keyword to create a constant. Remember, we're not going to change any of the content of our array, so therefore it's going to be a constant. And we said it would be called sound array. And it's going to set to be equal all the sound file names. Now, we don't need to use the .wave part, just as we didn't need to use the PNG extension when we made the array in Dicey. So let's create an array of all those file names. Okay, so here's an array of all of our 7 sound files. Is this what your array looks like? If not, or if you're still confused about arrays, have a look back at the lesson in the Dicey module where we talked in detail about arrays, how we create them, and what they're for. Okay, so now that we've got our sound array, we have to go back into our note pressed IB action. And we're going to use that sender.tag property to pick out the correct file name from the sound array. So we're going to create a variable using the var keyword that's going to be called selected sound file name. And it's going to be of type string. And it's going to equal sound array open square bracket. Then it's going to be sender.tag. Now, what this line does is that we create a new variable called selected sound file name that will contain strings only. And we use the sender.tag, i.e. the tag of the button that was pressed, to pick out a sound file name from the sound array. So if this line of code still doesn't make sense to you, that's okay. Let's print it out and see what it does. And I'm going to run the app. Okay, so let's see what happens when I click on these buttons. The first button generates note 2, note 3, note 4, note 5. And then at the end, I get this fatal error. Now, why is that? I'll give you a hint. Remember when we learned about arrays in the Dicey module? We said that arrays are counted starting from 0. So the first object is at index 0, and the second is at 1, 2, 3, etc. See if you can fix this error yourself and prevent the app from crashing when you get to the last button. Now in the next lesson, we're going to talk in detail about this index out of range error so that we understand what it is and we can fix it in the future when you come across this error again. The array index out of range error is a really commonly encountered error when people are starting out learning how to program using arrays. Now, let's try and recreate that and see when that error occurs. Now, in programming, it's really good practice to have an expectation of what you think should happen and then find out the reality. And if there's any discrepancies between what you expect and the reality, then it's your time to fix the bugs and figure out why that is. Let me show you. When I click on the first button, I get note 2, note 3, note 4, 5, 6, 7. And right now, if I click on this last button, my app is going to crash. Let's show you. There we go. Fatal error, index out of range. What does that mean? If you remember, arrays are numbered starting from 0. And the tag property of the first button here is 1, whereas the tag property of the last button is 7. So index 1 of sound array is not note 1, but it's note 2, because note 1 is index 0. So when we were pressing through all those buttons, essentially we were grabbing the items from sound array by going 1, 2, 3, 4, 5, 6, and then this last one was index 7, which of course does not exist. There is no note 8, and which is why it gives you the error of fatal error, index out of range. So that should now make a bit more sense. So how do we go about fixing this? Well, an easy way, you might think, is to change the tags of each of these buttons so that it corresponds to the array index. So this could be tag 0, tag 1, 2, 3, 4, 5, 6, right? Then that fixes our problem. Well, there's a slight issue with that. Everything on screen is given by default a tag property of 0. Let me show you. If I drag on a button from my object library and I have a look at its tag property, it's tag 0. So everything that's on screen, including the background, is given a tag of 0. That means if we change this to tag 0, it's going to be slightly confusing for Xcode. But instead, we can fix this in our code. Now, the key lies in this line. And it's a bit of a problem-solving exercise. So if you haven't yet managed to figure out how to fix this error, hopefully by understanding a bit more about how this error occurs and how arrays are numbered, you can now fix the code by changing this highlighted line. Pause the video, give it a go, and see if you can prevent the app from crashing when you press the 7th note. Now, hint, it has absolutely nothing to do with this yellow warning. This yellow warning is to do with the fact that Xcode wants us to change this var to a let. And because I have greater ambitions for this select sound file name variable, which I'll show you later on, we're going to leave it as a var. But try and think, where else within this line can you adjust so that the console prints note 1 when we press the first button? So pause the video. I'll give you a moment to see if you can figure it out. Okay, how did that go? Well, for those of you guys who figured it out, of course the answer is very simple. So here we have the sender.tag, which we know is going to be 1 for this first button. And we know that 1 pulls out note 2, where in actual fact we want note 1. So the simplest thing to do, and the correct answer, is of course to just put -1. So when that tag is 1, it becomes 0. When it's 2, it becomes 1. And most importantly, when it's 7, it becomes 6, so that we don't trigger this error where index is out of bounds. So now, if your app ever crashes in the future because of this error, array index out of bounds, you'll recognize it and you'll know exactly what to do to fix it. Now, in future modules, when we're building larger and more complex apps, we'll be purposefully encountering some of the most common errors and bugs in Swift programming. And the idea is to get you used to seeing the error messages, so you'll know what to do when they occur out in the wild when you're building your own apps. So in the next lesson, we're going to continue building our xylophone app and make our app play the note that the user selected. So I'll see you there. All right, so now that we can print out the sound file name that corresponds to the button, the next stage is, of course, playing the sound that corresponds to the button. Remember, at the moment, no matter which button we press, it only plays note 1. And that's because this is hard-coded. This is always going to say note 1. So we want to change this from note 1 to this variable selected sound file name. As we found out before, by using this line of code, we could get note 1, note 2, note 3 printed to the console, and therefore we could also transfer it in here so that our resource becomes the sound file that we need. So how do we go about doing this? Well, the most obvious way seems to be getting rid of this explicit string with the quotation marks and inserting the variable selected sound file name. Now you can see already as I'm typing this variable selected sound, even though I'm giving Xcode a bit of time, it's not automatically suggesting to me selected sound file name, which is what I need. Now in most cases when I'm typing out something that the system recognizes, say if I was typing out sound array, you can see that Xcode will automatically suggest sound array to me as a valid thing to insert here. Now, it's not suggesting selected sound file name for a reason, and it's because of something called scope. Now, scope is a really interesting thing. What it means is that when this variable is created or declared inside this function, inside the curly braces of this note pressed IB action, then it is only usable within these curly brackets. If you try to use it anywhere else, you would not be able to tap into it. But if I declare it right up here inside the class or the curly braces of the class, then I can use it anywhere within these curly braces. So basically, it's nested inside a function and I can't get access to it. Now, in the next lesson, we're going to explain a little bit more about scope, and we're going to talk about global and local variables, in which case this is a local variable, and this would be a global variable, which is accessible to everybody that's within the same class. So let's fix this by creating this variable right at the top of the file. So let's just put it below the var audio player. So var selected sound file name, type string, and let's make it equal to just an empty string for now, just 2 quotation marks with nothing in between. Now that we've created our variable up here, we've built our little container, even though it contains an empty string at the moment, later on we can change that string by getting rid of the var, so we're no longer making a new variable. Instead, we're now just changing the value of the selected sound file name variable. So let's get rid of this type declaration as well. So all we have is selected sound file name, which comes from up here, and we set it equal to a new value, which is the name of the sound file that we want to play based on what the user pressed. And if we go down here and now we type selected sound, there we go. So Xcode now knows, about selected sound file name, and it's now able to see this variable selected sound file name. Whereas before, when it was inside NotePress, it was not able to see it. So let's go ahead and hit enter so that Xcode automatically inserts it in here. And you can see that my code has wrapped around. Now, I haven't typed enter, I haven't changed line here. It's just because I don't have enough space that is decided to put it on the second line. So I'm going to get rid of my right-hand pane so that you can see this a bit more clearly. They're all on the same line. The extension's not going to change because all our files are WAV filed, so we'll keep that the same. The only thing that's now changed is what that resource file name is. And that resource file name is now programmatically determined by which button was pressed. So let's run our app and see if it works. Okay, so now I've run my app again, reflecting the latest changes in the code. And if I click on the buttons, there we go. You've got a beautiful xylophone app that you've just created. All right, so let's just take a moment to review our code and see exactly what's going on in the code that we've written. So firstly, when I click on the first button in my app, which has a tag of 1, this IB action note press. So everything in here gets triggered. And the sender, of course, is that first button. Now, that button has many properties, including its background color, for example, which is red, but also a tag property. And the tag property we know to be 1 because that's what we set it as. And so when I click on that button, that tag property gets moved over here into our code. So the 1 gets inserted here where it said sender.tag. So 1 minus 1 is, of course, 0. So essentially what we're doing in this line is we're looking for the 0th index in sound array. So if we have a look inside sound array, of course, the 0th index is note 1. So then our selected sound file name becomes the string note 1. And then that selected sound file name is used over here where we set the resource that we want to play. And of course, it is again equal to note 1. So then we use our AV audio player to play note1.wave, and audio player plays the sound. So essentially, this is how we can use the buttons with their associated tags to pick out the relevant sound file name and then get our audio player to play it. And there you have it. That's your completed xylophone app. In the next lesson, we're going to talk a little bit about scope and why it is that we needed to move the declaration of this variable selected sound file name from within note pressed IB action to within our class. So we're going to talk a little bit about global and local variables, and then hopefully you'll understand why we did that a little bit better. And we're going to dig into the theory behind that a little bit more in the next lesson. So I'll see you there. Right, so in this lesson, we're going to talk briefly about a programming concept that we encountered in the last lesson, and that's of course scope. Now the apple trees and the fence will start to make sense in a little bit. Let me show you the theory in code. So here we've got the code for our xylophone app. So I'm inside the viewcontroller.swift file, and this should be the code that you have as well. Now I'm going to talk about something that we did in the last lesson, that is moving this variable called selected sound file name from within the IB action note pressed to outside it and just below the class declaration. And I want to explain why we did this and what is the programming theory behind this. So let's put it back. So I'm going to take this variable and put it back into the note pressed IB action. Now you can see I'm creating the variable called selected sound file name inside the note pressed IB action. And the first thing that you'll notice is that we haven't changed any of the rest of our code. And Xcode has already given us one warning and one error. If you click on the warning, it says that the variable called selected sound file name was written to, i.e. a value was put inside it, but it was never read. So we never made use of that variable. And if you have a look down at the error down here, it says there's a use of unresolved identifier called selected sound file name. That means Xcode does not know this variable selected sound file name. It has no idea what you're referring to. And the reason for this is this thing called scope. Scope is about the visibility of variables. If you create a variable within the curly braces of a function, then that variable is called a local variable, and it is only visible within those curly braces. So I can use it freely within here. For example, I can say print selected sound file name, and Xcode would know perfectly well what it is that I'm referring to. And you can see that warning where it said that it was written to but never read disappeared, because I'm reading it right here. I'm going to print it to the console. Now the problem comes when you're trying to use this local variable that's declared within the curly braces of a function. If we're trying to use it somewhere else, for example within playSound or within viewDidLoad, if I did that, it would give me this error saying that it has absolutely no idea what it is I'm talking about, because local variables are only visible locally, i.e. within this function. But if instead I created this variable up here, just below the class declaration, where it is outside of any of the curly braces of the functions, and it is essentially at the same hierarchical level as any of these other functions, then it's visible to everybody within the class. So now you can see that error went away, because now it knows what selected sound file name is within playSound and within notepressed. And if I wanted to use it within viewDidLoad, I can do that also. So now it's essentially visible to everybody within the class, because it was declared within the curly braces of the class and not within the curly braces of a function. So now, while having that variable declared as a global variable, namely it's accessible to everybody within the class, allows us to use it both inside playSound as well as inside notepressed. Now that's useful because that allows us to set the value of it inside notepressed and use the value of it inside playSound. But the problem is that this is not an optimal way of using variables, and I'll explain why. Now remember the apple trees and the fences that we showed you earlier on? This is where it comes into use. So I want you to imagine that this is essentially your garden and this is your house, there's your front gate, and in your backyard you've got this apple tree, right? Now if that apple tree is within the boundaries of your own garden, only you can pick those apples. But if that apple tree was instead in the neighborhood, i.e. outside the fence of your own property, then anybody can pick that apple tree. So this is the same problem. So when you have an apple tree in your backyard, that is equivalent to a local variable where only you have visibility to that variable. But when that apple tree is outside your garden, in the neighborhood, then it is accessible by everybody else, including yourself, but also by the Browns, the Joneses. Anybody can pick that apple tree, and you have no control over it. Now let's go back to our xylophone app. And if I run the app, you'll be able to see that it's working exactly as we expect it to. We haven't changed the code since the last time we completed the app. And when I click on the buttons, you can hear that they have different sounds. And that's, of course, as we explained, because of this line, where we're setting the selected sound file name to correspond to the button that was pressed. Say if I was testing my code and I was playing around with it and I decided to change the selected sound file name inside playSound to equal just Note 2. For example, I was interested in testing whether if the Note 2 sound file was working, and so inside playSound, I decided to set selected sound file name to Note 2, which then gets passed in as the resource that gets played. So now if I run my app, you can see that it's now broken. All the buttons are now playing Note 2. And this is the equivalent of your neighbors taking apples from the communal apple tree. You have no control over who gets to pick that apple tree. And if you happen to have that greedy neighbor who happens to pick all the nice apples and leaves the apple tree in a bad state for everybody else, then you have to live with it. But we don't have to live with it in programming. We can instead use local variables wherever we can. So how do we do that? Let's get rid of this line. And instead of having a global variable, so let's delete that one as well. So now we have a problem. How do we pass the information that's contained here, namely which button was pressed, over to this function called playSound and get it to play the right sound file? Well, do you remember in the last module, we spoke about functions that have inputs. So this is where it's going to come in handy. Play sound can expect an input in the form of text, i.e. the text of the resource file that we want to play. Instead of using this global variable selected sound file name, or using a hard-coded version like note1, what we're going to do is we're going to pass in an input into this function play sound, and then slot that input into here. Let me show you how we do this. So I'm going to call it sound file name. So that's the name of the input, and it's going to be of type string. Then I'm going to pass that input name or parameter name into here, sound file name. So you can see now we've got this error here, and that's because we're calling play sound with no input, whereas play sound now expects an input in the form of a sound file name. And that sound file name is exactly this. Remember, we use the sender.tag to figure out which button was pressed, and then we use that number to pick out the right file name from the sound array. So essentially, this is the sound file name. Let's give it sound file name. Remember, we have to give it the name of the input, the parameter, and then the value is going to be this. So let's just move that into here and get rid of this line altogether. So now we don't have a global variable. We're not even using a local variable because we can't use that local variable to pass the information from note pressed to play sound. So instead we're using a function that takes an input called sound file name and puts it into the resource. So if I run the app again, you can see that the app is working again as expected. So the lesson learned here is that try to avoid using global variables where you can use local variables or using inputs through the function, just as we did here. And usually when you're programming a large project with thousands of lines of code, your global variables can stack up pretty quickly, becoming very confusing. Also, having this global variable, which can be changed anywhere in the code file, when there's an error, it will take hours and hours of digging around to try and find where it was changed inappropriately or what happened to it. To summarize, essentially, keep your apple tree within your own garden if you can. Try to avoid having these global variables where anybody can tap into, creating confusion, creating chaos, and therefore error. So that was a quick intro into scope and global and local variables, and we'll be seeing a lot more of those global and local variables in the coming tutorials. And I've included a link to some interesting reading from the Swift programming language book in the text box below. So if you're interested in reading up more about global and local variables in Swift, have a look over there. And I'll see you on the next module.